everyone, hope you all are having an amazing day. To make your day even more interesting, we at Intellipaat have come up with a live session on Java, conducted by multiple experts who are having more than 15 plus years of industry experience. Before we begin the session, make sure to subscribe to our channel and also like our videos so that it will motivate us to come up with more such live sessions in future as well. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Java. In that, we will tell you what is Java and why one has to learn it. After that, we will explain you few concepts of Java like statement, objects, classes and lot more. Then post that, we will learn the very interesting topic of Java, that is encapsulation and inheritance. After that, we will move on to Java Beans and Hibernate. And also we will tell you the architecture and applications of Hibernate. Post that, we will tell you what is ORM and what are the advantages of ORM. Then after that, we will tell you what is exception and how to handle it. Then later on, we will tell you what is synchronization in Java and also give you all the information about Java servlets. Then finally, we have covered the difference between Java and JavaScript. And also we will be telling the Java interview questions and answers. So guys, this is the agenda of the video. Without any further delay, let's get started.
Let's start about Java. So let's get a little bit of brief understanding about Java. So Java is one of the most popular languages, that was created in the year 1996. Now it was created for many different purposes. We'll talk about those purposes. Like it has been one of the most popular languages since the year 1996. Even in this, year of 2020, it's still popular and it's still being used even after 20 years. So you can see how popular it is and how useful it is for a lot of people. And it has around 10 million developers worldwide. There have been a lot of people using this, from creating small things to big things, and a lot of people have been using it from around the world. It can be used for creating small applications for smaller devices, or it can be used for creating entire enterprise applications themselves. So what is Java? Now Java is a high-level language which was developed by Sun Microsystem in the year of 1996. It was developed by a team led by James Gosling. Now, it borrowed a lot of concepts from a very popular language at that time. In the year 1996, C++ was one of the most used languages, and it borrowed a lot of concepts from it. And it obviously improved upon all of those concepts. Now, in many ways, which was the main aim for Java's development. Now, it not only acts as a platform for development of applications, but also as a runtime environment. And what that is, we will talk about. Alright, so now let's talk about why was Java created. Let's go into a little bit more detail. So Java was created for one of the main important reasons here, that it needed a cross-platform language for multi-device development. At the time of its conception, there was a need for a cross-platform language that could be used for multi-device development, which was also efficient to use. Now, though the developers could make use of C++, which was an object-oriented language and was the most commonly used language at the time, it was, very resource-intensive. The developers usually required to manage the memory by themselves. Normally, Microsoft Visual Studio required megabytes to run a simple command such as printing the string "Hello World." Hence, there was a need for a language whose runtime environment wouldn't require a lot of space on the target device. There was also a need for a portability across different platforms, which couldn't be achieved through C++ at that time. It behaved differently in different environments. C++ had to be rewritten for each different devices. If you had, Mac, Linux, or Windows, you had to rewrite, C++ code for each of these operating systems, because each operating systems had different architectures and they would behave differently once that C++ code had been run on them. And there was a need for creating a new language which could be written once and used everywhere, right? So that was one of the reasons why Java was developed. So guys, these are the main three reasons. It was created because there was a need for a cross-platform language. It was created because the most popular language at that time was very resource intensive and they needed a language which was more efficient than it. And it was developed with the aim of write once and run everywhere. So what does this mean? Write once and run everywhere. This basically means that the Java was created with the mindset of having a language that could be written only once and be used anywhere. Now we know that C++ had to be rewritten for all the different platforms, right? But Java can be written only once and it just has to be run in using specific JVMs in all of those specific operating systems. So how is it, platform independent? Let's talk about that. How is it platform independent? Java. So the traditional model, what happens in a traditional higher language like C++ or C is that code is written here. The code that is written here is converted into native code that is basically machine code that the CPU understands, and because of this all of the issues start happening. Because each embedded devices have their own CPUs, right? They have their own architectures, own operating systems, and because of this the execution of code has different results on each of these different devices. So how the Sun Microsystems company resolved this issue was that they first compiled the code into bytecode, which would then be later run on Java virtual machines or JVM. So that is your Java programming model, where source code is converted into bytecode and then it is sent to a specific JVM. Now we know that each operating system has different JVMs. Windows has its own JVM, Linux has its own JVM, and Mac has its own JVM. So you write the code once, that is your source code, you convert it into bytecode, and then you can shift it to any of the operating systems. All you have to do is just have the specific JVM on those operating systems. So what is JVM? Now JVM is used, it is basically specific to each different operating system, and all of those operating systems have their own JVM. It's basically a virtual machine that allowed for a consistent environment across both the operating systems, removing any excess issues that arise from having to having to use different OSs or different CPUs. So it resolved that because it was a virtual machine, it could simulate a very similar environment across all the different machines. So the source code was converted into bytecode, and the bytecode was run on a specific machine, and hence the whole write once and run anywhere comes. You have one Java file, and that can be written only once, but it can be run anywhere on different host systems. Alright, so what is JVM, JRE, and JDK? Let's talk about these three things. Now we hear this a lot when we talk about Java. So let's start with JVM. We already know what JVM is. JVM is, it's a virtual machine that runs on the host. Depending on what host it is, you'll have the specific JVM. And it helps in executing the Java bytecode on that host machine. Then you have JRE, whose full form is Java Runtime Environment. Now it's a runtime environment which provides all the necessary libraries for the Java code to run along with JVM for running the Java bytecode. Now then let's talk about JDK. Now JDK is Java Development Kit. So it is used for developing Java apps, any kind of app. It provides a Java compiler as well as JRE. It comes bundled with it. It's like an envelope that has everything that is necessary for creating an executable and running your code. So guys, these are JVM, JRE, and JDK. Now let's discuss the features of Java. Alright, so we have first feature, that is platform independent. We just saw this in our discussion of JVM. JVM is a virtual machine that provides a consistent environment for Java code to be executed across all platforms. So as long as you have a dedicated JVM on your host, you will be able to run Java code no matter on which platform. It is compiled and interpreted. So languages like C++ and Pascal compile their source code into object code. Then the linker converts the object code into executable, and when you run the executable in a loader in an operating system, it loads the executable into the memory and resolves any functional references, and only then it executes the code. So it takes it's a very long process and it's not very efficient. But in Java, the case is completely different. Java compiler compiles the source code into bytecode first. The bytecode then is almost like instructions for CPU that is then used in JVM, and there is no linker process involved at all. So when we run the Java executable on the machine, the interpreter converts the bytecode into machine code. So Java is first compiled into byte code and then interpreted line by line. This results in faster execution. But it's still not optimized as much as the C++ compiler, even though it's not as much as optimized. It's been 20 years and people have been working on it so much that they've eventually made it that fast, catch up to C++ compiler. Then we have object oriented. Now we know that C++ is also an object oriented language, and so is Java. Java is an object oriented language. It's an object oriented language. Now object oriented it's a technique for programming that focuses on data an object and the interfaces of that object. It is a type of design that believes in interaction of object rather than action. Dynamic. Another key feature of Java is that it is very dynamic in nature. We have seen that Java's source code always gets converted into bytecode first, which has the dot class extension. So running a Java code can load a compile time running dot class file, which it actually understands, and then it instantiates it and then uses it for its own purpose. This process is known as introspection and reflection. That is the dynamic nature present in Java. Robust and secure. So Java is robust and secure. So the introduction of JVM or Java Virtual Machine into the architecture of any system helped the developer in creating a more secure and robust Java application. As we discussed, the bytecode is first interpreted by the JVM, and the JVM contain a bytecode verifier which not only checked for validity of the bytecode but also maintain the integrity of the memory space which is used by the app that is running on it. If bytecode was invalid, the JVM would simply refuse to run it. If it doesn't match, then JVM will simply refuse to run it at all. Or if the bytecode tried to access a memory location that was outside of its mount, then JVM will again reject it. And that way it was very robust and very secure, as it would not allow a potential virus to spread on a target machine, as Java code that runs on the machine does not have direct access to the operating system's resources at all, and only it has access to resources through the JVM. So JVM stops any malicious attempts on the system. Multi-threaded. So C++ was one of the multi-threaded languages, but the approach that Java followed of adding synchronized keywords and adding block of code that acted like a shared resource made multi-threading in Java way more easier, which was the key attraction of it. Alright guys, so these are the different features of Java. Now let's talk about the evolution of Java. How has Java evolved over the years? So we have the first ever created version of Java, which is called JDK 1.0. It was created in the year 1996, and it's been like 20 years since then, and they have kept on releasing new versions of Java over the years, and the names have also changed. So you can see that the next version was JDK 1.1, which released in 1997, and the next version was J2SE 1.2, which is basically Java 2 Standard Edition 1.2, which was released in 1998. And you had similar versions releasing in 2000, 2002, and 2004. And here's again where the naming convention changed, where they started to name it Java SE instead of just Java 2 SE. So it's just called Java Standard Edition, and it was Java Standard Edition came out in 2006. Then you have Java SE 7, Java SE 8, Java SE 9, 11, and you have more versions that have been released so far. You have 13, 14, and 14 is the latest version of the Java that is being used. Okay guys, now we will go ahead and set up the Java environment so we can start using it, alright, and understand better about it. So let me head to my browser. Okay, so first what we're going to do is we're going to install the JDK, that is Java development kit. So I'm going to type in here JDK download, and I'm going to go ahead and install the latest of JDK. So I'm going to click on Java SE for oracle.com, and I'm going to click on JDK download. As you can see, JDK 14 is the latest kit, and we can scroll down and check out Windows 64 installer. I'm going to click over here and click on I've reviewed and accepted the terms and conditions, then click on download JDK. Then click on save, and then we'll wait for the JDK to get installed. Now I already have JDK 14 installed on my system, so we're just gonna go ahead and show you quickly how it works. Okay, once you downloaded the .exe file, you can go ahead and click on it. It will start opening JDK. Click on yes. So guys, it says that software has already been installed. Would you like to reinstall it? So just for you guys, I'm going to click on yes, and it will start trying to install. Alright guys, we have downloaded the Java 14, JDK 14, but there are other JDKs also. You have JDK 8 and 11, which have long-term support. So they're the ones that are normally used in industry for keeping standards and consistency. because they have long-term support, but JDK 14 will be obsolete as soon as JDK 15 comes out. So this is just for practice. Like in an industry, you'll be working with a very specific JDK version. So let me just click on next, then we'll click on next again, then we'll wait for download, install. Okay, while it's installing, what we can do is we can go ahead and install our IDE. Now that's an integrated development environment that we will need to use. So let me just type in here IntelliJ. This is the IDE that I'm going to be using. So you can click on download over here. That's the first link you get, and you can use this for working with Java. You can for JVM and Android development, so you need to click this one, and it's the community version, so just click on download and it will start downloading the JVM, the IDE for you. So I already have it, so I'm not going to install it again because this installing IntelliJ is a very long process. So cancel that. Let's see if this process is done or not. Okay, we're gonna fast forward this. Okay, now it's installed, so I'm just gonna click on close. Okay, now we have installed JDK 14. To check it out, what we can do is you can open up your folder explorer, head to your C drive, head to program files. In program files, look for Java. You find Java over here, and you can see I have two JDKs. I have 12 and I have 14, so I'm going to click on 14 because that's the one I'm going to be using, and click on bin, and you will be able to find the java.exe over here. All right, so we're not going to be directly using it. This is just installing the JDK. We'll be using an integrated development environment to write our code and execute our code and build our code, and that is our IntelliJ, right? So let me first go ahead and take it out. Now guys, before I do take them out, I want to show you one more thing. Now we have a lot of different other available integrated development environments out there. You have IntelliJ IDEA, that is the one we are going to be using. Then you have Eclipse, IBM WebSphere, Oracle J Developer, and Sun Microsystem has its own Java development environment. So you can use any of these. The one I'm going to be using is IntelliJ, so let me go ahead and open that up. Okay guys, now we see that IntelliJ IDEA has opened up. What we can do is we can click on create a new project. That's how we will be working. So let me click on create a new project. Okay guys, so I'm going to be selecting Java over here because it will directly detect the JDK version that we've installed. You can change it if you want, add a JDK, but we'll leave it to JDK 14. That's the one we want to use. Then click on next over here. Again next, and now we need to give this thing a name. So I'm going to give this name my package. So this is the name I want to give it. Project name is my package. Then click on finish, and it should start opening up our project. Let me just full screen it over here. Okay guys, so this is a working environment. Let me click on project over here, and this will open the directory. Okay guys, so this is our directory over here. In our directory, you can see there are a lot of things. We have my package, the source, and external libraries. So what we need to do is we need to first click on src, that is the source, and right click it and click on new, and then we're going to click on package, and I'm going to name this my package again. Then I'm going to press enter. Okay. So as you can see, my package has opened up, and over here we can right click again and new, and then click on Java class. So here we're going to be, basically this is the place we will be writing our code. So I'm going to give this name, so my first code. Okay, then I'm going to press enter. Okay, so now we have basically the place where we write our code, that is my first code.java, and over here we'll basically be writing all of our code, right? So guys, we have some basic code already written over here. Package, my package, colon and semicolon, and then we have public class my first code. So let me start this out by writing a very simple command. Okay guys, now we will go ahead and run our first Java program. Alright, so the program we will run is this one over here. It's a simple printout statement that says hello world. So let me go ahead and paste this into our IDE. Okay, I'm gonna go ahead and paste this over here. Okay, so as we can see, public static void main strings arguments system.out.println hello world. So let's go ahead and run this first before we analyze each sentence one by one, each command. Okay, so I'm going to click on build project. So as you can see, it's building the project over here. It's parsing, and once it's done building, you can see a new directory has been created over here that is called out. If you drop down production, you can see a folder called my package, which is similar to the name of our directory. And we can open this up again, and we can see my package again, and we can see my first code dot class. Now this is our basically a bytecode. So when we build our Java code, it has been converted into bytecode, and with that it has created a file called my first code dot class, which all bytecodes are basically stored as dot class files. And whenever we write a code, they are stored as my first .java. So any code you write will be stored as .java. Any code that has been compiled, built, it will be stored as .class. All right. So now that we have built this project, we can go ahead and run it. So I will click on run over here. Now you can either use the Alt Shift F10 or just click on run over here. So I'm gonna click on run, and my first code itself. Okay. So now it's building it, and it's going to start running it also. Okay, so now you can see that it has finished running the code, and we have our output in the terminal over here, that is hello world. So we successfully ran our code. Now the program has been compiled and it has been run, and now let's try to make a small change. Now we know that it prints out statements that are under this particular command, so we can try and add something. I'm going to type in hello world and hello to all the beings in the universe. So if I run it, I should see this also in my output. So I'm going to click on this again, directly run this particular block, this particular file, and it's running it, parsing Java, finished, and we can see the new output over here, hello world and hello to all the beings in the universe. So guys, this is how you would build your code, and this is how you would run your code. And this is your .class file, that is your bytecode. So program has been compiled and it has been run. So now let's start analyzing each part of this code. So we'll start off by something called package. Now package basically specifies the package of the program. It basically means that our Java code is under the directory with this name, that is my package. Now if I change it to something else, it's going to give me a slight error. So I'm going to change it to demo. You can see it's giving me an error, but I can correct this. I can set the package name to my package, or I can move the whole code to package demo. So these are basically packages. So if I click on move the package to demo, it will create a new package and we'll call it demo, but I don't want that, so I'm gonna go ahead and leave it my package. So over here guys, we can see that we have my package. This is the name of the package, and under which we have the code. And similarly, even in the my bytecode, we have my package, which is the name of the package. So after compilation, we have the .class file also produced, and it is also stored in the package. So package is basically telling us, the name of the directory. If we create another file, we will see all the changes that start to happen. So if you want to create a new package, what I can do is I can right click on source, go to new, and we're going to click on package again. Now this time I'm going to give this name my first project. I will call it actually my project dot demo, and then I'm going to press enter. Okay, so when I type in that, I can see my package has been created over here. This is the new package, and under this I can go ahead and create any new Java class files or normal files or scratch file that I may want to. So we don't need this. I just want to show you if you can create any extra packages or not. So I'm going to delete this. Yes. So now that it has been deleted. So guys, that's what packages are. So now let's move on to the next part of our code, that is comments. So what are comments in the Java program? Now comments basically tell a compiler that this particular part of the code is not it's not to be considered, it's to be ignored. So as you can see, I have all these parts of my code highlighted in some way or the other. So if I want to add a comment, I can add the comment by writing /* and then enter. As you can see, it automatically created the end of the comment line, that is star and backward slash, and I can write anything over here, that is anything, and author name is Ram. Now you will not see any error over here because the compiler is completely going to ignore this. But if I write the same thing over here, then it does not make any sense to the compiler. It will think it's an error. My name is Ram, and you can see that there is an error over here. So this is what the comments do. They basically help you write things into your code that will be ignored by the compiler. Now you might be thinking, where is this used? Now this is used in cases where you want to understand your code later. So suppose I have written this code where it tells me that this is the output string, but if I come back and check this code after a very long time, I may not understand this. But this is very simple, so I can understand it. But what if it was a very complex code? Then I wouldn't understand it. So to understand that, I would write a comment to explain to my future self. Now there are two types of comments. You have the slash star star slash. So yeah, so you have this comment. You can write whatever you want in this, and you have these are called multi-line comments, where you can write comments in multiple lines. So, and it still doesn't consider it. Now there's something called single line comments, where you write 2 slashes and you write whatever you want. This command helps you print hello world. Now if I tried multi-line in this, if I try to write another part of this comment, so if I wrote hello over here, it will consider this as a part of the code. And that's why you use multi-line commenting when you want to write a big passage, and if you just want to write one sentence, you use the single line commenting. So guys, these are what comments are. This is what comments help us to do. They also help us to basically help other people understand the code. If someone else is looking at a code and they want to understand what this particular command does, then comments are a very good way to explain to them. All right. So now let's talk about the next part, that is the reserved words. Now reserved words or keywords are words that have a specific meaning to the compiler and cannot be used for any other purpose in the program. Now you cannot use it for like any other purpose, like such as like defining a variable or anything. So they have a very specific use case. So as you can see, if let me just remove all this useless commands. I'll just leave these two over here. Yeah, so as you can see, there are a few things highlighted over here. Like we have package being highlighted, we have public class being highlighted, we have public class void being highlighted. So guys, these are your reserved words. They're keywords. They have specific meaning to the compiler. So public class gives meaning to the compiler that my first code is a class. It tells the compiler that this is a class. And public static void tells that main that it is a static method. And my package tells it that this is the name of the package. So these are reserved words. Now if you were to use two different if you used two different keywords together, if I typed in int and package, you can see that this is a definite error for the compiler. It's giving the red squiggly line, which means that it's an error. So guys, this is what the reserved words are used for, the keywords are used for, right? They give a specific definition to specific objects, and they have some kind of meaning to the compiler. We will get to know more about this when we get into coding even more. So now let's go to the next part of our program, that is statements. Now statements represent an action or a sequence of actions. For example, we have one line of code over here, that is system.out.println hello world. So this is a statement. Now this statement has a consequence. The consequence is that it basically prints hello world and whatever string is inside it. So since it's able to do that, it means that it's a statement. So again, anything that has an action or a sequence of actions is a statement. Now every statement ends with a semicolon. So this is a statement over here. Now let's move on to the next part of this code, that is blocks. Now a pair of braces, that are your curly braces, forms a block that groups the components of a program. So if we come back to our IDE over here, you can see there are many different curly braces. We have two sets of them. We have the first set, and as I click on one of them, as I click near one of them, I can see that the other part, the complement of this particular brace has been highlighted. So anything that is under these two curly braces is a block. Like you can imagine it as a block of code or a brick of code, like a lot of code that is being grouped together. So here we have the second set of curly braces. So anything inside these two curly braces will also be a block. This is a block and this is another block. If I wanted to add another statement inside this, if I add over here another curly brace and I write in here int var equals to 10, then this is my third block. Alright, so these are basically scopes of your code. These are what blocks help you do. They help you to organize and separate parts of your code. Okay, so now we understand what blocks are. Let's move on to the next thing, that is class. Now class are they basically help you to give the blueprint of all objects. Now let me come back. Class is something a bit more complicated, so just get a small idea of what it is. So here we have my first code. Now my first code is a class. Now any object created for this class will have this blueprint. So if I create an object called T, that T if it's an object of my first code, that it means that it has all the elements of my first code. So basically my first code is a blueprint for any objects that are created with it in mind. So they're basically like skeletons or blueprints. Just keep that in mind. When we get a little bit more deeper into Java, we'll understand what class is and what object-oriented programming is, alright?
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object-oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So now let's move on to the next part of the code. What is the next thing? That is, these are methods. Now, methods are basically a function call for performing some specific operations and takes in some inputs and returns an output. Now, again, we're going to use the same example over here, guys. We have system.out.println. So what is this statement exactly? Now we know we are printing something, right? So how are we printing this? We are printing this by using a function, that is println, right? So this is a function that is present in one of Java's libraries, and we are calling it to help us print this. And this function is called a method. You can have different kinds of methods that help you to perform complex problems. Like you can create your own methods also. Now this is also a method. This is the main method. We'll talk about this later. But methods basically are anything that can be referenced later. So if I write my name, if I write void my name, and inside of this I write int a, then this is a function that can be called later. I can call this later. I can type my name and I am calling it later. So this is basically something you can call and use its functionality. So these are methods. Now the next thing is main methods. So now main methods acts as a starting point of a program. So anytime you want to start a program, you need to write the main method. That is, this is main strings arguments, and it takes in string array as inputs parameter, and you can see an example of it. That is the one we have written over here. Alright, so these are different parts of our code. We have now analyzed it and we know how to build it and run our code. So now let's move on to the next thing. Language fundamentals. So in language fundamentals, we will start off by learning about identifiers. Now what are identifiers? Now there are the names that we use for defining a class, variables and such. So names used for classes, methods, interfaces and variables are called identifiers. All identifiers must start with either a letter, currency character or connecting character like underscore. So let me come back to the IDE to show you what an identifier is. So I come back here and we can see that my first code is an identifier. It is an identifier of the class my first code. Now let me give you another example. I will write in a variable over here. I'm going to type in int underscore var. So I am declaring a variable and I'm giving it value 10. So here my my underscore var is my identifier. Now there are specific rules in which how you use these variables and how you use these identifiers, and there are many rules. One of the rules is that you can these identifiers, they start with letters, they can start with currency character, or they can start with a connecting character like underscore. A Java keyword cannot be used as an identifier. What this means is that instead of writing underscore var, I cannot use any of the reserve words or the keywords. So if I wanted to use class, I cannot do it because class is already used as a keyword. So this will give me a definite error. As you can see, it's already giving me an error over here. It's asking me to remove the expression, and I can do that. But so that's what you can't use keywords at all. So I'm gonna leave it underscore var. And identifiers in Java are case sensitive. So what this basically means is that whenever you are writing a particular variable or anything, you are uniquely identifying it with that name that you've given it. So since you're uniquely identifying it, it has case sensitiveness. So if I write int underscore capital V AR equal to 15, then these two variables are different variables. They have different identifiers for them. This has a capital V and this has no V. So they are counted as separate since they are case sensitive. Okay, so now let's discuss variables and constants. So what are these variables that we have been discussing? So we'll see how to declare variables, how to assign values to variables, how to declare and initialize together, and how to create constants. So let me come back and let's take this example again. So here what I'm doing is I am declaring a variable. Declaring a variable basically means that you're assigning the type of variable it's going to be. So let me just remove this and give you guys another simpler example. So there are different kinds of variables. You have integer variables that store numerical value. You have char variables that store character value. And let's create some of them. So I'm going to say int a. So a is a variable, and since I've written int before it, I am trying to say that a will store numerical value. So I will end it with a semicolon, and then I'm going to write char and char b. So what this basically means is that b will have character values. It will not have numerical values, right? And I can do the same thing with string, and I'm going to name this f. So here again, guys, we are basically declaring f as a string variable. It is going to store string values. That is equal to, if I write hello world, that means this variable is a variable that stores string values. So guys, this is declaring variables. You declare them by telling the compiler what kind of variables these are. And now let's talk about assigning values to the variables. Now we have declared these variables. Now we want to assign values to these variables. So assigning value is basically giving them some sort of value. So I'm going to write here a equal to 10. So we have already declared it. Always make sure that you declare a variable before you assign any value to it. Otherwise it's going to give you an error. Now I want to name b, actually I want to assign b the value of 20. And I'm going to give f the value hello my friends. So here I've given values to all of my variables. I've assigned values to all of these variables, all these different variables. Now this is how you would go ahead and do the assigning part. But what you can do is, instead of writing it separately, you can do all of this together also. That is your declare and initialize. So I'm gonna take this equal to 10, copy it, I'm gonna put this here. I'm going to take equal to 20, I'm going to cut this and put this here, and then f equal to hello my friends, I'm going to cut this and put this here. So basically, instead of doing it separately, I'm doing this together. I am declaring the type of variable it is, and I'm giving it some value. I'm storing some value. So now let's talk about creating constants. So here we know that a equals to 10, but what we can do is we can change the value of a equal to 35, suppose, right? So I've given a equal to 35. So what will happen in this code is, since it happens line by line, right? So first value of a will be 10. That's its first value. But when the compiler reaches a equals to 35, it will replace a's value from 10 to 35. So the value of A is changing. It's not constant. What happens when I want to make sure that A remains same? It remains equal to 10. To do that, we have to use a specific syntax. So let me remove this, and in front of int, I'm gonna write final int. Now final int and then const. So this will tell my compiler that A is supposed to be a constant variable. Actually guys, we do not need const over here. This is not the correct syntax. The correct syntax is using final int A equal to 10. Okay, so now we have created a constant variable called A. So since we have told the compiler that A should remain constant with the value of 10, if you try to change its value anytime later in the code, it is going to give us an error. So let me try that. Let me show you what will happen. So if I write A equal to 50 here now, you can see that there's a red squiggly line, which means that there is an error. If we look at the error over here, I can see that it tells me that cannot assign a value to final variable A, which means that A is constant and you cannot assign any more values to it. So guys, this is how you would declare, initialize, assign values to variables and create constant variables. All right. So now let's move on to the next thing, that is encoding sets. So what are encoding sets, right? So you have ASCII, which is basically American Standard Code for Information Interchange. So it basically represents in 8 bits and represent all English alphabets and punctuation. So it's basically used for, writing your variables and etc. all for those purposes. The thing is, you can use before the starting standard was the ASCII standard, that is the American Standard Code for Information Interchange. But what happened was you couldn't include any of the different languages or British pound symbol, right? So to do that, we came up with another encoding set standard, that was the International Standards Organization. They came up with ISO 88591. Now this was again for 8 bits and it contained all the characters required for all Western languages. You had Russian, you had Portuguese, you had French, and they were all included in ISO 88591. Now later what happened, like there was again a problem with this also, like it didn't contain all the languages in the world. So that's when we came up with Unicode. It was developed by the Unicode Consortium. It accommodates all characters of all the languages in the world and it uses 16 bits for every character. So every character is represented by 16 bits. Now this is again great because all languages are being incorporated, but again this is 16 bits for every character, and that's a lot of memory to be used for it. So initially it used 16 bits to represent each and every character, but this was the problem. So they tried to come up with another solution for it, and that's when they came up with the next encoding set, that is UTF-8. Now UTF-8, the unique thing about it is that every character in UTF-8 has it is encoded in 1 byte. So it's way more efficient than your Unicode. So but again the problem was that it was only suitable for text having Latin letters. It didn't include any of the Chinese or Hindi letters, right? So then came UTF-16. Now it was commonly used characters that are encoded in 2 bytes. Now less common characters are encoded as pairs of 16-bit code units. Then you have UTF-32, uses 32 bits for every single character, and since it's so big, it uses 32 bits for every character. It's not a very great choice when you're working with internet applications. So guys, these are the different encoding sets. Now let's start talking about separators. What are separators? As we can see in this table, we have many different things over here. We have dot, comma, semicolon, braces, and parentheses, close brackets, square brackets, and colon. So what are all of these different things? So they are what the name suggests, they're separators. So if you start with period or dot, it basically refers to methods or fields of objects. Let's see this in our IDE. So in our code over here, we see a great example for this, that is system.out.println. So you can see the dot, right? It helps us to refer to a particular method. So that's what the dot is being used here for. Now let's talk about the comma. So commas are basically used to separate any arguments in any methods. So if we come back again, you can see that this is a method, that is main is the method which has one argument. But what if we wanted to add a second argument? To do that, we will need to add a comma over here and then add in any particular variable, any declaration we wanted. So if I wanted integer parameter, if you want any parameter, so I'm going to write in here integer, and I'm going to give this a. So this is how I would go ahead and do it. I would use the comma over here. Then comes the semicolon, which is again used to terminate statements. We terminated this statement using semicolon over here. Again, we use semicolons for terminating all the statements. Then we have braces, which are used for declaring arrays and blocks. So you have blocks over here, and to declare those blocks, you need to use the curly braces. Then you have parentheses. These are to evaluate conditions, method signatures to contain the list of arguments, narrowing conversions. So to evaluate, so we have parentheses over here. As you can see in the method, you use these parentheses to mention any parameters there might be. So if you want to add any argument in a particular method, you make use of these parentheses. You use them in a lot of different places also. Then you have again square brackets. They're used in declaring arrays. So let's get into it. So how do you declare arrays? Now what are arrays? Arrays are different than variables. Variables are single, there's like, just imagine them as like being a variable is having one person, but being in an array you having 10 persons, or how many persons you decide to have. So let's declare and initialize it. So I'm going to type in int.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below, and you can go check it out. Now let's continue with this session.
So this array is going to be an integer array, a equal to new int. So it's already giving me a suggestion for the close brackets, and here I can type in 10 there. So this is how you would declare an array using the close brackets. Then you have these parameters that pass parameters to parameterized types, and finally you have colons, which is used for loops. So let's see how it happens in loops. So let's take a for loops. Now getting into it completely will be difficult, but just understand that for loops are used for iteration purposes. If you want to iterate one statement again and again, you can use for loops for that. So let me type in for. Again, we're making use of parentheses. I'm going to type in variable declaration. I'm going to use the variable declared before f. Then I'm going to use colon m. So it's going to cycle through my string over here m number of times. Alright, so if I declared m equal to 2, it will cycle through my string twice. Okay guys, now let's move on to the next topic, that is primitives. So primitives basically help us to understand the different types of declaration we can do for a particular variable. You have many different types. You have Boolean. So Boolean is basically your true or false, 1 or 0. If you want to assign a true or false value, then you use Boolean type. Then you have byte, which is basically integer. So byte, short, int, long, float, and double. These are all basically used to represent numerical values. Now each of these declarations has some kind of range to them. So you're using byte, you have from -127 to +27 as the range of numbers you can include. With short you have plus or minus 32,000. For int you have plus 2 billion characters. And again, similarly with long and float and double, you have very large values if you want to use them. And again, you have finally char. Now char is used for storing integers. So guys, these are all the different primitives. They're basically the non-objects in Java. Alright, so let's check out the next thing, that is primitive conversions. So you have two types of conversions. You have widening conversions and you have narrowing conversions. So widening conversions is basically converting from a shorter primitive to a bigger primitive. So byte is a shorter primitive because, like we saw before, it had only a range of 127, right? -127 to +27. So if you're converting byte to long, now long has like a very large range, then you're doing a widening conversion. Similarly, int to long and float to double. So then you have narrowing conversions, that is basically changing a type from like a big type to a smaller type. So short to byte, or int to short byte, or double to float. So guys, these are different types of conversions. And finally, operators. So let's quickly go through what are the different operators. You have unary operators. They are basically plus or minus. So they basically tell what kind of operation is going to happen on a particular variable. So if I write over here a and I type in plus plus semicolon, this means that a value of 1 is going to be added to whatever numerical value is in a. Similarly with minus minus also. So these are your unary operators. You can have them postfix and prefix. Then you have arithmetic operators, which is kind of easy to understand. That is your multiplication, division, and percentage calculation, right? Sorry, my bad, it's not percentage, it's remainder calculation. Then you have addition and subtraction also. Then you have your shift operator, then you have relational operator, bitwise operator, logical operator, and ternary operator, and assignment operators. You have different kinds of operators that help you perform different kinds of actions between different variables and even within those variables also.
Now, if statement, the syntax of the statement is either of these two. You basically check a Boolean expression followed by the if, and then you have some statements written there. And the other example is that you check for a Boolean expression and then you write a sequence of statements. Everything is then followed by else and these statements, and these are included in the braces. So let's take an example of how do we write the if statement. So I've taken a class demo class here. So I'm writing a main method here. Alright, so let us take an integer and let's give it a name I. We'll assign some value 10 to it. So one of the ways of writing a if loop is we'll check if I is greater than 5, we'll print a line inside if. Okay, so this is a program that we have written, and we are just writing as of now an if loop. We are checking if the value of I is greater than 5. If it is greater than 5, then it will go inside the loop and will print this statement. So let's run this program. So as you can see, the output of the program is commas inside if. Now the other thing is, say for example, if the condition here is not getting satisfied, and we would want to write a default block that handles the other condition. The option of doing that is else statement. So let's take an example of this I variable only. Let's say that if I is supposed to be checked as less than 5, so the control won't go into this block. Now because of writing this if, the control will go into this block. So here is an example. Now the control will go inside else block. Now let's run this program. So you can see the output of the program is inside else. So this is one of the other examples. Now the case could be that I can have an option of testing if the value of I is less than 5. I just want to check that if it is say less than 7. I have a use case of verifying that as well. So let me just say, in that case the option would be I can write another if block which is followed by else, so it becomes an else if, and I can check my condition here, and then everything else could be followed by else block. I can write as many number of else if blocks as possible. So I'm just writing for the sake of demo here. And I'll follow everything with an else block. So I'll just give a value here inside if else. I'll say 1, inside if else 2, and inside else block. Now depending upon the values of I, the control would be going in either of the blocks. We'll start with the case of I is equals to 10, I'll run the program. So you can see the output has gone, the control has gone to the else block. So that is the reason the output is coming as inside else. Now if the value of I is given as let's say 6, so in that case it is greater than 5, it won't go in this block. It is less than 7, so it will go in this block. You can also note that it is also less than 8, but the thing is that I have put this condition after the else block. So if this is not getting executed successfully, only in that case this would be evaluated. So the control would go now inside if else one block. So let's run now. So you can see the output is inside if else one. That is what we were expecting. Now if the value which we said is now let's say 7, now else if evaluation would be failing and the control would be going here. Because 7 is less than 8, the control would go here. Let's run this program, and the output expected here is inside if else 2. So you can see that is the output that we are getting here. And as we had kept previously, if I is kept as 10, the control would go inside the else block. So let's run that as well. So you can see the inside else is getting printed here. So this is all about writing and implementing the if else if conditions. Okay, now we are done with the if loop. Let's go and discuss what is the other thing, which is the while statement. So the syntax of the while statement is while you check a Boolean expression, and this is followed by curly braces, and which has all the statements in it. Now why do we need for a while loop? So we have couple of use cases, like say for example you have a stock ticking application, and it basically needs to pull the server every 3 seconds to get the latest updates on the stock. So what you can do is you can just put up a while loop here. You can put the Boolean expression as true, and in the statement you can just poll the server and then sleep for like 3 or 4 seconds. So that would what it'll do is it'll kind of always run. It'll poll the server in every 3 seconds. It'll sleep for that time. So that way you don't have to worry about writing that statement again and again. So this is like the usefulness of the while statement. Now let's quickly have a look at how do we write such statements in Java. So let me just clear this. Okay. So now what I've done is I've taken a variable again integer I. I'm doing checking a condition here that while I is less than say 15, I would want to say print a statement. Just saying that I'm inside the while loop, and I'll just keep incrementing the value of I by 1. So I'm expecting that this would print the value of inside while 5 times. So as you can see here that every time it goes inside the loop, it checks the value. So we'll start with I equal to 10, it goes inside the loop, it prints this inside while, it increments the value of I with 1, so now I becomes 11. It again checks, it is less than 15, yes, it prints again, increments again, it becomes 12, checks again. So in this way it goes on, and till I equal to 15 it goes. Then after incrementing at I equal to 15, the value becomes 16, and that's when the execution of this while loop stops. So this is one of the ways of implementing a while loop. The second way could be that, as I mentioned, that assume that you have a stock picking application, right? So I would want that while loop to be running again and again and again, I mean without checking for some condition. So for that what I can do is I can just say that while true, so that becomes this while loop would be executed always. I can just instead of saying get the information from the server, for that I'm just writing that system.out.println inside while, and because it's like a demo here, and for the sake of demo I just want to get out of this loop, so I'll just say break I'll check if say I becomes say 20. Just break out of this loop. I'll come to the explanation on break in a while, but for the time being assume that as soon as I value of I becomes 20, it will get out of this while loop. So for that reason I'm writing this condition, and I'll increment I by 1 every time. So again, as we had seen earlier, inside while should be printed now 10 times. So let me run the program. So you can see inside while is now coming 10 times. So this is the other way of writing the while loop. Okay, now let's move to the next statement. The next statement after while is the do while statement. So the only difference between a do while statement is that while executing a while statement, what happens is before entering into the loop, we check the Boolean expression. Now, unlike that, in do while, what happens is the execution goes inside the loop at least once. So I'll go inside the loop and then I'll check the condition, the Boolean expression inside the while. So that is the only difference between a while and a do while thing. Let us see how do we write that in a program. So I'll do one thing. I'll just make use of this example what I demoed for in the while loop. So I'll just tweak that a little bit. So initially what I had done was I was checking if the value of I was greater than 15, less than 15. It was going inside the loop. I was incrementing it, and that is how it was behaving. Now assume that in a scenario if I want this condition to be negated, okay, and
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
so whenever the while loop would be getting executed, the control will not go inside this while. So let me just show what I'm trying to explain here. So you can see that the control didn't go inside this. The reason was I is equal to 10 and it's not greater than 15. Now assume that I would have a scenario in which this I would desperately want this control to be going inside the loop. So the way to implement that would be implement a do while. So I'll write here do while. So what would happen is the control would now go inside this do while loop once, and then it would fail. Well, after incrementing the value of I'll check, and then it would fail. So let me run that now. So you can see now the statement is giving the values inside do while. So that is the only difference between a while and a do while loop. Alright, so let us go to the next statement now. So the next statement that we have is a for statement. So for is again used for iteration, and the syntax of a for statement is it first of all initializes a condition, then it checks for a particular Boolean expression, and then it updates the initializer. This is followed by the block of statements. So let's see how it is written in Java. Okay. As I mentioned that I'll be initializing something inside a for loop. I'll delete this variable as well. Now I'll say that for integer I is equals to say 0. I'll check that I should be less than say 5. I would want to increment my variable. The condition that I'll write is I'll write inside for loop, and I'll add the value of I so that we get to know how many times this is, the statement is getting executed. So let us run this program. Now you can see what happens is, for the first iteration, the value of I is equal to 0. It checks if it is less than 5. This becomes true. It then goes inside the loop. It says that inside for loop, and the value is getting printed as 0. It then updates the value of I. Then it again checks if the value of I is less than 5. Now in this iteration, the value of I is equal to 1, which is again less than 5. So it again goes inside the loop. It goes on till the value of I becomes 4. It again goes inside the for loop. Then it increments the value of I, which then becomes 5. Now the check I less than 5 fails in this iteration, and because of that it is now not printing that value, and the program gets completed. So that is one of the ways of writing a for loop. Now in this for loop we have these expressions that we have written. As I mentioned, that this is the initialization, this is the boolean expression, and this is in the update condition. So each of this is optional here. So by that, what I mean is I can declare my variable here. Okay, now it'll just check for the value of I. If it is less than 5, it'll increment the value of I and it'll print the loop. So the output would be same here. For the sake of showing a difference here, let me just put the value as 2 and this value as 4. Let us run this program. So you can see for I equal to 2, it goes inside the loop and prints the value as 2. In the next iteration, the value of I becomes 3, which is again less than 4, and it prints inside for loop with the value 3. In the next iteration, the value of I becomes 4, which is not less than 4, and hence the program is not printing this statement. So this is, as I mentioned, that this is one of the optional steps. Again, I less than 4, the boolean expression check is optional inside this for loop. I can remove this condition here, and what I can do is I can put this condition here and add a break statement. It takes you out of the loop iterations. So in this case, what would happen is I'm checking if the value of I is let me just say greater than 4. If value of I becomes greater than 4, the execution of this would stop. Again, for sake of changing this, I'm modifying the value of I here. So let us run the program. So you can see for the first iteration, the control goes inside the for loop. The value is getting printed as 1. In the next iteration, what would happen is the value of I is equals to 2 gets printed here. Similarly, everything goes till iteration 5. Now for iteration number 5, basically what is happening here is that after printing the value inside for loop and 5, it checks if the value of I is greater than 4. Now since 5 is greater than 4, the control comes out of this for loop, and hence we are not getting any value which is greater than 5 here. This is how the removal of the initialization and the boolean condition works. Even the increment condition, the update condition here, that is optional. I can just move everything inside this for loop, and that is exactly the same thing. So now even if I run the program, I'll get the output as a little bit different output is there, because initially what was happening was after the completion of the for loop, the update statement was happening. Now even in this particular case, what happens is this condition, the check for this condition, before that the increment is being done. So when I equal to 4 is proceeding in this loop, the value of I now becomes 5, which is greater than 4, and hence this breaks out of the loop. So that is the difference here between these two programs. But as you can see, all the conditions, every condition is optional here. So that is another way of writing a for loop. So after the loop statements that we have seen, next comes is the break statement. So what is a break statement? It's used for breaking from an enclosing for, while, do, and a switch statement. So that is the importance of the break statement. Assume that you're writing a loop. So we just saw some conditions here that there was this condition that we added a true condition inside a while loop that was going on and on forever, and then we just checked if the value of I was greater than 4, and we just wrote a statement like break. So the statement of execution was stopped there, and it comes out of the loop from there. So that is the syntax of writing break. Let us take some other examples of break as well. Okay, so as you can see that the last example of for loop that we saw here, in which we had not even initialized or incremented or evaluated, we used break to come out of this condition of this for loop. So what we are checking here is that if the value of I becomes 4, if the value of I becomes 4, come out of this for loop. That is what is happening here. That is what the importance of break is. One thing that we need to keep in our mind is that whenever we use a break, it just stops the execution of the loop of the enclosing for loop. There can be a scenario where I can have multiple for loops. So let's say that I'm having a for loop like for int I is equals to say 0, I is less than 5, I plus plus, and having another while loop, for loop inside that, like say for int j say is equals to 0, j is again less than 5, incrementing the value of j plus plus. So before using this break statement, let me show you what is the value of I and j that you'll be getting for loop. Okay, so let's run this program once. For the sake of simplicity, let's put some small values here. All right, so as expected, the output is we're getting like 9 rows out of it. The reason that is that, like, for each iteration of the outer for loop, the inner for loop is getting executed 3 times. That's the reason we are seeing this output. Now if I would want to get out of this this inner for loop, I can write a condition like that, if the value of j is, say, it becomes equal to 1, break out of this loop. Let's see what happens to the output now. Okay, I was supposed to check the condition here, so let's see the output now. So as you can see, what happens is, as soon as the value of j becomes 1, it breaks out of this inner for loop. Okay, this for loop gets broken. Because of that, the value of j equal to 2 is not getting printed here. All right, now as I mentioned that this break would get you out of the iterations from the enclosing for loop. So it is just getting out of this for loop, this one. It's not getting out of this thing. So that's the reason we are seeing like from the value of I as 0, 1 and 2. So it's not stopping here. Now what if we want to stop this particular execution? So for doing that, there is an option of providing labels. So label is like providing an alternative for any statement. It's basically used for marking that statement and sending the program control back to that particular line of code. So I can just say that this is like my test line. Okay, so this is how I am kind of labeling my outer for loop. Now I can just say that break test. So let's see what happens now. So Now as you can see that in the first iteration of the outer loop, the inner loop is getting executed 2 times. So as soon as the value of the variable j becomes 1, I come out of this for loop. Okay, I'm breaking out of this for loop, which is kind of marked by this label. So that is how we work with the break statement and labels. So this logic can be implemented if we have, like, another for loop outside the outer one. So we can again provide that a label, and the execution of the iterations would stop there. All right. So this is as far as the break statement goes. Now let's continue to the next one. So the next statement is the continue statement. Now it is almost like the break statement, but what happens inside break is the execution of the iterations inside the loop that stops and the control goes out. But in case of continue, what happens is whatever is followed by continue, that doesn't get executed and the next iteration starts. Okay, this is one of the examples of having a continue. So here what it is checking is that if inside this is the initialization of the for loop. Here it checks if the value of I becomes 6, I need to continue, and this system.out.println won't be printed. Let's take this example itself. All right, let's use a similar example. Now what we saw there. Let me indent it a bit. So this is what is happening. We are running a for loop here. The control is supposed to be running here for like 10 times, and it would print the value of I. Now assume that I'm not having this block of code of continue here, and for the sake of simplicity, again I'll just print it 5 times. So the value of I would be printed from 0 to 4. That is 5 executions are getting printed here. Now if I want one of the numbers not to get printed here, so what I can do is I can say that, say if I is equals to 2, continue. So as soon as I say continue, what would happen is the control would go to this for loop. It would not execute this statement, that is system.out.println. So now if we try to execute the same scenario, we won't be getting the value of I is equals to 2. So as you can see in the output now, the value 2 is missing. So that is the beauty of using a continue statement. Alright, so as I had mentioned that in case of break, there was an option of using label. So the option of label was used to break the execution and break the execution of a particular while or for loop, which is not the exact enclosing one, which is like the parent of the for loop or the while loop, which is having the break statement. So for that reason we used a label. So similar logic is kind of getting applied here as well in case of continue. So here what we do is here again we'll provide a label. So let's kind of extend this example. We'll take a similar example of whatever we had done earlier for the break statement. Okay, let's say that now we are having two for loops. Okay, again we'll just use the value line for int j is equals to 0, j is less than 5, increment j. Okay, so we'll say that if j is equal to 2, continue, and print the value. We'll print the value of I, which is the outer variable here, and we'll print the value of j, that is the inner variable. So we'll say that is the j, and the same statement we'll add here is the value of I. So let's kind of remove this thing first of all. Okay, and Instead of putting 5 here, let's put 3. So let's run this program. Now the expected outcome is we'll be seeing the value of j getting printed 9 times and I getting printed 3 times. So let's run that program. Okay, so you can see the value of j is getting printed 3 times, then the value of I is getting printed, then the value of j is getting printed again 3 times, and similarly like that. So now let's say that if we are putting this continue statement here, so we are checking if the value of j is getting equal to 2, we want to continue, so that this statement which is inside the inner for loop, that will not be getting executed. So let's run this program now. So now as we had guessed, as soon as the value of j becomes equal to 2, the SOP is not getting printed, the statement is not getting printed here, and we are directly seeing the value of I. The statement which is printing the value of j has kind of reduced by 1. That means the use of continue has taken the iteration here and has skipped this instruction. Okay, now what if we want to get out of this particular loop and we just want the execution to start continuing from the outer one? For that we'll create a label and we'll just say that the value of j becomes equals to 2, continue to test. Now as soon as we say continue to test, what would happen is even this value will not be getting printed, okay, along with this. So let's execute this. Okay, so as you can see here that because every time inside this for loop that I'm going, every time the value once will be becoming equal to true for every value of I. So as soon as that becomes equal to true, I say continue test. So I never get out of this for loop completely, and hence this statement is not getting printed. So that is the power of using the label even with continue. Okay, so this is as far as the continue statement goes. So next in line is the switch statement. So switch statement is say for example is something like that I can have n number of values which are coming out of my expression. So that expression could the rule is that expression should always be returning an integer or a string. Only in that case I would be able to use that inside a switch statement. So say that I'm expecting some 4 to 5 values out of my variable, okay, and in that case I would want some specific block of code to be getting executed. So for doing that I use a switch statement. So the syntax, as you can see from here, is that in the switch we write a block, and before that block we check for the value of an expression, for the value of the expression. So in case the value comes as say value underscore 1, we execute a piece of code and then we break. So break is mandatory here. In case value comes out as value underscore 2, we execute another set of statement and then break. And after doing these end statements, what I'll check is I'll put up a default value and I'll put my statements for executing those default things. So let us again take an example of the switch statement. Let's say that I have an integer I again into the picture. I'm assigning the value I say is equals to 10. So this is just for the sake of assumption, assume that it is some value which we are getting out of a function, okay, and depending upon the value of I would like my my program to write some number of functions. So I'll do one thing, I'll put that value of I inside a switch block, okay. I'll say that when case the value of I is say 2, okay, say that print system.out.println the value is 2, okay, and after doing that I'll break. Okay, now I can just use this case condition again and again in my logic. So I can just say that, you know, when case the value of I comes as 3, print the value is 3. You can say that if it comes as 5, print as 5. And in the last I'll just say that, you know, if none of the cases are matching, this is what the default condition should be printing. The default should say that, you know, I'm printing a default value. None of the above mentioned. And this is how the execution of switch would be done. So as you've kept the value of I equal to 10, none of the cases here would be followed and the default should be getting printed here. So let's run the program once. So as you can see, the value is the SOP is saying the value is none of the above mentioned. Assume that if the value of I is kept as 2, the output would be the value is 2. So this statement is getting executed. If I'll keep it as 3, the output would be the value is 3, which is corresponding to this case, and none of the other things are getting executed. So if I remove this break statement from here, let's see what would happen if I just remove the break statement, which I mentioned was required. So you can see, because break statement was not there, it goes inside the case 5 as well, which is followed by a break statement, and then it comes out of this loop. So it is very essential to put up a break statement for all the cases except default, because default is mentioned at the last, so it won't print the values after that. Okay, so this is it from the switch statement, and for this after doing this, we are done with the statements module.
So we'll start with what is a Java object. So Java, unlike the procedural programming languages like C, is object oriented. So when I say that it is object oriented, the thing in the procedural languages is that whenever we want to start writing a program, first we think about the logic to achieve some particular goal, and then we come up with the data structures that help us in reaching that goal. So that is how the procedural programming works. But in case of object oriented programming, before starting to write the program, we try to figure out different objects that would be getting involved, and then we think of the logic in which these objects would be interacting with each other. The best part about the object oriented programming is that these objects, they don't overwrite each other's attributes. They just call the methods, each other's methods, and the logic of the program flows accordingly. So this is how we achieve like security in object oriented programming. So these are the objects. So let's take an example of a banking application. Okay, so if you want to start writing a program for that in Java, what we'll do is we will think about different objects that are involved. So we'll say that there should be a customer, there should be like an account object, there should be some employee of the bank, there should be bank itself. So these are the different objects that we can think of before writing the program. Then we'll try to see that how these objects would interact. Like say for example, how would a customer interact with the bank? He would be having some attributes like he'll be having some address, he'll be having a name, he'll be having like a number of accounts that he has already opened in the bank. Similarly, account would be having some account type. It would have the account number, it'll have how much amount it is having. So these are like different attributes that an account object would be having. So the interaction of these two objects would be like a customer goes to a bank and withdraws some amount from the account. So this is how he'll be kind of calling an account's method of withdrawing an amount, and some party, some interface in between would be handling over
this amount. So we'll be designing the architecture of the program in this manner. We'll be thinking of different objects involved here, and the flow would then continue. Next thing that comes is then what is a class? So let's take it by an example of the customer. So I can have a number of customers in the bank. Okay, now all the customers would be having some common attributes, like they'll be having a name, they'll be having an address, they'll be having that which account they correspond to, and how much amount is there in the account. So a couple of attributes would be kind of common across different customers. Okay, so the thing is that how do we create those objects that have similar attributes? A class provides us a way of doing that. It acts as a blueprint using which all the objects would be kind of getting created. It's like all the objects would be first of all taken as like a carbon copy of what a class is, and then some values would be fed to them, like name, address, the account and all. So a class basically acts as a blueprint for all the objects. It would define what all attributes those objects should be having. It should define that what should be the behavior of those objects. So the attributes that a class defines, those are known as fields, and the behavior, so those are exposed as methods of the objects. So that is how the concept of class is used for putting all the common attributes across similar objects. Now let's see quickly that how do we create an object. Okay, let's start with NetBeans IDE. Let's create.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below, and you can go check it out. Now let's continue with this session.
A Java class, that is, let's give the name as my first Java class. Okay, let's say finish. Right, so this is how I created a new Java class. Okay, now okay, let's define a couple of fields of this class. Let's say that it is having a string variable.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Name. Okay. Let us define a method, some random method that returns as a string that says get name. It'll just return me the name of this particular class's object. So it just returns me this name. Let me write the main method for starting this program. Now how do we create? So this is how we have defined our class. It'll be having a name attribute, and it'll have a method that is get name. Now how do we create an object out of this particular class? So the way forward is that we'll use the class name as the identifier of the variable. So we'll say that it's the first Java class variable. We'll name as some test object. Okay, and we'll create it by using the keyword new. So this is how a new object of first Java class would be created. Now what would happen is whenever the compiler and the JVM they kind of encounter this keyword new, what they do is they instantiate an object. They try to see what is the definition of the first Java class. So they'll allocate that much memory, and they'll be storing that. They'll be initializing with some logic, and this is how the object would be getting created. So let us see that if we try and see, what is the value of this name method here. We do it by calling test object dot get name. Okay, so this is how we have created our first object, and this is how we are trying to call one of its method. So let us run this program. The thing to note here is that we haven't initialized the name attribute of first Java class, so we won't be getting any value out of it. We'll just see null coming out of get name method because it has not been initialized by us and we haven't assigned anything as well. So when we run this program, we'll see we are getting null in this particular sysout statement. We can create n number of Java objects using this line. So what we can do is, if in case we want to create another variable, let's say test object 2, that also we can create using new. So n number of objects could be created using the new keyword. Okay, so just now we saw how did we how do we create new objects using the new keyword. Let us take a relevant example which we just discussed some while back. So let's say that you're writing an software application for a bank. So the object that we had discussed some time back was an account object. So let us see that if we are trying to create an object out of account, how would it be, and what should be the different fields of that object, what behavior it should exhibit. So let's quickly see that. Okay, so let me just create a Java class for that. Let's say the file name is account. Okay, and let's say finish. Okay, so let's say that what all attributes we can think of the account. We can just say that it would be having some account number. Okay, let's say that it's a string variable. Now it could be the other field could be like the account type. Then we can say that how much amount stored in that account. Okay, so these three attributes would be acting as the kind of identifier for different objects. So I can have a number of accounts, a number of customers can have like a number of accounts for them. So each account would be each account object would be kind of differing from the other using these attributes. The behavior that is exhibited by this account object is, say that whenever someone is trying to withdraw the money from an account. So let's say that there is a method that is withdraw amount. So let's say that it would it would just return me some boolean variable saying that the operation is turned successful or not. So let's write that method withdraw amount. Okay, I'll pass some amount variable into that which I expect to withdraw. Okay, now let's write a basic logic here. So let's write a very basic logic here. So if someone is trying to withdraw some amount from the account, ideally what it should do is it should first of all check if the amount which the account has, the withdrawal amount should not be greater than that. So we'll just quickly check that if the amount is greater than the withdrawal amount is basically greater than the amount that I'm already having in my account, then just return false. It's not possible, sort of thing. Okay, and else what one needs to do is else the amount should now become as amount minus the withdrawal amount, and I should just return true here. saying that the operation is successful. The other method that I can write here is like someone is trying to deposit an amount into an account. So I'll just say that, and again let's see that it's like a boolean variable saying deposit amount. Okay, let's say again if someone is trying to deposit some deposit amount into my account. So again, let's add some very basic validation that if someone is passing me say a negative amount, okay, in that case I'll return false. I'll just check that if amount that someone has passed me is a 0, return false. Else what one needs to do is else my amount should become equal to whatever value I was having initially plus the deposit amount, and I'll just return true after that. So that is like a very basic structure that the account class should be having. It should have like 3 attributes here: account number, account type, and amount. It should have like 2 very basic methods: withdraw amount, deposit amount. Now how do we run that program? So let's write the main method here. Let's first of all create an account object. Let's say it's test object. Okay, and let me just create it using the new keyword. Okay, now an account object has been created. Let me assign some values to the attributes of this object. Let's say that the account number is SB_101. okay, it's a savings bank account. I'll say the account type, so I'll use account type. I'll just use a string variable SB that denotes savings bank account. Say the amount in this object initially is, say I'm giving some 100 rupees into that while initializing, say it's some bank offer. Now after doing that, let's see what is the the state of the object. Let's print what all variables are getting into. So I'm using this system sysout method here. Let's say my test objects initial values. Okay, and I'll just print these 3 things. I'll print the account number. I'll print its account type. I'll print what is the amount it's having. So this is how I've created an object and I've assigned some values to it. Now let's see that what would happen if I write those methods. Let's say that if I'm saying deposit some amount in my test object. Now deposit amount method, let's say that I'm trying to deposit 100 rupees into that. Okay, now let's see what happens to my object state. So it would be my object state after depositing. Okay, so this would tell us what is the state of my object after I make a deposit. Now let's say that if I'm trying to withdraw some amount, So so now the method here would be withdraw amount. Okay, and let's say that I'm trying to withdraw 50 rupees out of it. Okay, let's see what happens to the state of the object after I make the withdrawal of 50 rupees. Say first withdrawal. Okay, now let's say that I'm trying now to withdraw say 1000 rupees from my account. I know that the account is not having that much amount. So let's say if I'm trying to withdraw 1000 rupees. Now let's see what happens after the second withdrawal to the state of the object. Okay, so just to iterate over what we have done, we have created a new account object. We have given some account number to it, we have given an account type, and we have given some amount into that account. Then what we are trying to do is we are trying to deposit some amount into my account, and then two subsequent withdrawals are happening. So let's see how the program runs here. Okay, now you can see we initialize the account with 100 rupees. Okay, these are the SB101 and SB are the account number and account type of my account. Now these values would be unchanged throughout these SOPs, so we can just happily ignore them. We'll see that this is the initial state of the amount. This is what happens when I deposit. So I have made a deposit of 100 rupees. What I'm doing is I'm adding this amount into 100. So it becomes 200 now. After that I'm making a withdrawal of 50 rupees. So because of that withdrawal, my amount would now remain as 150 rupees. After the first withdrawal, what I do is I make a second withdrawal of 1000 rupees, which will not be permitted because the amount is very low here. So as you can see, it was returning a false here, and my amount would now remain same as 150. Basically, none of the withdrawal, the second withdrawal didn't happen. So this is how you can try to think of creating a class and writing some of its fields, defining some behaviors, and how do you execute them. So the next topic that we have in mind is what is public static void main method. Now let's just go over it. Okay, so let's discuss on what is the public static void main method that we have defined here. So main basically is like a special method that provides the entry point to the application. Your application can have n number of files, and just one file needs to have the main method. So this method allows the class containing it to be getting invoked. The signature of this method is, as we have seen, public static void main, and the arguments that it expects is a string array. Okay, so these arguments can be passed to this program via the command line argument, or let's see that how do we try to get these parameters here. So let's say that I want to see what is the value of those string variables, string array coming into the program here. Let's say is the string input passed is, let's say I'll pass two parameters to the array of size 2. Okay, so let's say I'll print the value of args0 and args1. Okay, so I'm just printing whatever the value I'm passing into the program. So how do I pass the value in NetBeans? So the way forward to do is that you select the project, right click on that, go to the properties, select run, and you can select your main class from here. So say for example, I'm just removing the main class name. I'm passing two arguments here, hello world and hello 111. Or let's say that I'll pass here is hello Java. Okay, so once I add these arguments here, those would be passed into the main program of the application. So let's run this thing. Let's run the module and ask what is the main class, because it's having like two main classes are present in both the account and the first Java class. So it's asking which main class to pick. So we'll say that, pick it from the account class. So you can see here, these are the two values that we had passed, hello world and hello Java. So these directly came into the program here. So this is a way of passing the input parameter into the main program. Now, having gone through the fields, methods, and Java objects and classes, the next topic in hand is constructor. So what basically is a constructor? So every class must have at least one constructor. So this method, it basically is like a method, and that gets called whenever you try to create an object. So whenever the JVM encounters the keyword new, it calls the constructor for the corresponding class. So almost like a method, but it should not have a return type, not even void. And the arguments that we can pass to constructor, it's kind of up to us. It can have like, one argument, or we need not pass any argument to that. The thing is, we need not even define the constructor. If there is no default constructor defined by the programmer, what the compiler does, it creates a default constructor of its own with blank values. And until unless there is a constructor in the class, no object can be instantiated. So let's try and see how do we create a constructor, what is the use, and can we pass some parameters into that, and do we really need to? How does it work? Okay, so let's take the same example of the account class that we just created. Okay, first thing to notice, it should be the name of the constructor should be same as the class name. Okay, if you want, you can define some body into that. If it's not defined here, it's basically like the default constructor that the JVM creates. So let's try first of all running it and see what happens. So as we had kind of added some arguments to it, it's asking us to run via the module. So let's run via the module. So you can see that nothing important has happened as of now. Let me just remove these arguments from here, and so that it becomes easier for us to run the program. Let me just hide these methods, whatever methods we have added, and let's just keep what is available in the main method. So this constructor would be called whenever this new keyword is encountered. So to prove that, let's put up SS out here. All right, okay, now let's run this program. As you can see, the output of the previous run, because we have removed this particular line, this won't be coming. Initially, the initial values of the objects were getting displayed. So now we have added a line into the constructor, SS out into the constructor. Let's see what happens now. So you can see that this becomes the first line that is called from main. Okay, so automatically the control goes to the constructors method whenever it encounters a new keyword. Now let's take a couple of other examples. So as you can see that this is the logic that we have defined here, that we created an account with some account number, type, and amount. So what if I'm creating like hundreds of objects? I'll have to write these 3 lines again for all of them. So Java provides a way of passing this information while object creation. So that happens via the constructor. Now how that happens is, So I can say that, I can create a constructor in this manner that expects some arguments. Let's say it expects a string account type. Okay, let's say that it expects an account number. Okay, it expects an account type, and some amount. Okay, now what it can do is it can directly assign these variables to the input parameters that we are passing. The account type, account number, and the amount. Okay, so this is how we have defined another constructor for our class, and we are passing values like account number, account type, and amount. Okay, so now let us run the same program. Okay, now I'll also add a sysout parameter here. I'll say that called first from main, and this is the default constructor, basically, which doesn't have any arguments here, and I'll say that this gets called when it has passed some arguments while creation of the objects. So I'll say constructor with arguments. Okay, now again let us run the program without changing anything in the main method. So you can see as of now I'm not passing any parameter into the test objects constructor. So what happens is the default constructor gets called. Now let us say that I'm trying to create another object. Let's say that I've created another object. The object name is test object 2, and the way that I create this is I'll pass all the values into the constructor. Again, it's a savings bank account, and this guy has around 1000 rupees in his account. Okay, so this is what I'm doing here. Let me just remove the test objects deposit and the withdraw methods. Let us keep it very simple here. So the test objects once initial values would be printed here, and let us print the values of test object 2. We as you can see from here, we haven't assigned anything to test object 2 like we have done for test object. So let us see what happens now. Okay, let's see when we run this program. Now you can see the test constructor, the test object, it calls the default constructor because we haven't passed any argument to it. So this line comes up as soon as the test object gets initialized. This is the line that gets printed here, default constructor one. Now once we have assigned some values to that, and we are trying to print, so it gives us the object's initial values, that is SB101, savings bank, and 100 rupees. Now this is the account object that we have created, and we have passed couple of values into the constructor like SB102, SB, and 1000 rupees. So automatically the constructor gets called here, and this is the constructor that is getting called first from main constructor with args, and here everything is assigned into this test object 2 with whatever we have passed. So you can see similar values are getting printed, SB102, SB, and 1000. So that is the use of basically creating a constructor. You can create the object, and at the same time you can pass the initialized value into that. So yeah, so that's it from the constructors. Here we'll be going through what all are the different type of access modifiers we have in Java, how encapsulation is being implemented in Java. So a package is nothing but a way of structuring the Java files. We can create a package and we can keep the files performing like similar functions in that package. Basically all those Java files would be coming under the directory which is kind of given by the package name, and all the class files that get created, those would again follow this similar directory structure given in the package. Let me just quickly create one package and show you so that we are good on that. So here you can see that two of the classes that we created some time back, that is account and first Java class.java, they are coming in the default package. Let me quickly create one package. Let me name that as my source package. And let me create a new Java class here, source Java. So here you can see that this file that I created now, source Java, that is coming under the source package folder. Okay, so let me now compile this Java file that I created. Let's say clean and build. The class file, the Java file is compiled now. Under the files structure, I can see this is the source. Because account.java and first Java class.java, they were created in a default package, they are directly coming under source folder. The source java.java that file that we created, we gave the package name as source package, so that is coming under the source package folder. If you see the build directory, it is having all the classes. So again, the classes would be coming under source java.class. So that is the source java.class class is coming under source package. So that is the importance of how do we kind of keep different classes in the different folders. So that is known as a package here.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, coming to the access modifiers now. So, we have 4 access modifiers in Java: public, private, protected, and default. So, these access modifiers are applicable, and these are you kind of used as a keyword for all the members of a class. So when I say the members of a class, I mean all the attributes and all the methods. So all of them can be assigned these 4 access control modifiers. So when I say that a member variable or a member method is public, what I mean is that it can be accessed outside this class. Okay, outside this class and outside this package. When I say that a member variable is private, what I mean to say is that it can only be accessed from inside the class. So it cannot be accessed from anywhere else outside. And if a member variable is protected, it can be accessed by only within the package and only by the child classes, only by the children classes. They can access those member variables. When something is declared as default, so default is not basically a keyword. Default is like when you don't define anything before your member variable. So that is known as default access. And if a default access is given, that means the member variables can be accessed from within the package. It cannot be accessed outside. So let us take an example of these 4 access modifiers. It will become a lot easier from that. So let us say that we have created this source Java file. The package name which is given here is source package. Let me create a couple of variables here. Let me first create integer variable. Let's say, let me just give the name as public int so that it would be easier for you to understand. So I've declared one public variable. I'll create one private variable. I'll create one protected one, and I'll just create a default access modifiers int. So this particular thing, I don't have to define any keyword here, so it would be automatically taken as a default thing, and I'll just say that it's like the default int. All right, so this is my source Java file that I created. Let me write a public, and before doing that, let me just quickly initialize these values as well, so that if I'm trying to access, I should just see the value. Okay, or maybe just give us 20, 30 and 40 kind of. So creating a main method here. Okay, so for accessing these variables, I'll have to create an object of source Java class. So let me say that source Java. Let's give the variable name as object is equals to new source Java. Okay, so by doing this, we have created one of the object of this class. Now let us see if I try to print these variables values. So let me just print object dot public int. I'll print the private int variable. This is the protected int variable, and this is the default. Okay, so once I've done that, let me run this program now. So you can see I'm getting all the variables printed here. Now the access modifiers that are kind of given to these member variables, I'll take the example of only the attributes. Whatever I'm writing for the attributes, the same thing implies for the methods as well. So now here you can see that whenever I'm trying to print this object's public int and private int, protected int variables along with default int, everything is getting printed, everything is accessible. Okay, so that means anything, any type of access modifier is not, hiding the class's access to it, the same class's access to it. So everything is accessed from within the class. Okay, now let us create another class in source package. Okay, let me just give the name as some another class. Okay, I'm declaring that inside the same package. So once I've done that, what I'll do is I'll try to access these member attributes from this class. Okay, so what I've done is I have just I'm just using the main method that we have written for the source Java file. So it's in the main method. What I'm doing is I'm again creating a source Java object. Now I'm trying to first of all print the value of the public int variable. So public int is we have defined the access control as public, so it is available here because the class is in the same package. I have given that private int variable. Now you can see that for this particular variable, it is giving me a compiler issue. It says that this particular private int, it has the private access in source Java, so it cannot be accessed here. So you can see that the private variables are only accessible from the same class. The protected int, it is accessible, and default int, even that is accessible. So if I comment out these things and I run the program, I'll see the variables. So point to note here is private is not accessible from outside the class. Okay, now let me create another package and another class there. Okay, so let me go to the source packages. Let me say another package. Okay, so now in this another package, let me create another new class. Okay, now I'll do the same thing. I'll try to first of all access this object A, this source new Java object, and see how things go. Now you can see that as soon as I'm trying to get a reference of the source Java object, I'm getting an issue of importing the classes because it's in a different package altogether. So I'll just say okay, so that this file gets imported, the class gets imported in this Java file. Now what would happen is public int, as we have seen, that it is accessible anywhere. So the compiler is not giving any issue here. We mentioned that the private int, it was only accessible from within the class. So even, you can see, even if another class was trying inside the same package, it was giving an issue. So obviously it will throw an issue in the another package. So this would be giving an issue. Now next in line is the protected int. Now we had discussed that protected int is only accessible like within the package and outside the package, but it would only be accessible from the children classes. Okay, so that is the reason this another new class is not a child of source Java, so it is not accessible here. So the compiler again would be giving an issue that it has protected access in source Java. Okay, so we can just comment this line. Okay, next in line is default int. Now default int, those type of member variables are only accessible when you're trying to access them from within the same package. Now since the package has changed, it would be giving an issue for us. So here only the public variables are accessible. So if I run this program now, yeah. So this was an example of implementing another class in a different package. Now let us create a new subclass both in the same package as well as in a different package and see what happens. All right, so let us first of all create a child class in the source package. Let us say that I'll give the name as source child Java. Again, I'll follow the same process. I'll say that, so before doing that, let me just quickly at least, make this as the child class of source Java. So now this would be acting as a child of source Java. Source Java would be parent of this one, and I'll write the same method here. So now let's again go through all the different access modifiers. So public again is accessible here. Private, even it is not accessible from the subclass. So you cannot access a child, a private variable or a private method inside the subclass. Protected and default ones are again accessible here, which you can see, there is no issue from the compiler. So let us run this program. So you can see all the variables are now accessible and they are getting printed here. So this was an example of having a subclass in the same package. The thing was private member variable was not accessible here. Now let's create a subclass in a different package. So let me create a subclass here. Let me just give the name as source. Okay, source another child Java, and the thing is that it's in another package. Okay, so you can see that this file got created here. Let me first of all make that as a subclass of source Java. Okay, now you can see that the source Java file is the source Java class gets imported here. Again, I'll write the same main method. Now you can see inside this main method that again the public variable is accessible. Private, because it was not even accessible from the subclass in the same package, it won't be accessible here. That is for sure. The protected one, now you can see that it is giving an issue, but if you remember some time back I mentioned that protected variables are accessible by the subclasses even in a different package. Default, I mean, it makes sense that it's not accessible, it is only accessible from within the same package. So default we can understand. So you can see what the problem now which is happening is source Java is the object that we are creating. So ideally this should be the object that should be getting created, source another child. Now this is like a subclass of, you know, source Java file. So all the variables, all the public and protected variables, those are accessible by these by this class. So now you can see the error has gone, because initially what we did, we declared source Java, we created an object of source Java, so that was that is the reason it was giving an issue for us. But because source another child Java is a subclass of source Java, so it can access this protected int variable. It cannot access again the default int, okay, because it's in a different package. So if I run this.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out. Now let's continue with this session.
You can see the values are getting printed properly here. So this is as far as the access modifiers are concerned. Now, having gone through the different access modifiers, let's focus on how do we implement encapsulation in Java. So what encapsulation basically means is that an object that it tries to hide its attributes from outside world. It only exposes part of its attributes via some of the methods. Okay, so let us assume the example that we discussed some time back, that is of the account. Okay, we created a class account.java. So it had some attributes like account number, it had an amount associated to it, okay, and like the account type. So that account object, I mean, it shouldn't allow anyone outside the account class to modify the amount value. So that is the reason we created like two different methods, deposit amount and withdraw amount. And the main thing behind that is just to implement security. Okay, nothing outside should be, able to modify an object state, which is kind of the variables that are kind of associated to that class. These should only be modified by by the methods that the class decides to expose. So I mean, as of now, till now we have been just seeing that all the methods that we created, all the variables that we created were like either default or public. So anyone that was able to create an object of that class, irrespective of the package or irrespective of its subclass, everyone was able to modify the attributes as well. Okay, so let us see as to how do we kind of implement this encapsulation now. So let us go back to account.java. Okay, now you can see that we have created, this is the these are like the different constructors that we had. Now here you can see that we haven't defined any of the access modifiers. So these are taken as the default access modifier. So these would be accessible to all the classes in the package, and they all would be able to update these values. So for avoiding that thing, what we can do is we can just say that this is a private variable, the account number. No one should be able to modify that except for the account number class. Okay, again this account type, no one should be able to update that. The same goes for the amount. Now you can see that these amount variables that the withdraw amount and deposit amount, these variables are kind of getting, these methods are kind of getting invoked from outside classes. So it is easier for anyone, like a customer object that we kind of envisioned some time back. So that was able to use these methods to withdraw the amount, and subsequently the amount attribute was getting updated in this class. Now let's see that this account number and account type, if you are saying that this cannot be updated from outside the class, so we should be having some methods to change the values. So let us say that we define those methods here. Let us say that those methods would be say public say set account number, and it would either give a string variable, okay, which gets set. So here what we can do is that we can just say that this account number is equal to whatever account number is kind of provided in the method. So here again, if we want, so people would kind of call this public method and set the account number. So even if we want to restrict that, we can again declare that as a private method only. Okay, if we don't want anyone to access this method, or let's say that we want only, so assume that this account class is in a package and that is kind of holding all the base classes for my bank accounting software, and I trust those classes. Okay, so I can just give a default access here. So all the classes that are declared inside this default package or whatever package name that I give, those would be able to call this method. So that is the account number for setting. Now if anyone wants to get hold of what is the account number, what they can do is they can call this public method, because getting this account number, I don't think it could be an issue for us. So I just create this public method of getting the account number, and I would say that it would return me a string, return the account number. Okay, now same thing could be implemented for account type and amount. So you can just create those default and public methods for setting and getting the values. So I'm just creating those. Right, so this is as far as the setting of the account type goes, and this would be for getting the account type. So this is how you can implement encapsulation in Java. Okay, now let's go to the next topic. So the next in line is this keyword. So we use this keyword for from any method or constructor to refer to the current object. So I'll quickly take an example of how do we make use of this keyword. Just a quick thing to note is, the main purpose of using this keyword would be kind of to differentiate between the class level variables and the variables that are in the local scope. So let's go to the account class again. Now let's say that I'm creating this account class. Okay, now in the constructor what I've done is I've tried to create local variables, like instead of, for the account number I'm using act number, for the account type I'm using for the account type I'm using act type, and for amount I'm using AMT. So what if I'm kind of falling short of these local variables, or these variables with the same name are kind of getting used somewhere? So for making sure of this particular scenario, what Java does is it says that you can declare those variables as the class variables name. Okay, now you can refer that this variable is coming, this keyword, kind of make sure that this dot account number means the account number for this class. So this is how it differentiates the class variables with the local variables that are coming into picture. So we'll just say that this dot account number and this dot account type equal to account type, and this dot amount is equal to the amount. So that is the main purpose of using this keyword. You can use it to get reference to the class variables. So this is as far as this keyword goes. Static members. So what are static members? Static members are all the class level members. Since we have already talked about that class acts as a template for all the objects. So there would be couple of attributes or couple of methods that should remain same for all the objects. Like say for example, I have a class known as circle, okay, and I'm creating a number of objects out of it. So let us think that what could be the attributes of those circle. There would be say a radius, and on the basis of that, we'll be able to figure out the area or let's say the circumference of that circle. Now having said that, if we have 10 different circles with different radius, and so all of these would be kind of having the similar behavior, that they'll give us the area and the circumference. Okay, now one thing that is common across these circles would be that how do I calculate the area of circle? The formula of doing that would be pi r square every time. So this constant pi, if I want to share across all the objects in my circle class, the way forward of doing that is I declare that as a static variable, okay, static attribute, so that all the other all the objects in that class would be able to use that and calculate the area or say for example the circumference. Okay, so that is the importance of creating the static members. Now these also do not need an existing object to be used. So if I'm creating a circle of an object of circle class of say radius 5 centimeters, I don't need that object to be into existence for using this variable pi that I have declared, the static variable pi that I declared. It would be accessible even without creation of that object of circle of radius 5. So that we need to make always keep in mind that I don't have to create an object necessarily for using those static members, and these are always used to distinguish the class level variables from the local variables. So all the objects that I have, like circle, say for example I'm creating a circle of radius 5 c1 object, the radius of this would be different from let's say c2 object of radius 10 centimeter. So these are like local variables, right? c1 and c2 would be like variables. C1 and c2 are like objects, and these radius are like local variables, but pi is like constant across all the objects. Okay, so that is again one thing that we need to keep in mind. Now let us take an example of what do we mean by static members. I'll also dwell upon that where all we can use static. Static keyword can be used with a block of code. It can be used for methods. It can be used for declaring like the final constants that we discussed now, like pi. So these are like different use cases of using static keyword. Now let's quickly go into a code example and see how it is implemented. Okay, so now let us create a class here that we were discussing. Let's say the class is circle. Okay, now this circle class, as we discussed, that there would be some let's say we are discussing the constant is, assume that I'm not discussing, I'm not putting that as a constant, I'm just putting that as a static class level variable. I'll just say pi is equals to 3.14. Okay, now this is the way of declaring a static variable, static attribute. Now this static attribute can only be accessible, is basically only accessible only from the static methods. So let's say that we have declared a static method. Say return area formula. Okay, so here what we are doing is we are kind of returning the the constant that is used for calculation of area. So we'll return a double value to it. We'll just say return pi. Okay, let's write a main method here. So as I mentioned that I don't need to have an object of using I don't need to have an existing object for using this pi variable. I can just say that sysout value of pi is. Okay, so notice that I haven't created any object here. Okay, so when I run this I get the value 3.14. Now assume that I'm kind of removing this keyword from here, static keyword. Okay, now see, now it's basically acting as a normal class level variable, and this class level variable, it cannot be accessed from a static method. So that is another point that we need to keep in our mind. If a variable is declared as static, only then it can be accessed inside a static method. So you can see, because we have removed the static keyword, both the methods are giving us a warning saying that say the non-static variable pi cannot be referenced from a static context. So let us now declare that as static. Now, so that is one of the ways of declaring the static variables. Okay, now let us say that creating another variable. Let's say that I create an integer variable, integer radius. Okay, and in the main, what I do is I create an object. First of all, I say that circle C1 is equals to new circle. Let me quickly create a constructor as well. Say public, which expects an integer.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Radius, and I'll just say that this dot radius is equals to the radius that we are passing. So that way we will be creating an object just by passing the argument into it. So I'll say that new circle C1 is a new circle with radius as 5 centimeters. I'll assume that the dimensions are like centimeters. So let us see if we can refer this pi variable not only from the context of the class, but also from the context of this object C1. So let us see if this is a valid. As you can see, I mean, I'm not getting any error out of it, and if I run the program, I get the value of pi as 3.14. So that shows that this static variable is accessible from all the objects. Even if I say for example, I create another circle. Okay, I create another circle with radius say 10 centimeters, and now instead of putting c1.pi, if I say c2.pi, then also you can see the value of pi is returning as 3.14. So that means it is accessible from all the objects, and all the objects show same value here. Okay. Okay. So the next thing that we need to discuss is that it can also be used for writing the block of codes. So if I say that if I declare a block of code in the program as static, and I say that that system.out.println, and I'll say that classes static block is getting initialized, and let me not just print anything here except this here. Okay, now what you can see from here is, and also let me put up a sysout in the constructor class. What I'm trying to explain here is that how the static block gets executed. What is the flow? Does the constructor gets called before executing the static block? How many times does it get called? So that is what we are trying to see here. So I'll just say inside constructor. Okay, now let us quickly see that in the program that we are running, what should be the expected outcome. The expected outcome is that static block of code, which is kind of created like this gets executed every time a class is loaded into JVM. Okay, so this would only get executed once, this piece of code. It won't be printed for say for example I'm creating two objects here, it won't be printed twice. It only gets printed whenever I'm kind of creating or loading a class into JVM. That is one thing that we need to keep into mind. This circle constructor that we have kept, this sysout would be called every time we'll be creating an instance of circle object. So because we are creating two instances, we'll expect this value to to be coming twice, and at the last we should be getting value of pi is c2.pi. c2.pi is like again 3.14. So let us run this program and see the flow of execution. So you can see that this class's static block is getting initialized. This piece is called only once, it's not getting repeated. Similarly, this sysout for inside constructor is getting called twice. Once when we create a circle of radius 5 centimeters, and next when we create a radius of circle of radius 10 centimeters, and at the end the value of pi is getting printed. So that is another use of creating a static block of code. This static block of code can also be used for initializing the static variables. So let's say for example that this variable static, the pi static variable that we have declared, let us not initialize it with some value. Okay, now if we now try and print, because it's not been initialized, the value we should be getting is the default value, which is like 0.0. okay, now we can put its value inside the static block. We can just say that pi is equals to 3.14, and now when we run the program, so we'll get the value of pi as 3.14 because this static block got executed and it updated the value. That is another use of using the static block. Basically executing class level code just once. so that it does not get repeated for all the objects that are getting created. All right, now let us examine the main method here. Now if you remember, I mean, we have been writing this main method at a lot of places, and we have kind of declared that as public static void. Okay, so the reason behind putting this method as so first of all, the reason behind writing this method is JVM expects a main method available in any of the class for beginning its execution. Now because JVM needs at least one starting point, so any method that it is kind of is present as the starting point, it should always be public, because it can be accessed via any other class outside the package. Okay, so that is the reason it's kept public. Now the reason it's kept static is because since it's the starting point, the object of that class will not be existing. Okay, it makes sense, right? Because this object is not existing, so it should be a class level thing. It should not be object level. So that is the reason it's kept static. So so if anyone asks why the reason what is the reason of keeping this main function is public and static, so that is it. It is accessed by the JVM, and when the class is not even in, when the object is not even in picture. Okay, now another use of putting of using the static keyword is static import. So imports are basically if you are trying to use classes which are not available inside this package. Like say for example, if I'm trying to in circle.java, if I'm trying to create an instance of first Java class, I don't have to import anything because it is available inside the same package. So it is visible to this circle.java. In case I'm trying to use like another new class or source another child, I'll have to import these things. I'll have to so let us see, I mean, how import works. So when I say import, I'll say that another package dot another new class, and now I'll be able to use this thing. So if I try to create an instance of let's say object equal to, so this does not throw an error only because I have imported. If I comment out this line, it'll throw an error saying that this class is the circle class is not able to find this another new class. That is the exact reason of doing an import here. Now I can also do import using static. So this import static, when I do, I mean, I get the objects of the enumeration. So let's say that I'm trying to get, so let's say that so let's say that in my program I'm just trying to see that if today is Saturday or not. Okay, so otherwise, I mean, if I wanted to use, I would have done it like this, in that manner, that I would have imported java.util.calendar class. I'll show the first way of implementing it. I would have done is import java.util.calendar. Okay, so I would have just said that if, okay, so now let us see that how do we make use of this calendar class. So this calendar class, it basically stores the days as like integers. So if I just want to compare like Saturday, okay, of this calendar object, so is like it's kind of stored as starting from Sunday as 1. So if I say that if calendar.saturday, the number of days is kind of stored as like that. So if I say that calendar.saturday equal to 7, I'll just print the value. No, yes it is, else I'll just say no. So that is one of the ways of using this, calendar object here. So that is how I've imported this. Now assume that in my program I just have a requirement of comparing this Saturday. Okay, I don't want to get into account all the other days like Sundays and all. I don't want to take that into account. So for that, what I can do is I can get this particular instance of that. So the format of doing that is import static. Okay, and when I do import static, I can directly use that as the variable Saturday as it is, instead of putting calendar dot. So that is another example of using the import static. So this is it for the static keyword. Now let's move to the next slide. Now let's start with what is inheritance. So the concept is one of the concept of object-oriented programming, using which we organize different classes in a set of hierarchy. And the reason that is done is to we want to avoid the redundancy and the duplication. So let's say that I have already implemented a logic of say I have a person class. Okay, now if I want to kind of implement that particular module in for a school, so that person class can be kind of used as a parent class for a teacher and a student and an employee as well. So all of these three classes, that is teacher, student and employee, all of these would be having some common attributes, like there would be some name of the person, there would be some attached age of that person, and so on, address of the person. So these are like the common attributes that all of these three classes would share with person. So if I'm kind of not using the concept of inheritance, what I'll be doing is I'll be kind of writing the same method or the same attributes on all the three classes. So that way I don't want to do that. What I can do is I can just have all these three attributes in the person class, and let all the three new classes kind of reuse them, so that I'm kind of avoiding the redundancy and duplication here. So that's one of the main reasons of going by the inheritance approach. Now how do we create a child class? So we have a keyword in Java using which we can create a child class, that is the extends keyword. So using that I can kind of create a child of a parent. Now whenever, in this particular example that we have just taken, that person class, and it's kind of acting as the parent for teacher, student and an employee. So the parent class, that is the person here, would be known as a super class. Okay, and all the three classes, that is teacher, employee and student, those would be known as subclasses. Okay, and the concept of subclass and superclass is always relative. Okay, now a teacher is a subclass of class person. Okay, person would be could again be a subclass of say a class mammal. So it's always relative, the concept of superclass and subclass. So we need to make sure that whenever we are using these words like superclass and subclass, we need to always set the clear context, that this is a superclass of what child class. So these are always relative. Okay, now all these objects that we have in Java, all of them kind of come from object class. Object class could be kind of considered as a root of all the whatever objects that we create in Java. Okay, so that is one thing that we need to keep in mind. Second thing in Java is that it does not allow the multiple inheritance. So the idea is that a child can only be extended from a single parent. So that is something that we need to keep in mind here. So it cannot be the case that like in C++, a child can kind of gather the attributes or kind of inherit the behavior of n number of parent classes. So in Java we have that the concept is only single inheritance is allowed in Java. A subclass can only extend a single parent class. So that is something that we need to keep in mind. Now having kind of gone through all this, there is another concept that we need to keep in mind here regarding the inheritance is that whenever we create objects in Java, there is a sort of relationship between those objects, right? So let's take an example. So let's say that you have a car class. Okay, so you have created a class for car. Now that car would be kind of composed of say engines. It would be composed of tires, the metal chases and all. So if you would be creating objects for all different these components, uh, eventually what you get is that car is kind of made up of those objects. Okay, so that is one thing. So that is known as a composite relationship. That is, car has all those objects. Okay, but in case of the inheritance, what we try to do, we try to create is a relationship. So let's kind of extend from whatever we had discussed. So we said that person superclass, a person would be like acting as a superclass for a teacher. Okay, now so by saying that, what we are saying that the teacher is a person. Okay, that is, a child class is also like a parent class, correct? So just to give you another context in mind, let's say that we have uh, a square class and a rectangle class. Now what we say, a square is also a rectangle, correct? So square is basically a subclass of a rectangle. So you see that it has kind of established is a relationship between these two classes. So that is another point that we need to keep in mind, that inheritance always creates like is a relationship between two objects. Now let's go and quickly see the code of how do we go about creating these subclasses. Okay, so for the sake of this particular demo, what I'm doing here is I'm creating a new file, that is inheritance demo. Now what I'll be using this class is for, I'll create three classes. One is a shape class, the other two would be like the subclasses of shape, that is, I'll start with a circle and then a triangle. Then I'll use those three classes in the inheritance demo class for showing the demo. So let us quickly create the shape class here. So let's say the class name is shape. We'll give some attributes to the shape class, that is let's say that string the color of the shape. We'll say we'll also provide a boolean variable, okay, that is filled. So that tells that tells us that this shape is filled with this string color or not. Okay, so that is these are two attributes that we are providing. Let us also provide with the methods for accessing these two variables. So I'll say that public string get color, and I'll return this dot color. So again, just to make clear, this would be used for is kind of acting as a keyword for any object of this shape class object. Okay, now we'll also provide a setter method here. We'll just give the name as set color. It won't return anything, and we'll pass a string color into it. Okay, we'll set it by this dot color is equals to color, and it won't return anything. Okay, so this is the second method that we have created. Similar to these two methods, what we'll do, we'll create the getter and setter for the boolean variable. So we'll say that public boolean we'll just say that is filled. Okay, notice the capital I that I'm using as of now here. I'll return this dot is filled. Okay, and set so let me just Okay, and I'll again pass a boolean variable here. Okay, so that's how I've created the class shape here. Okay, now what I'll do is I'll use this class shape for as a parent class, and that I'll be using inside another class, that is uh, say a circle class. Okay, so I'll create quickly a class circle. Now I want to use this class shape as the parent of circle. So for doing that, what I need to do is I'll just say extends and shape. Okay, so that is a way of creating a subclass of shape. Now what extra things I need to do here is I need to let's say that a circle has a radius here, right? So a circle along with a shape or is filled attribute will also have a radius. So that is one attribute that we have added. We'll add an extra method here that gives us the area. So I'll say that public get area. Okay, so this would return us, and we'll return a double value from. Okay, so we'll say that return 2 into pi into radius into radius. Okay, we'll declare a pi constant here. So we'll say that, so we'll create a final variable pi here. So we'll say that final let's do 3.14. okay, so what we'll do, we'll use this particular variable the final static pi variable for calculating the area of the circle here. Along with that, let us also let me just create another method that would give us the circumference. So I'll say public double get circumference. Okay, and what I need to do is I'll just return 2 into pi into the radius. So that would give us the circumference of this area of this circle. So right, so now having done that, let us quickly go to the inheritance demo and see that how do we kind of create these objects. So for doing that, let's kind of start with the public static void main method. Right, okay, so let me create an object first of all of shape. So I'll say shape s1 is equals to new shape. Okay, I'll set s1 dot set color. I'll just say red color. Okay, and I'll say s1 dot is filled set is filled as boolean dot false. Okay, so that way I have kind of created a shape object and I have set its values. So let me just print the output here. So let me just say that the attributes of shape s1 are percent s and percent s. Okay, and let me just pass the variables here. Let me say that s1 dot get color and s1 dot is filled, and let us run this thing and see what it returns. So you can see that all the values, like the attributes, that is red and false, are kind of getting returned with this statement. Now let us create another object of class circle. So let's say that circle c1 is equals to new circle. Okay, now let's say that we would want to set the radius of this particular circle. So we'll just set that c1 dot radius is equals to, let's say, 5. Okay, now we haven't kind of declared the setter method for radius, so we can just directly declare it using the attribute here, because it's kind of set as default, so it's accessible inside the same package. So c1 dot radius we have set as 5. Let's say that if you want to print the area out of for this particular circle. Okay, so we'll say that the attributes of circle c1 are, okay, %s and %s. So we'll get here c1 dot get area and c1 dot get circumference. So that would give us all the information for this particular circle. So now you can see that the area of the circle and the circumference is returned to us.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below, and you can go check it out. Now let's continue with this session.
One interesting thing that we can also see from the inheritance point of view is it will also give us the color as well as is filled attribute. Now because class circle is extending the shape, I can directly access its methods. So I can just say and %s is the color and %s is the is filled attribute. So along with the area, I can also access here.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Say c1 dot get color and c1 dot is filled. Okay, so that would give us the other so that's how I'm kind of accessing these two attributes of the shape class. So let me run the program. Now you can see that the attribute what we have specified, the color and the boolean variable, because they haven't been initialized. Notice that these are the boolean here is an object, it's not the primitive data type. So these are the objects, so that is the, and since these have not been initialized, we are getting value null in that. Now let us see what happens in case we initialize the values here. So let us go to class shape and let us initialize these with the say color as blue and is filled as true. Okay, so let us run the program again. Okay, now what we are expecting here is that we should be seeing blue and true here, okay, for circle c1. So if I'm running the program again, you can see that the color now is coming as blue and the is filled attribute is coming as true. So that is how we are inheriting the methods of class shape. Okay, so the next topic that we need to discuss is the accessibility. Okay, so if you remember some time back we had discussed that there are different type of access modifiers we have in Java. So these are like public, private, protected and default. Okay, So these access modifiers kind of control, that a particular member variable is kind of accessible, outside the class or not. So using these access modifiers, you control the behavior. Now what happens in case you're trying to access the member variables from a subclass? So how does the access modifier kind of control the behavior? So now within a package, if you're trying to create a subclass and try to access the parent class's member variables, you would only be able to do that for the non-private members. Say for example, we kind of discussed the class shape and triangle some time back. So had the class shape been having some private member variables, so the class circle might not be will not be able to access those variables. Okay, so that is what happens when you're trying to access the parent class's members within a package, from a subclass. Now what happens outside the package? So till now what we discussed, we were never kind of getting into the context of a package here. Now what happens in case a parent class is coming from a different package and a child class comes from a different package? Okay, so in that scenario, subclass can only access the public and the protected member variables. Okay, it cannot access the private and default. If you remember, default is kind of a package level privilege. Okay, so let's see how it goes. Okay, so now let us say that first of all, just create two packages here. Okay, let me just say test1. Okay, and another package I'll create is test2. Okay, let me now create a class here. Let's say my Java class name is rectangle. Okay, right, created this class. Now let me declare some methods here. So let's say that my class rectangle, on the basis of its length and width, it would give me the area. Okay, so let's say that the method area is, first of all, just declare that as a private method. Okay, so private, let's say that integer only will be getting out of this, get area. Okay, this would just return us this dot length into this dot width. All right, so that would just return me the area of this rectangle. Let me also declare these variables as private. Okay, so that none of the things are able to access it. So that is how we can kind of and that's how we have declared a class rectangle. Now let us in package test1. That is the most important thing as of now to consider. So let's say I'm creating a new class here, square class. Okay, and I'll say that this square class extends a rectangle. Okay, so automatically this import has happened for test1.rectangle. Okay, from this IDE. So let us now just say that I'm declaring a public static void main method here. Okay, now let me create a square variable, square s is equals to new square. Okay, now let me just try to print the values here. So if I say that s dot, now I cannot get the get area method. Okay, which is kind of coming from the triangle. Okay, so this is the method that I have declared here, correct? I cannot get a hold of this particular method from s.getArea. So because this is a private method, now let us say that I kind of change the behavior. I make that as a public method. Okay, now let us see if I can access this method here. So you can see that the warning has now gone. s.getArea is not now accessible. So if I run this program now, okay, I'll get the outcome as 0 because I haven't kind of initialized the values here, the length and the width. So that is the reason I'm kind of getting this particular behavior here. Now let us say that if I kind of declare the variables as 1 and the width as 2, the answer we'll be getting here is 2. Okay, so now this method is accessible here. Now let's say that I remove this particular access modifier of public from getArea method so that it becomes default. Now let's go inside in the square class and see. Again you're getting the warning here. Okay, let us now put that as protected. Okay, now once we have put that as protected, because square is a subclass of rectangle, I mean this getArea method is again accessible here. So as you can see from here that this square class is kind of outside rectangle. Okay, so that is the reason it's able to access the protected and the public method. Now what would happen if this public this particular class is inside this test1 package? So you would be able to access the default methods as well. So let's say that I'm again creating a square class and I'm creating inside test1 package. Okay, let us use everything same, whatever we have used inside here. So that is the public class square. Okay, now everything is same here. What I'm doing here now is that I'm using the square class inside the same package as rectangle. So even if I now remove this access modifier and change it to like default, this getArea method is kind of accessible inside the square class, this square class which is inside the same package. But inside this square class, that is inside package test2, this method is not accessible. So that is how the access modifiers are kind of controlling the behavior for subclasses. Okay, so just to reiterate, if you are inside the subclass within the same package, this one, you can access all the public, protected and default members. You cannot access the private members. But if you are in a subclass which is in a different package, you can only access the public and protected members. Okay, so that's all on the accessibility.
So you might find it as there is no need of using the Hibernate. But yes, we are going to do the comparative study of it with the JDBC because Hibernate is your ORM framework, which maps your object to the relation, that's your table, right, in the database directly without writing your queries. If you remember our JDBC code, right, for every single statement we need to create the statement object, your prepared statement object, and then you need to write in your query. You need to be careful with the syntax of a query. And let's say if my underlying database gets changed, for example, my application was using the MySQL because I just started my business. So I thought of to use any open source database which can manage, maybe thousands of 10,000s of records. And that is sufficient to me and, better cost efficient for me. But later on, what happens is my business is growing. Now I wanted to replace my MySQL database to Oracle or MS SQL or any, that's a Sybase database or even no SQL database. So in that case, what I have to do? In every of your Java code or the Java class, you need to replace your JDBC code. Now, when I say replacing JDBC code means your query syntax. Although you guys are aware of database concepts, you know that each database follows their own query syntax. At the same time, they have a different SQL types which is need to be mapped to your Java data types. Okay, for example, if you talk about the difference between your let's say MS SQL and the Oracle database, right? In case of MS SQL, they represent the strings in a double quotation mark, whereas in Oracle, they present it in a single quotation mark. So this is very minor difference I'm talking about, right? But when we come to the SQL types, yes, there is a huge difference we have. Okay, so to meet up those changes or difference in terms of data types, or the syntax of a query, we need to touch our code, application code. And you know, when my application is in production, and if you want to change any underlying resources, you need to down your server, down your application, even if it is for 1 hour. You know that what business you are going to lose. Am I right? So that's what the problem we may be facing all the time. Okay, so this is mainly what we are targeting to. I want some solution, some basic strong code which can help me to implement database connectivity through Java application, remembering or reminding the generic nature of my application. So I can replace my database at any point in time. I need not to change a single line of code in my application logic. And that's what becomes more efficient application, right? That's where your ORM framework comes into the market or comes into the picture. What are the different ORM frameworks available? That totally depends on your requirement or the knowledge of your development team. Okay, what your development team is knowledgeable of. There are many frameworks available like Hibernate, we have iBetis, we have JPA API, which also provides the same capability as your ORM framework as well, right? So what your ORM framework is all about? Okay, as the name itself suggests to you, object relational mapping. You try to recall your applications of JDBC kind. What we were doing in JDBC application, the complete application may be either inserting the data, reading the data, updating them, or deleting, mainly CRUD operation. Am I right? CRUD operation over the data. Now, this CRUD operations we are writing explicitly in terms of queries, right? So if they are the query syntax, I'm getting bound to my underlying database. How my underlying database understands my query is, I need to write it in the specific form. Correct. And that's what I wanted to avoid. I don't want to write database specific query. Rather, I would like to write generic query syntax, which can be interpreted by almost any database. Okay, for any database. And that's what we are going to look into here. So what's your Hibernate? We will understand OR mapping. What does it mean? We'll see what this framework is going to provide us as the benefits of, and the working of the Hibernate objects. Because this framework, when you say they are framework, they are actually an API. I mean, predefined set of classes and interfaces, right? What does they provide to you? They provide you actual implementation, which makes your development much easier and much more generic in nature. Okay, with less implementation dependencies. And that's what we wanted to target here. After your J2EE, what all you will be learning, like your Hibernate, Spring, they all are going to improve your development methodology. They are none of the any programming language. Let me tell you very clearly. Don't expect them as any programming language. Rather, they are a way of managing, writing, or maintaining the code with its improved quality. When I say a quality of code, definitely the reusability, the less error prone or bugs prone code, and definitely not redundant code should be written, not even a single time. That's what a quality of a code we expect. Okay, and that's what we are going to learn today. So what is main objective? We will understand and define what persistence is all about. Although you know this, if you remember our Java IO package, and when I wanted to persist employee object into some flat file, we declared our class by implementing the serializable interface as persistable object. It's just a flag, because when you read the data, you actually read it from runtime, Java runtime environment, right? Your Java runtime environment, to store your data into flat file or into the database, they need to represent the object into machine level language and not only in the byte code format. And that's what we need to flag it. By implementing serializable interface, you actually tell your JRE to consider this object as persistable object, so its representation should be provided in the form of binary to its external or output resources. Okay, that is what we expecting as your persistence nature of the application. So we will understand what persistence is all about. After that, we will identify different problems. What object relational mismatch implements. That means with JDBC, what problem we may face and we are facing is what we will be discussing here. Okay, and then we'll find the alternatives for this persistence management system, and those alternatives are your Hibernate, IBATIS, or JPA frameworks, what we will implement into our application. Okay, and we will also define object relational mappings in detail. That means you write a configuration file or use annotations implementation to define this relationship. I'll show you. In fact, you will find them much more easier than writing your JDBC connectivity. Okay, so let's go ahead with a persistence. It's the availability of any object or maybe any data even after the process who has generated the data gets terminated. And this is what we implement for, right? Why do you use Java IO package? To write my data to any persistent storage so that they can be available in future to me, right? What else you define in terms of persistence nature? Is that only to write to any flat file? No. I may be writing my data to any database management system. Why DBMS we prefer to? Because it provides me an efficient way to query my data in comparison with any flat file. Okay, that's what its advantage if we are going towards the DBMS or database management system. Okay, to declare my object as persistent, we need to mark it as serialized object. Okay, now let's talk about the difference or a mismatch between, I will not name them as object relational. Rather, I will name them as the data at the Java side and at the database level. Okay. How do you present your data in Java? How? You do present your data in Java as an object, which is a collection of multiple properties. Whereas in table, they are declared or defined as a properties collected together as relation or table. Right? You are talking about the same data. Let's say an employee details. So in Java, you represent them as employee type object. But in database, you represent them as a table. So if you look at the actual or raw data pattern is exactly the same. For employee ID, employee name, employee salary, date of joining, so on. In Java code, I will declare them as a variable inside my object or attribute of an object. But in database, I declare them as the attribute of my table or column of my table. So what is a mismatch over here? So many object-oriented applications have to implement the object model and relational model for certain business entity. That's what we have achieved in our JDBC code, which I'm going to take you a tour of. So let's go to the hands-on on my JDBC code. Okay, let's say, yeah, going to the database. What am I trying? Testing the database, updating an employee details. Now here, when you say I want to update the employee detail, what you are doing here, you need to check. Okay, up to database connectivity, it is fine. But when I want to update my record, I am mapping each column. You can see that department ID is mapped to the ID variable or property of the class. This is called your object. Yeah, this is something called as object relational mapping. So here you see, update the employee table, set the salary with plus 2000, where department ID is this, right? And then we are retrieving the data and displaying them back. Okay, let me show you some more code to understand. When we are inserting the data, okay, let's open this code. Entering the department ID to list all the details. So here we are reading the employee ID, first name, last name, department ID, so on, and displaying them here. Okay. So this object of Java, which is result set object, is mapped to the relational, which is your table. Okay, which table may be an EMP or department table. Matching the data requires you to know what Java data type to be mapped with which SQL type or which SQL type. So whenever we are mapping them, you will see when we are representing a data object in Java, we don't have a similar data type into few database like in MySQL or MS SQL, because in that case they will be having a date time data type. Okay, but when we talk about a date data or date object, we are only representing the date of the current day. Okay, so this mismatch we need to always map, and that's where we are going to use our ORM framework. So object relational mismatch is going to lead us few problems. What problems? Problem of granularity. There is one example given to you. Okay. Suppose we have to design and implement an online e-commerce application in which we would need a class to represent information about user of the given system and another class to represent information about the user's billing detail. Now, how my SQL schema is going to be designed? Something like this, okay, as given below. But what problem over here you can see? Username, name, address. For billing details, we will need the account number, account person's name, okay, and the account type. We are going to check the username as the primary key foreign key, which is going to map both of our table. Now, what do you mean by granularity? It is a primary key, and the problem because of this is, I'll tell you, the moment you try to update any of the given record, let's say whether it's a user table or it's in a billing detail table, what happens is your database management system implements something called as locking, right? So that locking means if any user is updating the records, then my dependent tables are also blocking or locking the particular record from getting it deleted or updated by another user. You got my point? Now let's say, for example, if user wants to change the address, okay, you will be firing an update statement to the user1 table. Meanwhile, our accountant or employee at the e-commerce application side wanted to change the account type because he or she is being a regular customer. I wanted to upgrade the account from regular account to, let's say, premium member account type, right? But until unless user is updating the address, I cannot update the account type. Although this two updation doesn't have any data affected to each other, but still my record is logged because of the dependency what we have to implement into its real-time scenario. That is required even, right? That is what one problem we will be facing in. How does your framework will solve this problem? What your framework is going to do, whenever you fire any update or delete statements to the records, it will pick up the snapshot of the actual data from the database and provides this data as a cached object into your Hibernate framework. There is a different level of caching available in Hibernate, level 1, level 2. So the data from the database will be picked up, okay, stored as an object into the Hibernate cache, and then any updation what you are going to fire would be updated to the local cached copy of the data. And when you are closing the session, means the communication to the database, it will update your cached state to its actual database. That means in one application, I may update multiple data and multiple table without bothering about the DBMS way of behaving towards my relationship between tables, right? So you are updating the local copy, which you can even revert. Okay, before closing the session, you can even revert those updates.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And meanwhile, you are applying any business logic, checking your updation, what to fire, what not to fire. Your records are not logged at database level, right? Because you are reading the data from the database and making it available as temporary data copy. Now let my front user or end user to do any business logic implementation and decide what changes to be implemented or imparted. And at the end, when you say session.commit, it will read all the exact or updated values, replaces the existing record with all updated data, and it's done in a fraction of seconds. So your record will be logged, but for minimal time period. And that what helps you to avoid the problem of granularity. You got my point? Yeah. Let's talk about another problem what we may face with object relational mismatch. The problem of identity. Now, when I say the identity in database, how it is defined? A primary key column, right? So according to the logic of a primary key, each record has to be identified by a column called primary key column. Correct. But when you talk about a Java application level side, you are identifying two different objects as unique object if their hash codes are different. Okay. Now, how we can say that employee E1 is different than employee E2? At the database, you will compare their employee ID. But in Java, if you are retrieving the hash code, they are of a same type object, right? So they may be generating the same hash code, but different index value in the hash table or a hash map. So how do we solve this identity problem in Java application in your ORM framework, for which we will be using an annotations? Okay, that means the configuration what Hibernate framework provides you. So you have to declare any of the attribute or property of my class as ID property. Okay, which we will identify or which we will use at the Hibernate cache to identify each object as an individual object by comparing their employee ID rather than comparing their hash code. Okay, let's talk about a next problem. A problem with your association. Okay, when I say an association problem, what happens in Java? In Java, there may be a class. Let's say I may be creating one class which will be a child class or derived class of another class. That means my employee class may have its base class as a person class. So when I will save an employee object into the database, do I need to store the person details and the employee's details separately into the database or separate table as a separate table details? If yes, how it is? And that's what association problem we need to define explicitly by coding into my framework. Similar way of, association means when we are creating an object of one class in another class. So in an employee class, if you can imagine what my employee class could be. So let's say I'm trying to write one Java code, declaring a regular Java class here, defining a class, give a name as an employee or customer, anything, or let's say student even. Okay. So if it is my customer class, what data you may expect. In case of a customer class, I may be having customer's ID, customer's name, and so on. Let's just see ID, name, and an address. Now, address itself is one object which is defined separately in my program. So I do have one more class which is representing an address class here. Inside the address, we are going to specify first house number, second street name, third area, fourth landmark, many more. And this address object I'm going to create here for customer as address of P address, means permanent address. Same address of current address. Possible, very much required even. How does this association we are going to store into database? Because whenever you will save your customer object, let's say customer new of customer type, and you will say save my customer object. So in Hibernate, you will write it something like this: session dot save or commit, the methods we are going to call in, and you may pass your object C1. Now, with the customer, you have two more objects associated to it as their property. How does your database should store this data? As a separate table or as a separate column in a table? How does they need to be stored? That is what a problem of association we need to handle. Second, problem of subtype. A customer may extend any other class into it. Let's say extends. If they are customer, I'm going to extend, let's say, a person class. Obviously I have, okay, or maybe the state, city, anything you may specify. Okay, so if it is extending a person class, I may be having a data related to the person's property, which is a generic. Okay, first name, last name, mobile number, email address, so on. When it comes to the customer class, I may be having customer specific details, customer's login ID, password, okay, date of login or last date of login, and kind so. So when I will say save my customer object, what its base class person object to be stored with? As a separate table, as a joint table, as a separate column. How am I going to tackle this? So this is another problem what we may face if we are writing JDBC code. Okay, because when you are using JDBC, you cannot use your complex inner queries over here. Okay, because your inner query has to return some result to its outer query. How does your Java will handle that? So complex inner queries are not allowed in JDBC. So to handle the subtypes and association, we need to find the other way of implementation. This is while storing the data, inserting the records. Same thing happens while navigating the records. I wanted to retrieve the data. When I wanted to say retrieve or get me the customer object, something like this, session.get customer object C1. For the customer object, what it has to pull. Let's say for person, there is a separate table. For permanent address or current address, there is one table called address. So do we need to retrieve person table, address table, and customer table data, all three together as a single customer object? or only pick up the primary key values and just display that. If you want to know the permanent address, this is a primary key, fire one more select statement. No, that's not valid. That's not really or identically good logic or good idea of writing application, right? That is another problem what we need to target here while data navigation should take place. Clear? This all are the different problem we may face when we are mapping our relational model to our data model or object oriented model. Clear? If you wanted to understand each problems individually, okay, so how does we sort out these problems of granularity, association, subtypes, navigation of data, and kind of by approaching the ORM technique, object relational mapping technique. Why does it need to be introduced? Because your JDBC, serialization, EJB, and object-oriented database management system, this four techniques does also qualify these problems to be pointed, but yet they have their own drawback. And those drawback I have already spoken to you. With JDBC, I did told you that, right? You need to write a lot of code, and also the difficult representation of association between object need to be targeted, which is merely very complex using JDBC API. Okay, then definitely we go for the serialization. Okay, if you say that in JDBC we need to write lot of code to handle and manage all these features of granularity, association, subtype, data navigation, so on, then let's go for serialization. Because in serialization, we are just writing the data at our own. But you know the drawback of serialization. You are writing data to the flat file. Now imagine I wanted to query the data back. Retrieve me the customer's detail who has placed the maximum order in last quarter. Can you fire such query from a flat file? No, I can't inquire the data because it has its own limitations of data being written as.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out. Now let's continue with this session.
Text or characters where we cannot put up a query. You might have other solution, write data in the Excel sheet. Yet your Excel sheet has also got certain limitations. To apply your filter, to do the sorting, they are having their own limitations, for which the Excel macros are introduced. What are your macros? Nothing, your Visual Basic code. That means again you are entering into or ending up with programming. You need to do coding to retrieve the data. And that is something we are doing with JDBC. Why would I learn the Visual Basic additionally just because I want to write data in Excel sheet? So serialization is also not a good choice over here when we are approaching to different ORM problems. Then comes the solution as EJB. Let me tell you very clearly. Your EJB can only run on application server environment. Okay, when you say an application server, they are cost-effective products. Not only a cost-effective products, to run your EJB, very first problem, you need an app server. App server like your WebLogic, WebSphere, your Oracle database, like OC4J, what you know it, and many more. You know, this product are high-end products. They does cost to you. Apart from buying the product, for this app server, you will need an additional person as administrator to be hired, who manages the execution of the app server and monitors it. So there is an additional role as an administrator, which are again coming as a high-end roles in any of your market or your software development market. You talk about Java developer, architect, designer, so on. They are at the low level employees. But when you talk about the administrator, configurator, and solution architect, they are the high paid roles which we need to hire for managing this product. So this is high end solution in terms of cost perspective, which we may wanted to avoid, as depends upon our company's financial status or the requirement even. Okay, the last option we have object oriented database management system, which was introduced, but it has not gained the popularity as comparing to your relational database management system. So this solution is also not as effective as we expect it to be, and that has given a birth to your ORM frameworks. Okay, this is your preferred solution for object relational mismatch to be overcome. Use an object relational mapping system such as Hibernate, which provides an API to perform any CRUD operations on either a single object or on multiple objects. Okay, it is actually a facility for specifying a mapping metadata. Prior to Hibernate 3.0, we supposed to write the configuration files and POJO files, which is mapping our metadata and providing database connectivity configuration details. But from Hibernate 3.0 version onwards, you need not to write the configuration file which are in XML format. Everything you can implement with the help of annotations, which I will be showing you in the example. So one example we will create with the Hibernate configuration files, and we'll see how it could be avoided by using the objects annotation implementations. So let's say what is an advantage of ORM frameworks we will gain. Very first, they provide you the productivity. Why productivity? Because it is going to hide a lots of database activity. It helps any developer, allowing to concentrate more on business logic rather than writing a code for mapping your object to the relation. Now imagine I'm going to show you one small applications on JDBC kind. Let's say we are writing one JDBC code. Okay, I'm going to write each and every CRUD operations to that. Let me check, are we up with the database? Yes, database has started. Let me pick up any table to which we can perform any CRUD operation. I'll take the EMP table itself because we have a lot of data here. So we can implement the insertion, updation, deletion kind of things. Okay, so I'll pick up this EMP table and I'm going to write one application which is going to perform all the 4 CRUD operations. And you see how lengthy the code is going to be and how much scattering of the code we will be expecting into our application. Okay, so let's start with the code now. I'm going to remove this 2. Let's write a Java class. I'm going to name it as EMP CRUD example. Going to call a main method here. Let's write with public void insert. Okay, public void update, public void delete, public void insert update delete read. That means, let's say I'll call it as display. Okay, now how many columns we have in the table? I'm going to take only few columns. Let's say employee ID, first name and last name. Okay, so first we will need to implement the connectivity connection result set and prepared statement. Okay, let's import all these packages. We'll start with the insertion first. And before the insertion, let us establish connectivity, for which I'm going to use a constructor. Employee CRUD operation. Okay, let's put our try catch block. Even you will see how much scattering of a try catch we have to include in. Okay, call even dot print stack trace for any exceptions to be printed to our console. And let's call class dot for name. Okay, what we wanted to implement here, that is your for class dot for name, pick up our driver class name and let's implement connectivity driver manager dot get connection. Specify your URL, username and the password. So let's pick up the URL first. The username and the password. Done. We are up with the connection. Now we need to have prepared statement depending upon what operation I am firing. So constructor is done. Let's go with the insertion now. Put up your try catch here. Catch, exception, same thing, print stack trace. Done. Call your prepared statement equals to connection dot prepare statement. Write your SQL query. Insert into EMP. How many columns? Not all the columns I am going to insert. Employee underscore ID, first underscore name and last underscore name. Only this 3 column I am going to add the values for. Employee ID, first name, last name. Okay, values equals 3 question marks for all the 3 values. Done. Let's set this data. For that, we need to have a scanner and pick up the input. Okay. Now to pick up an input, I'm going to create scanner new of scanner, taking an input from our keyboard, passing system.in. Let's import our scanner class from the util package. Done. Give a message. Println enter employee ID. Read that. So, okay, so your employee ID is in the form of, let's check the data type of the columns, number and varchar remaining 2 are. So integer employee ID. I'm going to declare this variable as the class attribute. Employee ID, first name, last name. Done. Let's say scanner dot next int. Say enter first name. First name equals scanner dot next. Similar way, read your last name. Enter last name, read that into lname variable. Right? Done. Now you fire your insert statement. Okay, so say row of factor equals prepared statement dot execute update, because it's my DML statement, right? If RA is greater than 0, give a message. Record inserted successfully. Done. Else record not inserted. That's it. Not inserted to. Okay, this is one way of implementation. Close your prepared statement object.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, this is your insert function we have done. Similar way, I'm going to write my update statement. Okay, to write your update statement, I'm going to do the same. So let's copy this piece of code. Copy. Just change your query, because we don't know what customer wants to update. So just change your query from here. Say update emp set first underscore name equals question mark, last underscore name equals question mark, where employee ID equals question mark. Okay, now what you have to do here? Okay, for execute update, we forgot to set these parameters. For prepared statement dot set int first index for your employee ID. Okay, similar way, dot set string. Sorry. of second argument to be as fname dot set string third argument as lname. Clear? Same things we need to implement here. For update statement as well. But here sequence goes different. First name should come as a first argument, last name should be second, and employee ID should be the third argument. Okay, record updated. Record is not updated. Clear? Close my prepared statement. Now, in the same way, we are going to write a code for your delete and select query. For delete, let's change our query. Inside the delete, just say delete from EMP where employee ID is question mark. And here we only need an employee ID to be taken as the input. We don't need the first name, last name because that's not required at all. So my employee ID should be the first argument. Execute this, call it as execute update. Okay, and check whether my row is affected. So let's say record deleted successfully and record not deleted. Clear? Okay, same in your select statement. Okay, prepared statement. Now I'm going to write my select query. Select all the data from EMP where employee ID is as given below. Retrieve all the data. Set your prepared statements. Get the first argument as employee ID. And here you need to say execute query, which will return you the result set. Okay, and here you need to pass while result set dot next. You need to print the data. Okay, how you are going to print them? To print the data, print the line employee ID. Combine result set dot get int of employee underscore ID. Similar way, employee first name, employee first underscore name, we have the column. Similar way, employee last name should be as last underscore name. Done. This is what your select query we have. Okay. Now you see how many methods we have written. Only 4 basics method. Insert, update, delete. But when you talk about actual business application, we may expect the select query written with 3 different forms. Select with the employee's name, select with the employee's ID, select with the employee ID and the first name both, because there are 2 employees has the same first name, but the IDs are different. Okay, so how many times you need to write the select or display method? Now let me create an object of the class and call this functions. So employee CRUD operations, where even new of employees CRUD operation call even dot. We'll start from the insert. You can even call even dot update, even dot display, and delete we will call later on. Okay, let's execute this. Uh-oh. It didn't waited for the input. Wait, I need to cross check why it is not waiting for the input. Insert scanner, next int. Let me try to execute once again. Wait. Why it is not waiting for an input? Util. This was the problem. Yeah, let's provide an employee ID as 000, a first name as Neil, and the last name as Patel. Record inserted. Okay, cannot insert null into. Oh, these are the mandatory field, I believe. So it is expecting to add the data of HR, employee, and email column as well. So email, what other email, and okay, only email address it is expecting to add into. So let's add everywhere. Email, give a question mark here, keep one more string email as the variable. Let's have the scanner input here. Enter email. Let's set string of fourth argument as email. Okay, same things we need to do with all the methods apart from this. I'm going to comment them. Okay, let's first execute our insert statement. Employee ID 000, email ID, have I not mentioned email here? Employee ID, first name, last name, email. Set int string, that's correct. Oh, sorry, here it is. This was the problem. hire date. This all are mandatory field it is coming to, but the main target is to understand if we are using the JDBC. You see how many time I'm going to map each column value with my Java variable or the property attribute. This is manually we'll have to do. Now you can see as soon as I'm getting any error, I need to keep update my query, keep placing the question mark, take the input, set the variable as your columns value, and then fire your query. Isn't it a complex task over here? Even if your table structure gets changed, let's say later on we are adding some new column or we are dropping any existing column, I need to keep changing my SQL queries and the code, which is affecting to my application in the production mode. And that's what we don't want to implement, and we want this problem to be overcome by your ORM framework what Hibernate is providing, which implements better maintainability also. Now see here, what is the lengthy code we are writing? Almost 150 line of code just to manage basic CRUD operation. You can even imagine your delete update statement going in a different way. Update only the email ID, update only the address, update only the first name or the last name of a person, and maybe many more. Update the phone number. So that all depends on the business requirement. I may be incrementing the number of functions and their way of implementation, and even keep repeating the same JDBC code again and again. Can you see that? The prepare statement, write your query, prepare statement, write your query, call your prepare statement to set each column's value is specifically. This is a lengthy code. Can't we overcome? Can't my Java object gets directly mapped to each individual column as it has to be? If my property value is changed, it should be updated. If it is not changed, the same value could be overridden. If you are writing A over the A, there is nothing got changed, right? We can predict it like this. That's what exactly your Hibernate is doing. Better productivity. So if my code is not as lengthy as the JDBC way, it becomes better maintainable because the number of lines will be reduced. It gives you a better performance because I may be reading multiple records at the same time, placing them in the cache. So I know way connected to the database, which is making me to travel through the network traffic over the database, right? So it will increase my performance of the application because I'll be working to the local copy of the records or the data. And it also provides you vendor independence code. Here, I'm explicitly writing my query. Okay, I need not to bother about writing the query at all. Hibernate framework will write query for me. So it generates the query automatically. And those query will be generic, can be interpreted by any database, MySQL, Sybase, any database. Okay, so that's what vendor independency is what provided by your ORM framework. So let's start with what Hibernate is, and we will write a simple Hibernate program. After that, we will understand its architecture, how it is functioning, what is getting involved from its API, okay, what your Hibernate API is used for, how many functions are there, what are the ways of implementing those functions, and many more. Okay, to write a simple program, let's say we have one small table called student, where the student ID and the name we are taking in so that we can very easily see the application logic rather than more bothering about lengthy data. Okay, because it just we need to see how it is functioning. Okay, Now, before we start up writing a Hibernate program, we must have Hibernate APIs in our hand. You download the latest Hibernate APIs or library files, okay, and place it in your local directory. You need to create the library for Hibernate. I'll show you how to do so. Go to your build path for that. In that, say adding a library and create a user library for the same. I don't have the Hibernate user library. I will create it at my own. So say user library, create new library, give a name as Hibernate, library as Hibernate lib. Add jars to it. That means your Hibernate jar files. I already have those jar files in my hand, so I'm going to add them. Okay, so let's say, so let me tell you very frankly, one thing, you have to download this file from the any website. You can directly put it on the Google. Okay, that's something like this. What all files are needed, I'm going to give you the name of them. So just write it in Hibernate jars download. This is one way of doing it. Okay, either you download each individual jar files, or other way, if you are using any build tool like Maven, if you are using the build tool, you can only declare its dependency on a Hibernate, and that will automatically downloads it. But that you have to repeat for every project. You need to declare the dependencies, which will be downloaded from the web individually and added to your project. So what you do is better, you go to Java 4S, because we are not learned on build tool as of now, which is not a part of your course content. Okay, so once you learn any build tool, that will become much clearer to you how to manage it in better way. Just click on that and go and download each of your Hibernate files. Okay, you need to download its zipped version or the RAR version, any one which you are suitable or comfortable to download with. Okay, so these are the files what you will get once you are downloading the jar files. Okay, Hibernate core, Hibernate commons annotation, Hibernate JPA, and this some more commons collections, your log4j file. These are some important files which is required for your Hibernate to log any error messages to your console, and likewise so additional utility. Okay, in fact, if I want, I can send you this jar files, but as you know, they are the jars, so they are considered as executable files. So it is difficult to attach them through your Google or any other accounts, right? Because of the security threats, they are banned to be sent as an attachment. Okay, so I have posted you the URL from where you can download your jar files. Okay, depending upon the versions, whichever version you are interested to use, you can go for the latest version of 3.6, as I told you, Hibernate 3 and above. Now Hibernate 5 are also available in the market, but we are not going to go up to the Hibernate 5. Okay, so you go for Hibernate 3.6 distribution, final distribution, and can download this files. Okay, so once you download, you need to extract that and add it into your library. This is just a category. Yeah, here you can see the final distribution. You will get like this. Download that, extract this, and match with the files what you may need. Okay, these are the different files what you may need in to be downloaded. If you can't find any of this file, you can simply read the file name, or you may copy the file name like this and write it in the Google. From the video, you can pick up the file name, Antellar, commons logging. These are the utility files which you will need to support your Hibernate framework execution. Okay, so once they are downloaded, you go to this downloaded jar files location. Then I'll try to send you as an attachment. Probably I'll find the other way. We have a different open source website where we can send any type of files. I mean, maybe the jar files also we can send. I'll try to send you in that case, okay, if possible. For any new project, now you can simply select the project, go to its build path and add it as a user library. They will be always available into this current workspace of Eclipse. If you change your workspace, means your source directory where your project needs to be stored, then definitely this library files you need to create again. Okay, so let's say I'll show you once more. Go to this project, build path. Can you find any Hibernate library file? No. Now I want to add that. Go to add library, select user library, and you will find is created here. What you created before. Select them, add it here. Done. It's just one-time process. What you have to create it as a user library, and it's all done. Okay. How easier it to write your database connectivity with Java application using an ORM framework like the Hibernate, okay, which reduces your code length and also makes it better maintainable. So when you have to add the Hibernate jar files, which is already done, okay, write your Pojo class. Now, what this Pojo class is used for? Let me pick up one program and we will compare them side by side. I'm going to pick up the Hibernate Basics. Let me copy this to import the project, or I may take a new workspace over here, probably. Let me take a new workspace. Let's go to other. Into hands-on. Inside this, I'm going to create one more workspace called Hibernate Workspace. Done. Now, after your Eclipse getting started, I have changed the workspace just to have a better grouping of your code for Servlet, JSP, for Hibernate, for your core Java, just to segregate them as a separate directory. I'm just creating a new workspace. Let's start with a new project. Here for Hibernate, you can write it as a simple Java project. We need not to have it as a dynamic web project or any of this. Okay, so I'm going to select the regular Java project in that case, because I'm going to write a simple Java classes which will be executed through your main method. Okay, so let's say Hibernate project. Okay, I'm not going to create it, rather I already have that project, so let me import that. So say import an existing project, going to the general and existing projects into workspace. I already have all the examples ready with me. Okay, so I'm going to copy them. This is the way how you can import. Add this. It will list you all the Hibernate project, I mean all the Java projects or Eclipse project here. Whichever you wanted to include, you select them. Okay, so let's say deselect all. I'm going to start with the basic first. Okay, then we will do add each project one by one, so that you can see the repeating of the same steps, which will make you more familiar to import statements of the Eclipse. Okay, now to the project, let me add my Hibernate library. Same way, going to the build path, configuring it. Okay, these are the jar file what it is looking for. They're already added. Okay, if you don't want to do it in this way, you can create it as a library, going to the user library, create it as a new library, give a name, Hibernate lib, add the jars into it, select all of them, opened, right? So we are added with the Hibernate library files. I'm going to remove this all and done. Okay, let's go to my project now. How we need to code. Okay, we are starting with the employee. Let's say as a table, we may have the employee table. Okay, this is my employee class, which is called as a Pojo class. Okay, you call it as a persistent class, you call it as a Pojo class, is one or the same. When I say a Pojo class, it's a plain old Java object class which will be representing your table into the database, having the same properties as similar to your database table. Clear? So we have the employee ID, first name, last name, salary, so on. Okay, you need to create a Pojo class as you can see here. Just like an employee, I'm going to add one more Pojo class as a student class. Let's say student. It's a Pojo class, you need not to add the main method into it. Declare the student ID, SID, and the name. That's it. See. Your properties must be private because you are creating the getter setter for each property. To generate getter setters, I did explain to you, right? So go to your source, click on generate getter setters, which allows you to read and write the private properties from outside the class definition. Then we created the Pojo. We have an employee, we have a student. After you created the Pojo class, this is your object, okay, which will be an object to store each records from the given table. After this, you will need Hibernate configuration file and Hibernate mapping file. Okay, Hibernate configuration file is the one which will have the configuration of database. Can you see some data which you already know here? When to connect with JDBC, through JDBC to database, you used to pass driver class, URL, username, and password details. This is called your Hibernate configuration, what you need to place under your source directory. Okay, so here is your Hibernate configuration file we have. What this file is going to carry? Database specific configuration. Okay, and written in this way, Hibernate-configuration. If you are comfortable writing in XML is fine, or your IDE can generate it for you. But nowadays, from Hibernate 3.0 version onwards, we are not writing the configuration file. Sorry, mapping files. I'll show it to you. Okay, so here you need to write each and every property. You need to mug up this. You have to remember. You don't have any other way. Okay, so provide your Hibernate connection driver class, Hibernate connection password, URL, username, and very important additional thing is your dialect class. What your dialect class is going to provide? This dialect class is your Java class available with your Hibernate API, which will convert or generate.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Hibernate queries or generic query for your database connection. Okay, what type of query it is going to generate? A generic SQL query which will be passed to your database while passing any SQL command. To see what SQL query it is generating at runtime internally, implicitly, we need to enable this parameter to true. Show underscore SQL, make it true so that in the console it will print you. I'm generating, I'm writing this query, I'm executing this query, so and so. Okay, which is very important. After that, Hibernate mapping to DDL. Automatic means implicitly update the data. If your tables are not available for which you are writing your Pojo class, like student, we don't have the table of a student name. Can you see? We don't have. So what we want our Hibernate to generate the table for us. That is even possible. Hibernate not only can write your SQL queries, it can even generate the database schema for us. Okay. It can also generate the database schema for us. And to make it generate the database schema, you need to enable this property as HBM to DDL, Hibernate mapping to data definition language should take automatic implementation in update with database. Which tables to be created? To get the details of a table, you need to look into this mapping file. Mapping class com.example.employee. This is your class which need to be mapped to your database table. Okay, ID, first name, last name, salary. Do I need to create all these 4 columns? That will be answered with one more file, XML file, which is called Hibernate mapping file. This Hibernate mapping file will map your Java class with your Hibernate or database table. There is a Java class called employee should be mapped to an employee table where there must have an ID column which is a primary key column. The moment you say ID, it is an identity column. Okay, and this ID, primary key ID, will be assigned. I will add the primary key value, not my database should generate. You can tell your database to generate primary key for you. That is even possible depending upon the database type. Okay, what database you are using, what facility it provides to generate primary key. Create one more column with, so there is a property in Java class employee with the name called first name. Create the same name column, first name. If I want to change the name of the column, I should write it like this. Column should be F name or first underscore name, something like this. Okay, so create a table with employee name, create one ID column, one first name column, last name and salary column. but first name should be named or titled as F name. Okay, so this is a mapping of Java object employee to the relation called table employee with given attributes. Okay, this is about mapping of object to relation. Now, how to use this relation, for which we will be writing one test class. What this test class is doing? It is initially instantiating your Hibernate session factory object. So let me explain you about. You need to write your mapping file as you have seen here. You need to write your configuration file. After that, you need to write your Hibernate code or program, which will first create session factory object. Okay, using this session factory object, you will need to get the session object. From session factory object, by calling an open session method, you will retrieve a session object. Using this session, I will fire each CRUD operations. Okay, to save the records, call a save method. To retrieve the record, call load or a get method. To update, there is an update method. To delete, there is a delete method. Okay, and this all method needs to be called on session dot. So on session object, you need to call these methods. And this method will take an input argument of object type, Java object type. Okay, let me show you in our code. There must have an employee table. Let me check, do we have any employee table? Not employees, this is plural. I'm looking for employee table, which is not available. Okay, so we may expect it to be created. Into that, we want to add one record as 100 ID, name as Uttam, last name as Patel, and the salary as given. When you call session.save, this will generate your Hibernate generic query for your database, which you can see in the console when we will execute this code. Okay, so let me show you by executing this code. Why it is taking so longer? It is yet executing. Unknown entity com example.employee. I'm using this. We have a user table which will be mapped to the user details table, which need to be created, where we will be having one column as an ID column, user ID, other column as a user name. Okay, these two columns will be created into the table and they are mapping with the annotation. So your class need to be declared with @entity what error we were facing in. Okay, that is trying to read as an annotations. Okay, because we are using Hibernate 3.0 version, it will always look for the Pojo class declared with @entity annotations. Okay, and each column needs to be defined with @ID or @column attribute. And I'm going to test this user with this. Okay, set the username and create new user here. So we are going to create 10 users. Okay, and then we are going to pass them into the table, which is similar to your sessions to be created. So let me execute this code. We'll see any error we are facing into the Hibernate jar files. I need to cross check. Yeah, it's getting created now. You can see that what SQL command it is firing. It has created the table automatically and inserted 10 records into it. Okay, let me show you that. Let us refresh our table. I need to refresh by this way. Yeah, user details table. Even user table has also got created from our previous execution. In the user detail table, 1, 2, 3, 4, 5, 6, 7, 8, and likewise this, it has added 10 records. And one record, it has fired an update statement. Let me show you that in the code. Okay. As I told you, if you are using Hibernate 3.0 version, you need not to write your mapping file. Because mapping of your Java object to the database table will be implicitly taken care by your annotations. Okay. And with the annotations, it is taking care of mapping each column. So let me show you from the beginning. This is my Pojo class user. Apart from any annotation entry, you see this is my regular Pojo class. I need to write @NTT to declare this class as my Hibernate entity class. That means it needs to be mapped with a table called user by default. But I don't want to create a table with the username. I want to have a table name as user details. So add one more additional annotation as @table name is user detail. So user Java object needs to be mapped with user details table into database. Which database? Here is your configuration file. Same, your driver class, URL, username, password, dialect class, show SQL to us, what query you are generating, and if the table is not available, you create that, your Hibernate to be converted to the DDL. For mapping, you need to look into the user Pojo class. Mapping class is user. As a Pojo class, you need to identify. Okay, we will see what is the problem we are facing in. Okay, there is something we are missing or some problem in writing the configuration we will have. Okay, that's we will anyhow, make it out. So you map my user Pojo class to the table which is given as the details in the configurations. Okay, table name should be user details. There is one ID column which will have some generated value. This value will be generated by your database. If you can see the query, what it has generated internally, it is generating some numbers. Can you see that? Sequence. You know something called a sequence in Oracle database. Am I right? Starting from 1 up to the number of records it is inserted. Yes, that is what it is generating for all the 10 records. Why there are 10 records? We are telling it to write 10 records. That is in our Hibernate testing code. I will explain you. So this is my table. Should have two columns. One is user ID. Other one is username. Okay. So user underscore ID should be the column name. For username, it should be the same as written here. See, user underscore name, user underscore ID. If I'm not going to mention this line of code, okay, let me show you what are the column name you are going to get. I'm going to drop this table. Okay, let's say table, drop this. Okay, so table has dropped. Let us refresh our web page. Can you find any user details table? No, right? Let's go to our code. Generate a table with the called user details. If I'm not passing the user details, it will create as a user table. Okay, the table name will be the user table. Okay, so let's say if I'm avoiding this annotations as well, what will be the table name? User. Do we have any user table? No. So the table name will be user. Column name will be user ID, username without any underscore. because we are not giving any specific name to the column. Okay, this is my configuration which tells the database configuration details. This is my Hibernate util class which will retrieve a session factory object from your Hibernate API, and that is like this. This is your Hibernate architecture. When you are using Hibernate API to get connected to the database, you will need two important files, XML mapping, which is now replaced with an annotations, and Hibernate configuration files. You know something called resource bundle properties file, right? The same way you can write it in. Okay, from your Java code, the Java code is passing some persistent object to it. When I say they are persistent object, they would be passed to your session object. Write your configuration which is common across any application of Hibernate type. Okay, this Hibernate util file is also exactly the same. You need to generate always to retrieve your session factory object, which is a home guard to get connected to the database. Okay, after using session factory object, you need to retrieve a session object from that. So from session factory, call open session as a method. This method will return your session object, which is actually your object to talk to your database. Okay, I'm creating an object of the user class, creating a 10 users. See, it's looping for 10 times. Set the username as user1, user2, user3, user4. And the ID we have given as auto-generated from database side. Who has told that? That is this value, generated value, generated from database. Okay, or you can write it as assigned, which I will show you. If it is assigned, we need to pass its value manually. If it is generated value, it is from the database side. So in your Oracle database, they will generate the sequence by default, which is getting updated. Okay, so once you get the session object, begin your transaction to the database, create the user object, call session.save method on the user object to insert any record. Am I writing insert statement here? No way. That means I'm nowhere dependent on the SQL syntax or mapping each value, calling prepared statement, statement object, set string, set int, remembering the sequence of the question mark to be replaced, nothing. It is directly writing my user object to the table. Okay, for updation, I'm just calling update method. What are we doing? I'm calling only the update method. Update which record? So in the session, get the record whose ID is 5. Now who says this is ID? Your get method definition. Where is this definition? You can directly Google your Hibernate API. Okay, let's go to your Hibernate API to see the syntax of your get method. It's better to have an API documentation in hand to understand your code much easily. Okay, you need to go to the session object, session class. Okay, so from where you are getting the session class, that is also you need to remember. Your session object is coming to you all the way from Hibernate session API. Okay, so org.hibernate package you need to visit, into which you have a session interface. What is interface? It is a main runtime interface between your Hibernate and Java application. Did I told you the same? What methods it is carrying? To retrieve the data, it has two methods, get or load. To save the data, it has save, persist, save or update method. Okay. And to delete the record, it has a delete method. Okay. All this method we will explore little later. What your session get method is telling you to write. Here it is. Give me the class type and the ID. Which ID? You can see that mentioned here. @ID mentioned over the user ID value. So pass me the user ID as the second argument to the get method. So I will read the records of 5 user ID type, store it into user object. I told you, if you remember, it reads from the database, stores it into local object. So this is what your local object into which the record of 5 user ID is stored. Now you update the username and then merge this local object to your database table, so that your database need not to acquire a log starting from this line up to this. It only need to acquire a log at this line of code, nothing else. Okay, get me the data, maintain a local copy, do updation, override the same copy into the database. So that's what updation we are doing. To update the data, we are calling session.update method. At the end of everything, we are calling transaction.commit. You know what is transaction capability, right? You need to always remember calling the transaction commit or a rollback depending on your business requirement. Okay, so we are calling transaction.commit to apply the changes or to persist the changes into database. Now you see, what is it generating? Could not load the entity with the user ID called 5. Okay, it is not able to update that because it cannot find the 5 as the ID, but it has generated all the records. Okay, so let's go to our table, the database, refresh this. It must have a user table here. Let me check, have I done any changes? Okay, let me check from the beginning. Anything we did updated? No, right? Configurations to be the same. Users, let's execute again. It shows to null pointer exception. Select user ID, user's name from the user details where the user ID is question mark, which is showing as null pointer exception, line number 37. Why it is 37? Set username. Correct. So my transaction is going in a rollback situation. That is one reason we are not getting the correct data. Yeah, no data is stored because the commit statement is not getting fired. It is ending into the exception. What exception it has? Null pointer exception. Null pointer at this. Okay, it might not be generating the sequence from the beginning. Okay, let me avoid the updation for the time being. We'll only insert the records. We will do the updation later on after we get to know what records are getting inserted. It will generate your sequences and will insert your records. Insert it into the tables. Let me check the data we have. Yeah, see, because your sequence has increased. So your sequence was not able to identify the 5 as the user ID. due to which it was getting failed at the update statement. At this line of code, it was not able to get the user with the ID called 5 because of your sequence. Okay. So now if you say update the user with the ID called, let's say 31. If I'm changing it to 31, it can update your records as well. Let us execute again. It will add some 10 more records into your table and will update the last one. Can you see update user detail? Set the username as the past and the user ID as the past value. Let us refresh our data. User details, a data, 31 record, updated name 1. And how many records we have in the table? 20 records. You can see that. Am I right? Up starting from 31 to 50 because your Oracle sequence is getting updated. Let's understand each and every class individually now. Now the problem what we were facing into our previous code, let me sort it out and explain that to you. What is the problem? I did realize the problem is the previous code, which is our basic, we are facing a problem due to this line of code. When you are using the annotation, it should come as mapping class. But when I'm using the Hibernate mapping file, it should come as mapping resource and write the Hibernate mapping file name. So employee.hbm.xml, it should be written as employee.hbm.xml. So let's start with the Hibernate architecture. Code seems like an alien statement to you, but each line of code we need to understand in terms to check what each object's role is associated to your application layer as well as to your database level. Okay, that is what we are going to implement in with. And we also have a discussion about what different problems what it solves in terms to connect with your database module. Okay, so now I will be explaining you each of the object, writing the code in front of you, and will show you why to write and which statement is going to proceed what action to the database. So let's understand the architecture first. When I say it is my Hibernate architecture.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Your Hibernate architecture is full of different pre-built classes which helps you to manage your application or object to relational mapping. Like this is my application of Java kind or .NET or any other programming language, they can make use of Hibernate. So my Hibernate framework is totally a generic implementation which can be used with any application written with any programming language. Okay. Now, your application layer has to get connected to your configuration layer at the Hibernate side, which is going to read your Hibernate configuration file, which provides you a detailed to get connected with the database. So this is the file which is being read by your Hibernate configuration layer and establish the connectivity to the given database schema. Okay, but this 4 parameters are sufficient to get connected to your database. What is your dialect class is acting here? Because we are not going to write our queries as a native SQL statements. We rather want to use the pre-built method available with the session object of Hibernate layer and provide a different database transaction capability. And that has to be executed on database layer. As I told you before as well, each database has to follow their own syntax of writing the query. So your dialect class does a task of an interpreter or a conversion. It reads each request coming from your session object and converts it to the specific query, which is yes. In interview, they'll only ask you where you are providing the database configuration details. They don't ask you. Okay, you only need to remember few parameters name, right? Apart from your database connectivity like driver class, URL, username, password, what else parameter is mandatory? So that is this, a dialect class for the Hibernate is very much mandatory. And if you are using the XML based configuration, you have to map your XML or Hibernate mapping file by this particular way. And the problem what we were facing in the last project, I will show you how to resolve that. What you have to do is always in the build path, you try to refer the project itself as its class path. Okay, so what you have to do is within the library, you need to add a project as your class library. Okay, so that I'll show you the way you are going to add it into. Which will be identifying your Hibernate mapping file to get connected to the database. Okay, so very first your application should obtain the configuration object which will be carrying the database configuration details. So how we are obtaining the configuration object is what we have seen. So let me show you the database configuration, how it is been readed. No, that is just user. Yeah, the util file. This is the file from where we started. Now, if you look at the Hibernate configuration file very carefully, what we are passing, I'm passing Hibernate configuration, but that is bundled as one session factory object. Now, what is this one session factory object? When you talk about real-time project, in your real-time projects, you may be connecting to the multiple database, development database, testing database, production database. So in all these 3 layers, the database are different. That means the schema, let's say here, I'm connecting to HR schema. And my testing environment, I may be connecting to my test database or test schema. And into my production database, I may be connecting to the original data of the any application. So how does we can establish the connectivity of one Java application to multiple database by creating multiple session factory configuration. For each equivalent database, you need to pass the database configuration like this. Okay, here I want to connect to the admin database. So I may write it in the form of admin. Here I may want to connect to my test database. So my schema would be the test schema. That's what your session factory object is represented. Okay, so let's come back here. From the configuration layer, we obtain an object called session factory object, which represents one database connectivity or one schema connectivity you may think for. Okay, now after you get your Hibernate factory object, what this object is capable of, what advantages of this object you may get. So let's start very first with your configuration object. Okay, what we are obtaining by this way. You can see the very first statement, create new annotation configuration object. What this object is going to give, your config object is the very first Hibernate object we are going to create in our application, and it is usually created only once. Okay, it is containing two things, database connection. You have seen, right, what we are passing in. Second, it also contains class mapping details or setup, anything you may call that, right? That's what you are passing here. Map each Pojo class to its specific table, what we have mentioned here. Here, because we are providing the mapping to the table and the class in the form of annotation, we are creating the annotation configuration object. But if we are passing the mapping through your Hibernate mapping file, we may be creating only the configuration object, okay, where our mapping is specified in the same way as my previous example. Okay, so your configuration object is going to carry two things. One, the database connection detail, and second, class mapping detail. What about session factory object? Your session factory object will contain the configuration for the application which is supplied by the config object plus a session object. It allows a session object creation. So it is a kind of a home guard object through which we need to pass through to get the session object. Okay, now why does this session factory object is required? The session factory object is created one per database. For each database, separate session factory object will be created. So you may write multiple Hibernate configuration file in that case. And that file we can pass as an argument to this configuration method. So let's see our Hibernate API. And I'll be showing you the configuration class in that. Okay, that is Hibernate configuration we need to go for. Okay. Here it is, Hibernate CFG. Here is your configuration, what we are obtaining from. Okay, so you can read that. Allows the application to specify properties and mapping documents. Okay, while creating the session factory object, these details are required. Now you may see the function. Can you see there are overloaded configuration method, the constructor? Why they are overloaded? So if my application has exactly one configuration file, I can call this default method, default constructor, sorry, because there is only one file to read the configuration. But in case of to get connected to multiple session factory object, I may be passing the session factory details in a separate configuration files. So that file name I need to pass in here. Okay, as a setting factory file details. You got my point? Why do we need multiple session factory configuration? To connect to multiple database at the same time. And that is provided as a separate configuration file which can be instantiated in this way. Okay, that's what the another thing we need to keep in our mind. So there can be multiple session factory object we can obtain by passing the different Hibernate configuration file as an argument to my configuration function. While creating new configuration object, you may pass an arguments to it. Clear? Okay, let's continue understanding our architecture second. So after the configuration object, you need to get the session factory object by calling .configure.build a session factory object. Okay, so for the configuration which is been readed from the specified file, you create me the session factory object which will give me a session object to pass on any database transaction to my underlying database. Okay, so from configuration we will get session factory. From the session factory we will get the session object. Where it is, let me show that to you. It's here. From the Hibernate util class, I'm calling this method. I mean, this is session factory object we got created. We are calling get session factory object method. Dot open session is a method which will create your session object. Okay, what's your session object is required for? Your session object is the one which will be firing each query to the database. Okay, it is mainly to fire any query to the database. So let me show the session object from your Hibernate. This is an exception. Classes, yeah. Session factory and the session object. This object is actual object, is your actual runtime. between your Java application and your Hibernate architecture. So it is a bridge between Java application and your architecture of Hibernate. And this particular object is providing you the different predefined methods. You can see them here: save, persist, save or update, delete, load, get. These all are the method which will fire the different SQL statements as seen. Save and persist will call your insert. Delete will call your delete statement. And update method or merge method will call your update statement, whereas get and load method, they are here, will call your select statement. So there are mainly DML statements and select statement what we are going to fire in. So your session object is mainly the object which is implementing the actual runtime interface between your Java application and your Hibernate architecture. This session object will definitely be queried to you. Okay, that is one reason why I am showing you in detail with its API. So best way to understand and to know what definition should be given for what object, what class interface is you should go to an API rather than visiting the different tutorials over online. Okay, because in multiple tutorial, if you are visiting, you may find some contradictory statements, and that will not give good impact in your interview. Okay, so remember that. Now, when you say a session object and you fire any kind of DML or any other operations, you are going to fire these operations not on actual data. You are going to work with an object of Java type. So if you remember, here you can see that what we are calling session.saveUser. What is user? An object of user class. That means the save method will fire an insert statement, something like this: insert into user values like your user ID, which is being stored as the property. You can see them here. And username. That is what it is firing in, right? But whenever we will pass any query to the database using Hibernate, we are not firing a query over column or the property. We are firing it on the Java objects. Okay, so we are always sending a Java object through my Hibernate layer. So whenever you send an object, your object may pass through the different states. You can see them here. Instance, the entity class instance may exist in any of these three given state. So the life cycle of your Java entity object within your Hibernate layer. Yeah, query interface we will see how our query interface will help us. Okay, the different Java callbacks which helps you to know in which state my current Java object is lying right now. Okay, the different types. Types means your object types when you are storing them to database, how they need to map. That's we are going to look into the relationship. Okay, and extension again. These are the ID generators, which is an additional extension like the one we have used here. Okay, for every user, we are not writing the user's ID. We are only adding the username. User ID is getting generated through your Hibernate extension. generated value. Which generated value? Sequence. In your Oracle database, the default generated value for any new record is the sequence. So that your database will handle. Okay. Sequence generated user ID will be added. I'll show you once again. I'll execute this code and I'll show you in the query how it is generating that. Okay, and we will identify each and every statements what it is executing. Okay, so that is your generated value. These are an additional Hibernate extensions what we can use, like your ID generator, your dialect class. So both we will see in action. Okay, this is what a life cycle of your object. Which object? Pojo object. Who are the Pojo object? This user is my Pojo object. Even it is also called as Hibernate entity class. So either you call it as a Pojo class or you may call it as entity, or you may call it as Hibernate entity class. Many names. Okay, and object of this class is the one which we are passing through the Hibernate back and forth. Okay, in the form of Java object, not in the form of simple value like how we did with JDBC. Set a string, set an integer, set a date, likewise. So no, we are not doing that. We are directly giving our Java object and let my Hibernate layer to map each property of Java class to its respective table. Okay, so let me take you to the table as well. Yeah, so each ID, each attributes of my user class, you can see the column name what I am expecting to. User underscore ID, user underscore name it should be. Okay, which is getting generated, and they are mapping both of them over here. Clear? Now how these numbers were generated, you know that very well. Using the next sequence which is generated by your database. I'm going to even delete this table and we will see what next sequence we are going to get into it. So I'm going to truncate this table. I'll not delete this table. I'll truncate it. Truncate means I'm going to remove all the records from. Okay, so now if you see the data, we don't have any data into the database. We are refreshing the page. Here is my class. When we are executing the test user case, running it as our Java application, we will see what queries it is generating in the Hibernate. Very first, yeah, you can see what it is reading from database. There is a temporary table in Oracle database, you know, called dual, right? This dual table generates a new sequences. Okay, the moment it generates new sequences, the sequence has been given to your database table. Now, the moment you say save method, our object must be the serialized object, which is going to get inserted into database. If, in fact, you can see that here. Save or persist method will result and select SQL insert statement. Okay, that is what we are executed to. And let's see into our database. These are the data has been generated. We were having up to 30 or 40, sorry, 40, 31, 32, we were having the sequence. So up to 40 it was there. And then we executed once when we touched up to the exception. So it moved to your 50 data. And after that it is inserted up after 50, 61, 60, 50 to 60 was generated in the exception case. Okay. So this is what this Hibernate sequence, how it is creating or reading this sequence and then inserting the value. Did we wrote any of select statement for this? No. Why? Then how does it is coming? That is due to your Hibernate extension of generated identity generated values, which you are declaring here at the rate generated value. In the generated value, if I'm not passing any arguments, this you can also find it into your API. Let me show that to you. Your generated value annotations. ID generator, identity generator as an interface you will find somewhere. Action annotation, here it is. Identifier generator is what we have used, which potentially aggregate other persistent identifiers. These are predefined Hibernate extensions, which can help you to provide an additional data to the database. Okay, you can see that. It generates unique identifiers for each records we are trying to insert into it. Okay, fine. Let's continue our discussion. So my Java object will pass through this three state of the object called transient, persistent, and detached. When on which method execution the state of the objects are getting changed. So the moment we are creating a new object, it is in a new state, as you can see here. Next, when we call save or update method over an object, my object turns into transient state of this Ojo object type. So you call save or update. These are two different methods we have. Let's say I'm not sure about the record is inserted or not with the given ID. But I wanted to make sure if it is existing, it should update the new value what I am inserting. If it is not inserted, it should get inserted with the given value. So save or update is a method which is an alternate to your save method. Okay, so let's say for example, if your ID generator is there and if you are passing the same ID value, it ends up into duplicacy. So in that case, it will throw you an Hibernate exception while inserting the record. The duplicate identifier matched. Okay, but if you are calling save or update, it will override the new value what you are passing for the record with the same ID. So that's what save or update method. Okay, so it will turn your method, Pojo object or entity object from new state to transient state. Save or update will convert your object from transient to persistent object. My object is into transient state the moment we create it. So at this line of code, when I am creating the user object, user equals new of user and setting all the parameter. So at this line of state, my user object is into transient state. The moment you call save or update, it converts my entity object into persistent state. Okay, and once it is persisted, we may call the update, save or update, lock the record, any of the methods, or we may call evict, close, clear. This is all related to your transaction, which converts your state object from persistent state to your detached state. From detached state, it can be garbage collected by your runtime environment. Or once it is detached from your Hibernate layer, we can even remove this object by calling a delete method and so on. Okay. From the new state, I am creating only the user as the empty object, and I want to read from the database and store an existing value into this object. So by calling get or load or find or iterate method, we can convert our new object directly to the detached state. So this all depends on which method we are executing over a given object. Okay, so this is a state of your object has been explained here.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So from the persistent layer, when it is transferred to the persistent layer, it is through the session object. And then its state gets committed to the database. Okay. From detached, you either read from the database and then remove it in either or case, or you just create and you don't save it. It is in the detached object state. Okay.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out. Now let's continue with this session.
What is your object identity? In Java, objects are often compared using which method? Using your equals method, right? But when you talk about persistent object at Hibernate layer, they are compared using their database identifier or any identity what we are generating for the object. Okay, so object identity either can be assigned by the end user, means we can add, or it can be auto generated using your Hibernate extension, just like your generated value. Okay, so it can be in either or case, we can specify that. So comparison between two persistent object can be established by using or by overriding the equals method of Java lang.object kind. So how we are writing the Hibernate application? Let me show you from the beginning. Okay, so here they are using the same Hibernate mapping class. You can see that what we have implemented is in the same way. We are calling the table as user details. Here it is a message. Okay, we are writing the class as a user. Here it is class called message class with ID and the message as the two different properties. This is my Hibernate mapping file. Okay, and this one is my Hibernate DAO or util class, you can think for, where we are creating the configuration object and creating our session factory object and providing the session object to the calling application. Okay, so after you get the session object, let me show that to you. 1 second, I'll expand the size. So you can see that here, after you obtain the session object from the session factory object, which is created here, start with the configuration. From the configuration, you need to obtain your session factory object. Okay, you are retrieving that here by calling build session factory. Okay, you can see that you are adding the resource in this way. Either you add that into your configuration file, Hibernate configuration file, or you are adding it in this way. Okay, so after getting the session factory object, you are obtaining the session object, starting your transaction, inserting the records, committing the transactions, and closing your connectivity. Okay, here is your configuration file. Clear? These are the jar files which are required for your Hibernate application. We have seen them before as well. Okay, so I'm not repeating the same thing. After that, you may execute your applications and can test your applications. Okay. After that, we talked about the different problem with the JDBC and the database connectivity in terms of relationship and the association. How your Hibernate is going to solve that. Okay. Most of the data what we are writing in the applications are related to each other. Very frankly, right? But relation between the tables of the database are mapped in a different way using primary key, foreign key, right? So they are as a dependent record, they are being added, and they're also applying the ACID properties over them. So if I'm trying to remove the records from the foreign key table, and if the matching record found in the primary key table, right? So this all, I'm trying to remove from the primary key table and same record is available in foreign key table, I cannot remove that, right? So those relationships are mapped in a different way in comparison to the Java application. So how Hibernate will help you to map this object model to your relational model. What additional consideration we should implement? That's where your relationship comes into the picture. Like one-to-one relationship of an object, one-to-many relationship of an object, many-to-one. Let's say, for example, a student may obtain multiple subject. So there is a subject class. So in my student object, there may be multiple subject object we will create. Or let's say multiple seminar object which student will attend. So one-to-many, one-to-one, many-to-one. Like for example, student at a time can enroll for exactly one subject, or let's say one particular degree, right? So one certification. So one student, one certification at a time. But in that certification, there may be more than one subject, right? So kind of many-to-one, many-to-many relationship. This all we need to implement. Okay. And this relationship, apart from one-to-many, many-to-one, in Java classes you will very frequently find something called as composition and inheritance relationship. Okay, and that is what we need to map in. Let's say for example, a person and address, current address, permanent address, billing address, and let's say delivery address. What is very common in your e-commerce application? I'm placing an order, but I wanted to give something to someone else. So billing address should be mine and the delivery address should be of someone else. Okay, so I may be creating my account and adding multiple addresses into that. Right? So that is one-to-one relationship using the foreign key what database implements. But in Java, you implement this relationship by creating an object as a property in the person class, something like this. This is my class person, my class address. So in a person class, you will create one address as billing address. You may create one more address as delivery address, right? This is what your one-to-one relationship into your Java application, whereas this is the way it is handled in your database. Okay, fine. So to map your one-to-one or one-to-many, many-to-one kind of relationship, you either need to configure your Hibernate mapping file with respective tags or elements name, or if you are using an annotations, there are one-to-many, many-to-one, one-to-one relationships. Annotations are available which can help you to implement the same logic in your application. Okay, so it's the same thing which is talked about here. So let me show you one example of relationships, how to be managed. This is many-to-many relationship, how it is managed in Java and the database. Okay, we will see the examples of each of them, and then we will move up to the advanced mapping concepts. Okay, so let's start with the relationship examples. Here is your one-to-one, one-to-many relationship programs we have. let us import this project into our database. Let's clear our console. You need to do it in the same way. Extract into one of the directory of your choice and then select this location and directly go to import the existing project into your workspace. This option you need to select under the general category. We will first start with our Hibernate configuration file. It is exactly the same. We are connecting to the database, okay, and mapping two objects as a user and vehicle, okay, and we are expecting it to be created as a table. So after we have the mapping, let me just say update. Okay, we are having two different objects as a user. Okay, I would need the user details table and then a vehicle, where a vehicle is a table name and these are the properties will get stored into it. So each property is declared as @column name as vehicle ID, vehicle name. So each user may have exactly one vehicle associated to them. To implement the connectivity or the relationship, we are creating the vehicle object into my user class. You can see that here, private vehicle. So here we need to mention its relationship by using an annotation called one-to-one, one-to-many, many-to-many, and likewise. These are the predefined annotations available from Hibernate 3.x version onwards, where we need to specify an additional parameter of cascade type. What do you mean by cascade? If the vehicle details, or sorry, if the user details getting deleted from its user details table, should we need to remove the vehicle detail as well? Yes, obviously. That is why we say cascade type is all. Okay, we say the cascade type is all. And to know this, we can even better go to this API. Persistence cascade all. Let me show that to you. Java persistence cascade all. This is my advanced Java API. Java X persistence cascade type. Here it is. You can see Java, sorry, the relationship between your objects, what we are implementing. What do you mean by an all? The all cascade type says each and every operations need to be cascaded to your vehicle object. If it is updated or deleted or inserted, need to be cascaded to its database. Apart from this, your Hibernate util is the same file. We are getting the configuration session factory object. From the session factory object, we are obtaining the session object, starting with the transaction, creating a new user, new vehicle, setting the vehicle name as Activa, setting the username as Deepak, adding the vehicle to the user object type, and then only committing the user object. I'm not calling the vehicle to be committed. Okay, so I'm only committing the user object. And once it is done, let's see its execution here. Done. The insertion has happened into two table. Can you see that? I'm calling a save on a user table itself. But because my user entity class is creating the vehicle as its object with one-to-one relationship, this after sequence getting generated, the sequence is added to vehicle and to the user ID as well. Let's see our user details table now. Going to my database. The user details table, vehicle table. In the vehicle table, we will find one entry, 72 vehicle ID as an Activa, and the user details when you go to the last record, Deepak with the vehicle ID as 72. Clear? This is your one-to-one relationship, what Hibernate can easily map to. You see, it is taking care of generating two sequences for both the table and inserting the record too. Clear? It's just you need to mention your annotations, which is mapping the relationship between both the object. Similar way, you can practice other relationship which is already given to you as an example. One-to-one, one table per concrete class, one-to-many, and all the relationship is given to you for practice, like many-to-many, one-to-many, one-to-one. Let me show you an example with one-to-many implementation so that you get an idea how one-to-many relationship is being implemented. Okay, so this is about one-to-one relationship. And now when we talk about one-to-many relationship, let's go again to import statements from an existing, copy pasting the same, deselecting all the projects. I only want the relationship projects. Yeah, Hibernate, one-to-many and many-to-many relationship. Copying the same to the workspace. I need to check their configurations in the class path. From Hibernate jars, let me update them to Hibernate utils. Same way with your this example. Go to build path, select your path. Okay, Hibernate utils are not added here. Let me do so. Add library as user library, Hibernate library. What else the error it has? It is the same. I need to remove the unused import statements. Done. So now when you see one-to-many relationship, we are expecting that one user may have multiple vehicles. Okay, so that I'm creating the vehicle object as collection type as an array list object. Okay, so because it is an array list object and there are multiple objects of vehicle type, I need to specify this relationship by creating an additional join table between user and the vehicle. So because one user may have multiple vehicles, okay, how this relationship will be added? Because in user table, user details will be added only once because user ID is a primary key. So I cannot say user Ratna has Ratna and vehicle Activa, Ratna and vehicle Fascino, Ratna and vehicle access Scooty. That will violate my primary key rule in a user table. Correct? So what we are implementing to? We are creating one additional join table between the vehicle and the user class. What this class are doing so, or what this join table is doing so, it is just managing the primary key and the foreign key relationship of both the table. Okay, so let me update this, execute it, and show you how it is going to map them. So create a vehicle as car, as a bike, and add the details of them into the user table by calling save user details and adding your multiple vehicle as the array list to the vehicle. Okay, that is your regular array list collection type implementation, and you have learned that, so you will be able to understand it very easily. 3 records, 2 into your vehicle table, one into your user detail tables, and their join table, which is user underscore vehicle, has got 2 records into it. So let's refresh our database. User details, user vehicle, and user table. So when we go to the user details, let me go to the user vehicle. Yeah, user 1 has vehicle ID 2, user 1 has vehicle ID 3. So let's check the vehicle at user ID 2 and 3, car and bike. And let's talk about the user details. There is exactly one user with the name called Deepak, whose detail we inserted just now. This is your one-to-one relationship. Similar way, sorry, one-to-many relationship. Similar way, you handle many-to-many relationship. How do you handle many-to-many relationship? Take in same example. Okay, one vehicle within your family belongs to multiple users, and one user may utilize multiple vehicle within the family. So that is one-to-many relationship what we can implement with. Right? Let's say, for example, course and student. Right? So when we say a course, student, what is the relationship between both of them? So when I say a course, it has a course ID and a name. And when I say a student has a student ID and student name, one student may enroll for multiple courses, and one course may be enrolled by multiple students. Correct? And that relationship is mapped with the help of your mapping file. So you can check that with your mapping file for an example. Okay? Into the course, this is a course name, its attribute, course ID, and course name. When it comes to the student, student ID, student name, and a set of student course type, having the cascade type as all, adding the student ID, and many-to-many relationship by using one additional column called course ID in a student table has been established. So let us test this application. Okay. Execute, sorry, as Java application. See. Generating the sequence, adding the record to the students table, course, and multiple details to your student course details. Okay, let's verify them. Under your student, you have one record as Ishwar, ID 4 as Joe. Under the course table, this is the entry. Second is for maths, third is for computer science. Student course details. Student 1 Ishwar has enrolled for both the courses. Student 4 has enrolled for second and third ID courses. Clear? So this is your additional join table what we are generating to. That is by many-to-many relationship what is been implemented to your Hibernate architecture or layer, you may call them. Okay, so that is about your relationship mapping. After this, let us discuss about the inheritance mapping and your association mapping. So what is an advanced or mapping of inheritance? Why do we use an inheritance? It is really a powerful feature of object-oriented programming, which helps you to reuse the class or reuse the logic what we are writing as one Java class and may override or repurpose the same logic. But in the relational database, they do not have anything called as an inheritance apart from the primary key foreign key relationship. And this relationship only derives the dependency between the table. Okay. So for the scenario where my Java application or application domain is implementing the inheritance relationship and need to be mapped to my Hibernate database table, how does it to be taken care? That is by different way or different logic. For example, consider a case where an application has multiple billing options for credit card, for bank account. Okay. In this case, the username and details are exactly the same. Only the type which are specified does differ. Okay. And how we will map this relationship? That is, we will create one table for each concrete class, not the abstract class, which is your billing details. Here, your billing detail is a kind of an abstract class. Okay, and credit card and bank account are your concrete class. To map the inheritance, you will always go for creating a table per concrete class. So let me show you the example for table per hierarchy or table per concrete class implementation logic to be written in. Yeah. Inheritance, how you map the inheritance in routine way, table per concrete class, what we can implement to map our relationship. Let's say we are configuring our class path. Let me show you the same. It's the same for two-wheeler, four-wheeler and the vehicle class, and the user class what we are generating. Four-wheeler, Hibernate util, your inheritance, two-wheeler, vehicle, and your Hibernate configuration. So Hibernate configuration, I need not to explain you, it is the same what we are using. Vehicle is here the same class, only the inheritance what we are mapping the way at the rate inheritance strategy is joined table. We are going to create one class or the joined table between the inherited class. So it's kind of the class or table per hierarchy. Okay, there is a two-wheeler entity, means two-wheeler as a class table will be created and four-wheeler table will be created. You're just mentioning at the rate entity. That means the name of the table is the same as the class name and the name of the property is the same as your property name what is been designed to. Okay, and Hibernate util is as usual you knowing. Okay, so let me just add execution to them. Okay, 3 sequence generated, vehicle class, table was already available. Two-wheeler and four-wheeler table was created to map your inheritance relationship. So four-wheeler and two-wheeler class. For steering wheels, bike steering. Okay, this is your inheritance relationship which is been mapped by the different classes and saving each object separately because this is inheritance. So you cannot expect it like getting stored as one-to-many or many-to-one relationship, right? Because they are the base class and the derived class relationship. You need to save them explicitly. Okay, fine. So that's all about your Hibernate and mapping the relationship and the classes.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
All right, let's focus on what is typecasting. So if you remember, while discussing the primitive data types, we verified that an integer could be typecasted to a float, or vice versa, with some loss of precision. So at that time, we only discussed about the primitive data types. Now, how does typecasting work in case of a superclass and a subclass? So we can always assign an object to a superclass variable, and that is known as upcasting. Okay, so let's take it for an example that you have a class parent and its subclass child. Okay, so you can always create a parent type of reference variable and point it to a class object in the heap. Okay, so that is always permissible. That is known as upcasting. Okay, and you can always assign an object which is referred by the superclass variable to a subclass variable, that is known as downcasting. So the example that we have taken is like, again, you create a parent type of variable, you assign it to its subclass, that is new child. Now you again create a child type of reference variable, so you can only assign it to, you can only typecast it to a child object if it is pointing to the subclass. Okay, but again you'll have to typecast explicitly by adding child in brackets before the parent. So let us take an example of what we have just discussed. Okay, so some time back we discussed about the rectangle and the square parent and child objects. So let us see if we can uh, create those typecasting objects here. So let's say that I'm kind of starting with the example of upcasting. So I'll say that a rectangle, I'll say parent object. Okay, it'll be kind of clear. So I can just say that new square. Okay, so by doing that, what I'm by doing this particular assignment, what I'm saying is I'm creating a square object that is a child or a subclass object in the heap, and I'm referencing to this particular subclass object using parent class's reference variable, which is rectangle's reference variable. Okay, so now that is a permissible thing. Now I can just call some of its methods, like say for example I can say that or let me do one thing, let me um, start it with some constructed integer radius. Let's say that the radius that I'm pointing is 6. So I can say that system.out.format, okay, the value of parents area is parent dot get area. Okay, now let us run this program. Now you can see the value of the parents area is coming as 36. So the thing is that what we have done is we have created a parent parent type of parent variable which is pointing to rectangle. Now when we say parent dot get area, it would go to the get area method of square and print its value, and because we are passing the value as 6 for the side, the value is coming as 36. Now one thing to note here is that this particular method, the parent dot get area method, the get area method would be called of the object which is created in the memory. It won't be called for the the reference variable that is pointing. So that is known as runtime polymorphism. Okay, the JVM decides which method to call depending upon the state of the object. It's not dependent upon what reference variable that object is being pointed by. So that is one thing that we need to take care. Now here in this particular case, you're seeing that it's called inside rectangles area method. That is because in the last example we had called the super dot get area. So if we just comment out this code, okay, and run the program now, so you're seeing that in this particular line you're seeing that you're going inside the rectangles areas method, but that is not the case. That only went because you had written super dot get area inside the get area method of square. So if we just comment out this method, let's see what you see now. So now you'll be able to see that you have reached inside the squares area method, okay, which is what is the expected outcome. You will always be seeing the method flow going inside depending upon the state of the object, okay, which is the object it's kind of available in the heap memory. That is a very important point, that is known as runtime polymorphism. Now having gone through what is upcasting, let's try and see what is an example of downcasting. So we'll take an example here only. We have said that we've created a square object pointed by a rectangle variable. So let's say I create another, I declare a square child object, let's say child. Now I can always do this assignment. I can say that child is equals to parent, and assign the proper class name in front of the variable. This is known as a downcasting. What I'm doing is I'm downcasting an object variable to its subclass variable, okay, which is child here, which is of square type. So this is a valid assignment. Okay, now I couldn't have done this particular downcasting had it been this example. Like I'll say that rectangle r1 is equals to new rectangle, okay, and if I like pass couple of values in this, so I cannot say that child is equals to square r1. So as I said that we cannot point this child variable to this r1 because the object which r1 is kind of is pointing to is rectangle, which is the parent here, okay. So now you see that I'm not getting any exception here or any warning of the compiler here. The reason behind, as I mentioned, that it gets decided at the runtime, okay, and that is what is runtime polymorphism. So if I execute my program, okay, so let's say that I'm just executing my program. I don't want to print any of the values of the child here. So you can see that the exception is coming here. It's a class cast exception saying that test1.rectangle cannot be cast to test2.square, and the reason is because square square object is a subclass and it cannot point to a parent object, okay. So this type of downcasting is not permissible. What is permissible is only this particular scenario here, okay. So that is one important thing that we need to keep in our mind. So that is as far as the upcasting and the downcasting goes. Let's move on to the next slide. So basically this instance of keyword, it can be used to test if an object is of a specified type or not. Okay, so for an example, let's say that I'm having a string variable, okay. Let's say that I've declared a string variable as hello world, okay. I can use this operator to figure out if this string variable is of type string or not. So if I use this operator saying that is this string variable hello world is instance of an integer, say, okay, so I'll get a boolean value saying it is false, okay. So that is the use of this instance of keyword. You can figure out at runtime, we had talked about runtime polymorphism, right? So you can figure out at runtime that this particular object, this belongs to this is of which object type, okay. If you apply this instance of on a null variable, null reference variable, it will always return as false, because as I said that it is used to figure out the type of the object in memory. Now if it's a null reference variable, it's not pointing to anything, okay. So for that reason it always returns as false. And a subclass, when is kind of is used against this particular operator. So say for example, it said that if child is an instance of parent, okay, so for that particular test, it will always return as true, okay. So let us apply this instance of operator on this rectangle and child subclass. So let us say that, if variable r1, okay, so this was one of the invalid things that we had done. So let us first of all just remove this. Okay, so we'll say that if child is instance of, say square. So we'll just print, in case this is true, we'll print. Okay, let's run this program now. So when we run this program, you see the output as it is an instance of square, so that means this child, which it's pretty much correct, is an instance of square, because parent initially was pointing to a new square object. So this is coming as true. Now let us kind of check this thing. If child is an instance of rectangle, okay, now let's run the program and see what is the outcome. So as we mentioned that this particular instance of operator will also work, because rectangle is also a square, correct? So that's the reason this particular test of instance of rectangle is getting passed. Now if we had declared that square child, and let's assume that it's not pointing to any object. So in case this particular square child is not pointing to any object, or let's say we have declared that as a null variable, okay, so in this particular case, because there is no object, it's kind of pointing to, let's see what this particular line is printing. Okay, let us see if this line gets printed or not first of all. So you can see this line is not getting printed. It is an instance of rectangle that's not getting printed. The reason is it's not pointing to any object in memory. Okay, so this is all on the instance of operator. So now what are nested classes? So any class which is defined within a class or an interface is known as a nested class. So traditionally we have seen that whenever we were defining the classes, we were writing a Java file in which we created a couple of skeletons for a class, and in case we wanted to write separate class altogether, we either appended the definition by the existing skeleton. So far we haven't ever written this definition inside an existing class. Okay, so in case you write a definition of a class inside an existing class, that is known as a nested class. Okay, now an example of that could be that how do you define that nested class? You can say that this is a class which is Java outer class. Okay, you can define your static variables, you can define your member variables, you can define your methods and all, and then within the definition, okay, within the definition of this class outer class, you create another class. Okay, so that is how a nested class is created. Let's quickly see a demo of how this nested class works. Okay.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below, and you can go check it out. Now let's continue with this session.
So what I've done here is I have created a nested class demo. Okay. Let me create another class here. Let's say inner class. Okay. Let me just define a method here that prints a value. So let's say that void print inner method. Okay, it doesn't expect any argument, and what we'll do, we'll just write sys out here, saying that reached in the nested class. Okay, so this is what we have done. We have created a nested class. Let me define the name as nested. I'll come to what are inner classes in a while. So let me, for the time being, kind of keep the definition separate. Okay, so okay, we have defined this inner class. Now let us define a void main method here inside my nested class demo. Right, Now, how do we create an instance of this class? What we'll say is that, say, nested class demo dot, nested class, let's say n is equals to, we create a variable of the outer class followed by saying that, new nested class. Okay, so this is how you see we create an instance of my nested class. This nested class is kind of, visible to an instance of my nested class demo. So for that reason, what I've done is I have created an instance of the nested class demo, which is, the outer class, and using that I'm using a dot operator to, specify the inner class. So this is how you define or access the member variables or methods, right? That's what we have been doing of an object, and we refer to its fields or methods or attributes by the dot operator. That's what we are doing. Using the new, we are creating the outer class, and for that outer class instance, what we are doing is we are creating the nested class instance. Once you have done that, what we can do, we can just say n dot parent inner method. Okay, now let's run this program. So you can see that we have reached inside the nested class. So this is how you define those nested classes. Let's see what are different types of nested classes we have. Okay, so here are different types of nested classes that we have. First is, so we broadly divide the nested classes into two categories. So one is the non-static nested class, the other is the static nested class. Okay, so when I say a class is a static nested class, the meaning is that I'm using a keyword static with that, and that particular inner class or the nested class, it doesn't require a reference or an object of the outer class to be created. Okay, you don't have to define an object for that, and that is how the static keyword is used, right? We've seen that for the other methods or the attributes. You don't have to create an object of the class in which that static attribute or method is defined. Okay, you can directly use that attribute by using the class name. Okay, the same goes with the static nested class. You don't have to create an instance of the enclosing class for using that nested class. That is a static one. And in case you don't specify the static keyword, that means you're kind of creating the non-static nested class, and for using them you'll have to specifically create an instance of the enclosing class. So in the demo that we had just seen, we witnessed an example of a non-static nested class. So talking about them, we have three type of non-static nested classes. One is a member inner class. Okay, so any nested class or any non-static nested class, which is defined like as an attribute is defined or as a class level method is defined, so that is known as a member inner class. The instance of that member inner class would be different for each object that is created of the enclosing class. Okay, so that is known as a member inner class. The other is a local inner class. Okay, so any class that you define inside some method, okay, that is known as a local inner class. You're not defining that class outside a method or somewhere else. You're defining it inside some method. That is the reason it is known as a local inner class. The last one is known as the anonymous inner class. Basically you don't create that class. Okay, what you do, you just provide an implementation of that class. Okay, you're not providing any name for that class. So in the example that we saw, we kind of created the inner class or the nested class inside. We had specifically given a name for that class. In case of the anonymous inner classes, we don't do that. Okay, so this example of the anonymous inner class would be kind of more clear when we get to it. When we see a demo of how it works, it'll be clearer. I mean, having gone through different type of nested classes, different type of having seen the example of how it is kind of operated,
why do we basically need these nested classes, or why do we need these inner classes? So we were saying that the inner classes were introduced in version 1.1 of Java, okay, and we've seen that in the object-oriented programming that the classes are kind of supposed to be specialized, because that kind of create the concept of greater usability and flexibility. And that the reason is because a class only needs the code that allows an object of that class to do whatever it needs to do and nothing else. That's the whole idea of object-oriented programming, correct? Figure out different objects, and depending upon what all functionalities they provide, what all specializations they do, and on the basis of that create different classes. Okay, but there are different situations when we need to write some code that it seems like it belongs to its very own class. Okay, at the same time the code that we want to write, it needs to be tied intimately to some other class's code. So the question is, what do we do in that particular situation? Okay, so in this case the inner class are kind of very useful. Okay, so let's take an example of how and why we need an inner class. So assume that you have a Java graphical user interface application, and it kind of acts as a chat client, just like you have Google Chat or Facebook client. So let's think about, what all method need to be present in a class like that is kind of exhibiting the behavior of a chat client. We need a method that reads the user input, whatever you type, okay, and when you press enter, it sends that message to the server, and the other person who you're chatting with, he should automatically get that message, right? So this is like an example of what all this method needs to do. Along with that, what we are supposed to do would be that as I said, that when you press enter key, this message that the user is writing, that needs to go to the server. Okay, so the press of the enter key is acting like as an event here, along with you're writing something and capturing that user input and sending that to the server. So now these are like two different things that we are handling here, right? But these two things, that is sending the message to the client, or showing the information of waiting for the event, that is the event handler. These are like two different things that we need, but these specifically are required for a chat client. That's correct, right? Now, and why this is required for a particular chat client? Because assume that a person XYZ is chatting with person ABC. So these event handlers and these methods need to be associated with different objects of XYZ and ABC. Okay, they kind of have to interact with them only. A chat client application can have thousands of users, lakhs of users. Okay, but the event handlers, they should kind of cater to the needs of XYZ and ABC simultaneously. Now for doing that, the concept of inner classes is kind of used. Okay, what you do is you create a class that takes in user inputs, and it sends the user input to the server. Then you create a class that shows the behavior of handling the event. When you press enter, it sends the message, or when you press some key, it sends the message to the other user that XYZ is typing. So you kind of create a class for that. Now you can say that what a person can do is he can write this code in different methods in the chat client class, let's say. Okay, but think about a scenario in which the event handler is kind of waiting for or is kind of extending some other classes inputs, or some other classes methods, and the class that kind of takes the user inputs and sends to the server, that is also extending some other classes attributes. Now in Java, we don't allow the concept of multiple inheritance, correct? So inner class kind of allow us to inner or nested classes kind of allow us to show that sort of functionality. Now what I can do is I can create a chat client sort of class. In that I can have two separate nested classes, one that takes the user input and sends the message to the server, the other that kind of takes care of the event handling. Okay, and both these two classes can extend from different classes. My chat client don't have to necessarily, extend any of these classes. It's not required for me to do. So that way I'm kind of solving the problem of, a multiple inheritance. I'm kind of implementing different, scenarios, and my inner classes are kind of helping me to do that thing. Okay, so as you've seen, better encapsulation, like say for example for the chat client taking in the input and sending the message, that class, it need not be used outside. Okay, so I kind of can provide better visibility scope to that class. What I can say that is that class is private and it need not be accessed anywhere else. Okay, I can kind of control that accessibility of my inner class. What it is also helping me to do is kind of provide a better modularity of the code. So we have seen that there are two different classes. One would be taking in the user input, sending the message. The other would be handling the events. So I'm kind of providing a modularity in the code. And as I said that each inner class can extend from its own parent class, irrespective of the outer class extending it. I'm kind of, taking care of that functionality as well. Okay, so that is nested classes are kind of used in Java. Okay, now let's move over to the next topic, which is the non-static nested class type member inner class. Okay, so coming to the member inner class. Okay, so any non-static class that is created inside a class but outside a method is known as a member inner class. So as we had discussed that any non-static class that we'll be creating and it's not inside a method scope is kind of defined like an attribute or some other method, that is known as a member inner class, because that can be accessed using an object of the enclosing class. Now the syntax, coming to the syntax of the inner class, we have an outer class. Okay, now for that outer class we'll be writing some attributes, some methods, and we'll be defining a class in a class here, and that can have its own set of code. All right, so for the demo of the inner class, what I've done is I've created a class that is the inner class demo. Okay, let us create a class, let's say outer. Okay, let's have an inner class for this outer one. All right, now let's create a private variable. Let's say that you have a private string, let's say str, and you just say that it's outer string. Okay, now in this class inner, let's define a method. Let's say that it's void print string method, and it doesn't take any argument, and what it does, it prints the value of this particular string. So the idea behind this particular inner class is that it can have an access on the private variables of the outer class as well, because it is one of the members of the outer class. So in case we would want to get a hold of this particular string, so what we can do is the value of, let's say, outers str is, let's just print the value. So we can just say that it is str. Okay, so this is one of the methods that we have written inside the inner class. Now let's write a main method for accessing this particular inner class. So as you already know that because this is an inner class and it's a member class, what we need to do, we need to have an instance of the outer class for accessing this particular class. So let's say that you have an outer class, let's say outer O, and you create an instance for that. Okay, once you have done that, so the way forward would be that we create the instance for the inner class as outer.inner. Okay, because it's part of the outer class. Let's say it is I, and you would say that O dot new inner. All right, so we had seen in the previous slide that how do we create the inner class in the same line. So this is the other method of creating the inner class. So now once we have done that, what we can do, we can just call the method of the print string method of this particular inner class. Okay, so this is the way forward for calling the method of the inner class. Now let's run this example and see what is the output coming. Okay, so you can see in the output, you can see the value is coming as the value of outer string is outer string. Okay, that means this inner class, instance of the inner class, has an access on the private member variable. Okay, so this was because this class was declared as a default one. Okay, so it's having an access here. Let's say if I try to declare that as a private class. Okay, so once you have done that, you can see that you get an error message here saying that outer.inner has a private access. Okay, so it cannot be accessed outside this outer class. Okay, so we don't have a way forward for accessing this. Okay, so this is one thing. Now other thing that I would like to demo here is that in case what happens is that this inner class itself has a string str. What happens then? What value would it print? So let's say that it is inner string, right? So you can see that the same string variable is used here and the same string variable I'm using here. And so if now I run the program, the idea would be it would print me the value of inner string. It will never say that the outer string, because the precedence is taken by the member variable of the inner class. Okay, so let's say if I now run the program. Okay, so you can see the value that is coming here is inner string. The value of outer string is inner string, which is incorrect. So I mean, how do we access that? How do we in case we want to kind of revert back to what we were doing for the outer classes string method? So how do we do that? So the way forward would be so basically this is the inner string method. Okay, the outer would be, we'll say that.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Outer dot this dot str. Okay, so if you remember, I mean, we had used the keyword this for referencing the current object. So in case we would want to get a hold of the parent class for a particular internal class, the way forward is to provide the name of the class dot this, so that gives an instance of the outer class, and just print this string forward for that. So if I now run the program, so now you can see you're having an access on the outer string. So in case you want to access the variables of the outer class, this is the way forward to do that. Otherwise the precedence is taken by the inner class member variables. Okay, now having done that, let's move to the next topic.
So interface is a mechanism by which Java somewhat achieves the concept of multiple inheritance. Now, we have some while back discussed that there is no concept of multiple inheritance in Java. That is, an object cannot extend more than one parent class. Okay, so I cannot say that the class, let's say for example the class dog, it extends animal, or it extends something else as well. So we cannot do that in Java. So Java restricts that. But there are a couple of advantages of having multiple inheritance. Like say for example, you would want an object to behave in a manner which is kind of similar to 2 or 3 different objects, right? So how do we kind of go about it? So Java provides a mechanism of having an interface using which 2 unrelated objects also can interact with each other. Say for example that you have a car object, okay, and the car object also has a driver. Okay, now the driver need not know how the internal mechanism of the functioning of car goes about. Okay, all he should be concerned about is that how does one start a vehicle, how does one accelerate the vehicle, how does one put a brake, okay, how does one steer a wheel. So these are the couple of mechanisms that is only expected by a driver to know. He doesn't need to know how the axle works or how the fuel is ignited in the the cylinders. He's not expected to know that, right? So these are like two unrelated objects, a driver and a car. So how do you kind of make these two objects work with each other? So you say that a driver says that car must provide some interfaces to me, that uh, how do I start a car, okay, how do I accelerate, how do I put brakes. So a driver says that I know only these things, and a car object must provide the exact implementation of whatever I know. So that is like a binding contract between a service provider and a client. So these are what the interfaces are meant to be. Okay, so that is like one of the examples. The other example you can think about is okay, let's say that a Windows machine is trying to implement a printer. Okay, now it doesn't need to know that if an HP printer is getting installed, or if say for example a Canon printer is there, or some XYZ companies creating a printer. All Windows says is that I should be able to print my document, and whoever is kind of providing me the printer, he should implement at least those methods. Okay, like say for example, the Windows would say that I'll provide a document object. Okay, use that object and provide an implementation to make it print. So now then the onus lies completely on the companies who are implementing the printers. Okay, they'll have to implement how do they take care of taking a document object and parsing it and sending it to the printer and printing it. How what should be the properties of the printable object? Should it be like in the landscape format? So these are like the different properties that a printer object should be taking care of. Windows need not be concerned about that, right? This is again an example of how the interfaces provide us mechanism of two different or two unrelated objects making interactions with each other. Okay, now in terms of Java, what an interface is nothing but a class file where all the fields are public, static and final. Okay, and all the methods are public and abstract. Okay, so when I say that, we have seen, I mean, what is the public access modifier mean? That it is accessible from anywhere. So what all variables, what all fields I'll be declaring inside an interface, those would be accessible anywhere, outside the package, outside the class, anywhere. Okay, those would be static. So when I say static, I mean for using those fields, I need not create an object of that interface. Okay, those could directly be used using the class reference. That is the meaning of static. Final, when we say final, it means that these cannot be changed inside if a class is implementing the interface or extending the interface. These cannot be changed at all. Okay, so this is what goes about the fields of the interface. The methods are public and abstract. So public, again, it can be accessed anywhere outside the class or outside the package by any of the classes, right? So that's for the public modifier. So the next thing is the abstract keyword that we are adding here. So whenever we say that a method is abstract, we mean that we will not be providing any implementation of the method. All we will say is that this is my method, this is what it expects, and this is what it would return. So we only declare a method, we never define the method. Okay, so that is the meaning of an abstract method. So all the methods inside an interface are public and abstract. There will never be any implementation details available in the interface. Okay, now having said that, and having tried to say that Java tries to implement some sort of the multiple inheritance using an interface, still it is different from a multiple inheritance. So there are a couple of similarities which we kind of discussed, but there are a lot of differences as well. So what are the differences? The difference is like a class can inherit the fields of a superclass, correct? But it inherits only the constants from an interface.
all the constants that we have declared, like all the fields which are like constants in the interface, only those can be inherited from an interface. In case of the inheritance, the multiple inheritance, a class can inherit method implementations from a superclass. So we saw at a couple of places that we were trying to figure out the area of a square when a square was extending a rectangle. So we had given an implementation of get area method in rectangle, and square class could have kind of reused that implementation. But in case of the inheritance coming via interface, uh, there is no implementation available, right? We just discussed that all the methods inside an interface are abstract. So a class which kind of implements that interface, it has to provide its own implementation. So that is another difference between inheritance and multiple inheritance and interface. The third thing is um, in case of multiple inheritance, the objects that I'm trying to inherit some properties or implementations from, they are somehow related, correct? That is the whole idea of having inheritance in place. But in case of interfaces, um, all the objects that are kind of implementing that interface, they need not be related anyhow. Like we just discussed that okay, let's take an example here again. So let's say that you have a company, right? And in this company you have a couple of employees, and you provide them stocks. So an employee object can also implement a printable interface that would you use that printable interface to print details of an employee. The same goes for a stock. You're giving some stock options to your employees, correct? You can use the stock object can also implement the printable interface, and it is again used for printing the details of a stock. Now a stock and employee need not be related. These are not related objects, right? So that is one of the other difference between multiple inheritance and interfaces. So let's now see that how do you create an interface in Java, and how do you use it. Okay, so let's start with the next topic, that is how do we create and use an interface. So this is how you define an interface. You know, so first part is you specify a modifier, whether it's public or private. Okay, that's an optional thing. Then you specify the keyword interface. After that, it is followed by the interface name. Okay, now the extents and the interface names, the following interface names are optional. If you want, you can add the extents, the base class of that interface. You can add that as well here. That would be followed by the statement block. So you can declare your variables here. You can declare your methods that need to be implemented, and if you wish, I mean, you can do not declare anything at all. So it could be like a marker interface. So an example for that would be a serializable interface, where there is no body inside that interface. Okay, so again, the modifier part is optional, extents is optional, interface names, again it would depend upon the extents, and the statement block. So everything else is optional here. Okay, now now assume that you have kind of created an interface class. The next thing that you would want to do is you need to create a class that implements that interface. Okay, so for that, I mean, again, you need to create a class followed by the class name and the keyword implements. Okay, now that can be followed by a single interface or multiple interfaces, because as you know that we have been discussing interface from the point of view of like the multiple inheritance. So you can implement multiple interfaces here. Okay, and because this class is implementing the interface, okay, it has to provide a statement block, and it has to provide the implementation of whatever methods were defined in that interface name. Okay, now let us see that how do we create those interfaces and how do we make use of them in an example. All right, so I have I have created a class interface demo for this particular demo. Okay, so let us first define an interface here. So let's say that this interface, okay, let's try and do one thing. Let's try to implement a program here
that we are trying to implement like two type of vehicles here. One is a gas vehicle and the other is the electric vehicle. Okay, so for both of these vehicles, what we are trying to do, we are trying to figure out what is the efficiency, what is the fuel efficiency. Okay, so because these two kind of vehicles would be kind of are both like different, and we want each of them to give me this method that it returns the mileage. Okay, so we can introduce an interface like say interface fuel efficiency. Okay, let's give the name as fuel efficiency. Okay, and let's say that I need a method, I need a float returning method that gives me the mileage, right? And that is it. Okay, so that is one of the ways of defining an interface. Let's say that I'm also kind of creating you know an attribute here. So let's define that for the sake of defining. I don't foresee any use of this as of now. So let's say that I'm defining that as an integer, integer, let's say test interface. Okay, all right, and let's say that the value is equal to 10. Okay, now let us define another class that implements this interface. Okay, so let's say the class is let's say gas vehicle. Okay, and it would implement the fuel efficiency interface. So okay, now once we have done that, now it gives us a warning saying that gas vehicle is not an abstract class and it needs to override the abstract method get mileage. So you can see that the method that we have declared here, get mileage, it's an abstract method. We have just declared it, we are just saying that it does not accept any parameter, but it returns a float value to us. Okay, we have just declared, we haven't defined the body for that. And the way to do that is, after writing the method name followed by the parameters, we just add a semicolon to that. So that way it's just like a method definition. And implicit, whatever methods you are declaring here, these are public abstract. Okay, so compile kind of pursues it, understands it like that. So you can just want and remove these two keywords from here. So it can as well be a float get mileage method. Implicitly it means it's public abstract. The same thing goes for this integer. It would be a public static final integer. Okay, so that is the whole idea. Let's kind of just remove these two keywords, public and abstract, and let's see what happens in the classes that are implementing it. So let's say that I have a gas vehicle here, and let's say that it it has run for some miles. So say miles counter. Okay, I'm adding a miles counter here. It has one of the attributes, and let's say that the other attribute is fuel consumed. Okay, so let's say fuel consumed, we'll assume that's in gallons. Okay, so these are the two fields of my gas vehicle. Now let's see that how do they implement this get mileage method. So for implementation of that, we need to have float get mileage. Okay, and it needs to return us a value. Now you can see as soon as we have created this thing, we are getting a warning saying that get mileage in gas vehicle cannot implement get mileage in fuel efficiency, attempting to assign a weaker access. Okay, now you can see that in the interface class fuel efficiency, we haven't defined any access modifier, and that is taken implicitly as public. Now the first lesson you have to take is that in case the class is implementing an interface, it cannot narrow the access modifier scope. So by saying narrow, we mean if it is public, it cannot be put in a narrow scope. So narrow scope would be a private, a protected, or a default. Now because we haven't declared anything here,
it is considered as default, which is a narrower scope than public. So we'll have to declare that as public. The point to note again here is that it's not, the gas vehicle is not an interface. So it's the public access modifier will not be implicit here. Okay. Now let's say that what we are doing is we are just we just return a value, like say miles counter divided by fuel consumed. Okay, that's what it is, right? Fuel consumed. Okay, so that should be it. We have created a class that is implementing this interface. Okay, now let's try and run this particular piece of code. So let's say that we have we'll create a main method here. Let's say public static void main, and we'll declare a argument array here. Okay, now we'll create a gas vehicle class. We'll say class gas vehicle gas object. Let's say gas object is equals to new gas vehicle. Okay, we set the gas objects miles counter as let's say that 100 miles. Okay, let's assume the the unit is in miles. Let's set the fuel consumed of this object as fuel consumed as in gallons, let's say 20 gallons. Okay, so let's print what is the efficiency of this gas vehicle object. We'll just say efficiency is dot get mileage. Okay, efficiency of gas vehicle is good. So let's run this program now. Okay, so you can see the efficiency of gas vehicle is coming as 5. So that would be like 5 miles per gallon. So that is how what we have done is we have created an interface here, and what we are doing is we have created another class that is implementing the interface, and we have overwritten a method. Okay, now another thing that I would like to show here is that this test interface integer that we have kind of created as an attribute of our fuel efficiency interface, we can always print that, as in we can always have an access on that. So let's say that I want to create I want to use that in my SOP here. Let's say that the value of test interface is, now we can directly write this test interface without giving any object reference, or it's a static variable. You remember, I mean, we have added that as a static variable. So if I run my program again, the get mileage method would be called and this value would be printed. So let's run the program now. So you can see the value of test interface is coming as 10. Another point that I want to verify, I want to show you is that let's say that I assign the value 200 to it. Now you see, as soon as I've created this assign statement, I'm getting a warning saying that I cannot assign a value to the final variable. Okay, so that again proves a point that all the attributes declared inside an interface are final. Okay, so if I run that, okay, I get it. Now this is an example of we kind of used an interface for a gas vehicle. Now we said that we'll be creating another let's say an electric vehicle that also implements this fuel efficiency. I mean, that's the whole idea of creating an interface. You would want 2 or 3 different objects sharing a common behavioral pattern. So this is known as a behavioral pattern because the gas vehicle and the electric vehicle, apart from gaining the inheritance from a vehicle class, they are kind of different, correct? So the mileage is one of the behavior that both these two vehicles show. So that is the reason I'm kind of keeping that inside an interface, and I'll be creating another class. Okay, let's say we create another class that is electric vehicle. Okay, I'll just make use of the same class here. Okay, so let's say the new name is electric vehicle. Okay, the new class name is electric vehicle. It also implements the fuel efficiency interface. For that, again, we'll keep an attribute miles counter, and we'll say that power consumed. Makes sense, right? It's an electric vehicle, so we'll say that power consumed in let's say kilowatts. Okay. The get mileage method again would be printing the value for the electric vehicle, and what we'll do is we'll return the value divided by the power consumed, the miles counter divided by the power consumed. Okay, makes sense. So now both the electric vehicle and the gas vehicle are kind of implementing the fuel efficiency interface. Now let's create another class of another object of electric vehicle. So let me just say that electric vehicle elec object, okay, is equals to new electric vehicle. Okay, we'll set the values of elect object as.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below, and you can go check it out. Now let's continue with this session.
So the mile counter again would be, let's say 100, and let's say that the power it has consumed in kilowatts is let's say 15. All right, so we would want to say the efficiency of the electric vehicle. So we'll say that electric vehicle's efficiency is ELC object dot get mileage. Okay, now let's run this program and see what is the expected outcome here. Let us first of all just remove this statement of printing the test interface attribute. It's not required in both the places. All right, now if we run the program, you can see the efficiency of the gas vehicle is coming as 5, and the electric vehicle is coming as around 6.6 miles per kilowatt. So that is what we have done here. We have kind of created two classes. Both are implementing the interface fuel efficiency, and we are using both of them to call a particular method and implement it in its own manner. So now let's move on to the next topic.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so the next topic that we have is extending the interfaces. Now, an interface, unlike other Java classes, can extend multiple interfaces. Okay, so so far we have seen in Java that you cannot extend more than a single class, right? But interfaces are an exception here. They can extend multiple interfaces. Okay, say a class is about to implement that extended interface. It'll have to implement the methods of all the previous ancestors. Okay, so say for example we have we declared like a fuel efficiency interface sometime back, right? Now assume that I create another interface, fuel efficiency 2, that extends fuel efficiency, and I create yet another interface, fuel efficiency say 4, it extends fuel efficiency 2, right? And each has its own method. Now if a class is going to implement fuel fuel efficiency interface 4, it'll do that by implementing the method specified in fuel interface 4, fuel interface 2, and fuel interface. So that is the way to go about. It has to implement all the methods. Okay, now let's quickly see in an example as to how this particular extending interface is required and why it is so useful. So we'll pick from the example that we have been discussing, right? So you have an electric vehicle and you have a gas vehicle, right? Both of them are implementing the fuel efficiency interface. Both of them return the mileage. Okay, so that is that method is defined in the fuel efficiency interface. Now let's say for example that you get another class of vehicle, that is hybrid vehicles. It's kind of combination of gas and electricity. Now along with getting the mileage, what other information you might need is that what is the exact fuel efficiency that my hybrid is providing, right? And what is the the electric efficiency that it is providing. Okay, I'll try to get the mileage on the basis of both these outputs. Now an option could be that I add those two methods in the interface fuel efficiency, but because of that what would happen is both electric vehicle as well as gas vehicle will have to implement those methods. So interface extension kind of comes to our rescue here. So what we can say is we'll create another interface. Okay, we'll say that it extends the fuel efficiency, right? We'll whatever interface that we'll be using to extend the fuel efficiency, will have to kind of will inherit this get mileage method, right? So any class implementing that new interface will have to implement even this get mileage method. Okay, so let us say that this new interface is, let's declare that as interface let's say hybrid efficiency. Okay, let's give some name to it, random name to it. Okay, okay, now we'll say that it will give us a method get fuel efficiency. And we'll write another method that gives us the charge efficiency. Let's say charge efficiency. Okay, so these are the two new methods that we are saying that this new interface would be kind of providing, and we want to use the get mileage method as well. So we'll say that it extends the interface fuel efficiency. Okay, now let us create that another new class of vehicle that we were talking about. So let's say that the new class is let's say class hybrid vehicles, and it implements, let's say it implements the hybrid efficiency. Okay, now as soon as we have declared that that will implement the hybrid efficiency, you see that we'll be seeing couple of errors saying these particular methods have not been implemented. Okay, so we'll similarly declare like two more variables here, like the miles counter and the power consumed. Because it's a hybrid vehicle, we'll add the other parameter as well, which is fuel consumed. Okay, we'll kind of consume both power and fuel. So we added like these three attributes here. Now we'll first of all implement what is the fuel efficiency. Okay, so we'll implement this method here. We'll say that fuel efficiency is just return the fuel consumed, sorry, the miles counter divide by fuels consumed. The same method was same formula what we have used here, fuel consumed. Okay, so that is the first method that we are implementing here. Again, it has to be declared public here. All right, the next method has to be the charge efficiency. So what we'll say is we'll create a new method here saying public float get charge efficiency. Use that. Okay, and what we'll do, we'll return the miles mile counter divided by power consumed. Okay, so these are as far as these two methods of the hybrid efficiency are concerned. Now you can see that we are still getting an exception saying that the get mileage method of fuel efficiency is not being implemented till now. Now again, that kind of proves the point that this get mileage method, because it's not defined here, but because hybrid efficiency is an extension of fuel efficiency, this hybrid vehicle will have to implement that method. Okay, so let's implement this method, get mileage, for a hybrid vehicle. Okay, so we'll say that it's a public method that returns a float. Now what it basically does, let's kind of just take a random formula that whatever is my fuel efficiency, okay, I'll say return my fuel efficiency, say multiplied by like say 5, half of what I'm getting from the fuel efficiency. Okay, I'll add like 0.5 multiplied by whatever is the charge efficiency that I'm getting. Let's say the charge efficiency. Okay, so we'll kind of give a combination of these two values, and it's let's put that as float. Okay, so 0.5 into the fuel efficiency plus 0.5 into get charge efficiency. Okay, so once we have done that particular thing, right, that is implemented the get mileage method. Now let us use this particular hybrid vehicle inside our main class, and let's see how it performs. Okay, so we'll use the logic of creating a hybrid vehicle. So hybrid vehicle hatch object equals to new hybrid vehicle. Okay, for the hatch object we'll set the miles counter as, again, let's say 100. Okay, we'll set the hatch object's power consumed, let's say 10 kilowatts, and this hatch object fuel consumed, let's say it's again 10 gallons. Okay, and we'll print out what is the mileage. Okay, so we'll say the mileage of the hatch object, the hybrid vehicle is this. Okay, let's run the program and see what happens now. Okay, so you can see the efficiency of the hybrid vehicle is coming as around 10. Okay, so this is how we made use of extending an interface, which was almost like having a it was kind of getting implemented by two other classes, and we didn't want to disturb them. So that is the reason we kind of opted for an option of extending an interface, because the new interface also we wanted the prior interfaces method being there. So this was an example where we were extending an interface. Okay, now let's move on to the next topic, that is how do we implement multiple interfaces. Okay, so the next topic, as we said, implementing multiple interfaces. Now a class can choose to implement from multiple interfaces. It has to decide that what all behavioral patterns it wants to exhibit, and using that it can pick up all the required interfaces. It then has to implement all the methods that are defined in the chosen interfaces. It cannot say that I'm implementing just 5 interfaces, but I'll implement the methods of only 4 interfaces. It has to implement all the methods that are defined that are applicable for those interfaces. As I said, that it is again helpful in spreading the concept of multiple inheritance, because that is the reason interfaces were kind of brought into picture, the idea of multiple inheritance. And here a class chooses to pick from different multiple behavioral patterns. So let's try to put that the example of implementing multiple interface in the example that we have been discussing. So let's say that that for all the vehicles that are kind of working on charge, that is both the electric and the hybrid vehicle, I need to kind of add another interface that changes that provides the option of changing the battery. Now as you know that both the electric and the hybrid vehicles would be kind of operated on some battery charges, right? That would be used to run the engine. So I need to create another interface. Okay, so that interface would kind of define a method that change the battery. Now that interface again would be common to the electric as well as the hybrid vehicle. So now let's see, if we want to implement that scenario, how do we do that? So in that case, till now, you would have seen that we have a fuel efficiency interface, we have a hybrid efficiency interface that is extending the fuel efficiency. Let's create another interface only for the battery operated devices, vehicles. So let's say the interface is battery machines. Okay, and let's say there is only a single method, that is void change battery. After a while, the vehicles are required to change their batteries. So that is the only method that it prescribes. Now since you see that this hybrid vehicle is type of is like a battery operated device machine, so it has to implement this battery machines interface. So how do we do that? We say that implements hybrid efficiency comma the new battery machines. So as soon as we added this new interface, you see that we get a warning message saying it has to override the abstract method change battery. Okay, so let's quickly add this method. So let's say this method is public method saying change battery. We'll just add a system.out.println here saying that change the battery of hybrid vehicle, change battery. Okay, similarly we'll implement this new interface for the electric vehicle. Again we are getting a warning saying that we are supposed to implement this change battery interface method. So let's use a similar implementation, that changing let's say changing electric vehicles. Okay, that is the way we have kind of implemented multiple inheritance for two of our classes. Now let's execute these methods in our main method. So we'll also say that electric object dot change battery. Similarly for hybrid object, we'll call the method change battery. Okay, now we'll run the program and see what is the expected outcome here. So you can see that efficiency of gas vehicle is 5. You're getting a new line here saying changing electric vehicles battery, and then you get the efficiency of electric vehicle, and after that you get changing hybrids battery. So that's it regarding the implementation of multiple interfaces. Now let's quickly see a scenario in which we had discussed some time back the concept of polymorphism. So we can create the reference variable of a superclass and point it to the subclass object right in the heap, and depending upon what sort of the object is created in the heap, that method would be called, that overridden method would be called. So that was like the polymorphism runtime, right? A similar thing happens for the interface as well, right? So let's quickly see that behavior. So let's say that we have this interface battery machines. Okay, it implements a single method, that is change battery. Let us create two more classes here. Let's say that class A that implements this battery machine. Okay, it has to implement the change battery method, correct? Because that is the only method which is available in the battery machines. So we'll say that changing, let's say, A's battery. All right, let's say there is another class B here which has exactly same behavior as class A. Okay, we'll say that class B, it implements battery machines. Okay, it implements that behavior of change battery. It says that, changing B's battery. Okay, now let's define the object of battery machines. Okay, so far we have seen that, all the objects that we have created were of classes which were implementing the interfaces. Now let's create an object reference of the interface variable. So let's say that, I have a battery machines, say VM object, and let's initialize it with new A. Okay, that is the first object that we implemented. Now let's say that VM object dot change battery. Let's call this method. Okay, now let's see how it prints. So you'll see that we are getting the sys out here saying that changing A's battery. So it is calling the method of class A. Okay, that is implementing this interface. So that is like again a useful example. Let's say that we now declare this VM object. Let's say that's this VM object. Now we create another variable of class B. We created another object of class B. Okay, and again if we call the method of clear data, change battery on VM object, we'll be seeing that you're changing B's battery. So let's run this thing again. So here you see that depending upon the type of object, I'm seeing the method being called. So I'm right now into changing B's battery. The object reference variable, that is battery VM object, it's of type interface, but the object which it is pointing in the heap kind of keeps on changing. So depending upon that object state, it is calling the method. Okay, so this is as far as the concept of interfaces go. Let's start with what is an exception. So while running a Java program, if the program fails, because of some issue, because of some memory issues, or the way the program is coded, or if it's trying to access a resource which is not available. So these are a couple of reasons why your program might fail, right? So what Java does, it encapsulates all those error conditions and the reasons why it happened, and it encapsulates that and into a Java object and throws it back to the running code. Okay, so that what can happen is the code can then examine that Java object. It can figure out the reasons and causes, and accordingly take a corrective action. So that is known as exception and exception handling. So this exception is basically a subclass of throwable. So that is the main class out of which this exception kind of derives its attributes. There are like two types of issues that can happen in an application. Okay, so consider an issue that say for example your JVM is running for a long time and the heap memory kind of goes out of control. Okay, now it's not even able to create a single object. So in those scenarios, what happens is the JVM itself throws an issue like out of memory error, and because of that the application cannot proceed. So until unless you terminate your JVM and restart the process, you won't be able to work further. So these are known as like the fatal errors. That's what we call them. These are the fatal errors. Or there is a class in Java that is the error class that denotes all those fatal errors. Okay. There could be a couple of scenarios like say you're trying to access a web app or some application or some site on the browser. Now it might happen that that site is temporarily down, right? So the browser does, it kind of allows you to browse other sites. It doesn't stop you from doing that. Okay, so that is known as kind of a graceful handling of an issue. Okay, so this is an example of exceptions that come. So another example of an exception could be that say in your Java program you're trying to access a system file, and you're trying to read its value and copy those values in some other file. Now, what can happen is that you take this file, the path of the file as a parameter from user. It's like a user input. Now, assuming that user enters some incorrect value and you're not able to find that path. Okay, so that is again an exception that is coming. It's coming only specific to your program. Okay, even if your program terminates, there are a couple of other programs that can run on this JVM. So what you can do, you can kind of handle that particular issue of saying that this particular file is not found, can you please enter again. So that is the scenario that we'll be kind of dealing with in this particular module, that a user gets an exception, and how does the programmer gives him a different option to handle this particular issue. So that is the exception handling. As you would have kind of understood that the whole idea of doing this exception and exception handling is it is kind of useful in providing answers to what all has gone wrong, how it has gone wrong, and where all things were incorrect in the code, and more about and more importantly, how do you proceed from there. So these are like the more important points that we'll be kind of considering in this particular module. So let us kind of write one of our programs that would tell you that how these exceptions come. So here what I've done is I've created another class, exception demo. Let me write a main method here. Okay, so let us say that what this program does is that you're having a specified number with you. Okay, and you're trying to figure out what all are the possible divisors of those of that number. So say for example your number is like 25, so you'll give the answer as 1, 5 and 25. So these are the possible divisors of number 25. So how do you write that program? So let's say that you define that number. So let's say that int number is there and you define it with some value. Say for example I'll start with 25. Okay, I'll say that this number is 25. Now I want to figure out all the divisors of 25. So how do I go about it? I'll start with the for loop. I'll say that int I let's say is equals to 25. I'll start from 25. I should be less than equal to 0 and I minus minus. I'll reduce the value of 5. Okay, now I'll check that if num percent 25 is equals to 0, sorry, num percent I is equals to 0. So if this particular condition is true, that means the quotient that you're getting after dividing this number is equal to 0. So in that case, let's say I'll print system.out.format. Okay, I'll say that percentage divides percentage. The arguments that I'll give is I divides your number. Okay, and I'll add a new line character here. So that way I'll see that what all are kind of the numbers that are kind of getting divided by this. So let's say that I is greater than equal to 0 and run the program. Now you see here what has happened is we are seeing that 25 is divided by 25. So that output is coming here. Then 5 gets divided, 5 divides 25, even that is true. 1 divides 25. So even that is the correct case. Now what you are seeing here is we are getting an exception that says that exception in thread main java.lang.arithmetic exception divide by 0. Now you see what has happened here, that now we are trying to iterate from the values of I equal to 25 till I equal to 0. Now what we should have done is we should have just kept the divisors like max till 1. It shouldn't go beyond 1, right? Because anything you divide by 0 you'll be getting an issue, because that is not permissible. So this is the mistake that we had made, right? Now what we didn't want to do was we should have just kept as I should be greater than 0, not equal to 0, and this particular iteration wouldn't have happened, right? Now, say for example, if we run this program, we are good, right? 1 divides 25 and the program stops here. So now let's say for instance that if a user has kept I less than equal to 0 here and the program is running. So this particular exception comes, right? The arithmetic exception divided by 0. Now this is an exception that we would be kind of focusing, right? How do we kind of make sure that because of a programmer's mistake or some bugs in the program, a user doesn't see these exceptions, right? How do we kind of gracefully handle that? So that would be the next topic, the constructs to kind of handle these exceptions. Okay, so let's move to the next topic. So now, having seen that how the exceptions come in the program, let's now focus on how do we handle these exceptions are coming in our program. So let's move on to the constructs here. Okay, so these are the three important constructs which will help us in dealing with the exceptions here. So the idea is that we enclose whatever statements we have in our program between the try block. Okay, so this is our try block, and we write all these statements within this try block. So what would happen is, in case any exception that comes up, okay, that would be it'll kind of the execution would go inside the catch block. So there is a subsequent catch block that we need to write after the try, okay, which takes the parameter as the exception. Okay, so say in the example that we discussed right now, the exception was the arithmetic exception, right? So automatically the control would go inside this catch block, and we can write our statements to handle this exception. Like say for example, we can just print on the console that this particular issue has happened. Okay, like you have tried to divide 25 by 0. Instead of showing all the all the warnings and all the errors in red, we can just put up a system.out.println. So that would be like a graceful handling. Okay, then this catch block that gets followed by the finally block. Okay, the idea behind the finally block is that you can have your program that needs um, some resources, like some files to work with, or say for example some DB connection or a net connection. So these are a couple of things that your program might need, right? So these are like the resource intensive things. So what advantage this finally offers is that uh, after the try block, the control will always go to the finally block, irrespective of if the exception has happened or not. So in case the exception happens inside the try block, the control goes inside the catch block for that exception, and after that the control comes to the finally block. Okay, so this is basically used for either handling the exceptions or doing a code, doing cleanup for, like, you're closing a particular resource or you're closing a connection. So that sort of cleanup activity you can always do inside the finally block. So one of the things which is mandatory is, in case you want to handle an exception, is that you're supposed to write your statements inside the try block, and that can either be followed by a catch block or a finally block. Okay, so this catch and finally are kind of optional. Either of one has to be present. Okay, both of them can come, one of them can come, but after the try block there should be either of them that is coming, right? At least one of them should come after the try block. So these are the kind of rules of the try, catch and the finally statements. Okay, so let us now go inside the same program that we had written, and let's see that how we can make use of try, catch and finally constructs to handle the exception that we got. Okay, so let's say let's move on to this thing. Okay, so let me run the program again. Okay, so you can see that the program we had like 25 and we figured out all the divisors. It came till 1, and as soon as the value of I started becoming 0, became 0, it gave us an exception saying that it's a java.lang.arithmetic exception divide by 0. Okay, Now let's say if you want to handle this particular piece of code, so what we can do is we can start a try block, put a catch block after that. So let's say that we are just expecting some exception E that is coming inside the try block. Let's say that we are saying system.out.println, let's say some exception has happened, okay, and we are inside the exception block. Okay, so let's print that statement. Okay, now let us see if we run our program now, what would happen. We'll come to finally in a while, but let us see how this try and catch blocks behave. So if we run a program now, okay, so there you see that the control is coming inside the exception block. Now you no longer see the exception that is coming. So the arithmetic exception, I mean everything that has gone. So all you see on the console is that some exception has happened and we are inside the exception block. So that is, you're gracefully handling the issue that has happened. Okay. Now one important thing to note here is I need not put anything inside the catch block. It can be empty. It need not do anything. So I have commented this system.out.println line. Let's see how it functions. Let's run the program again. See, now I'm not getting anything at all. So that means I need not put anything inside the catch block. Okay. Okay. Now let's see if we put a finally block. Let me uncomment this thing as well. It'll be kind of clearer. And let's put up an SOP here that, we are inside the finally block. Okay. So now if we run the program, you see now we have put back these system.out.println that exception has happened. So we'll be seeing this line, and because it's a finally statement, irrespective of any issue is coming here in the try block. Okay. So this is our try block as of now. So irrespective of any issue that comes up in the try block, the control will always go inside the finally block. So let's run the program now.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So okay, now you can see that there was some arithmetic exception coming. So the control reached inside the catch block saying that some exception has happened and we are inside exception block. But after executing that, the control has gone inside the finally block saying that we are inside the finally block, which is evident from here. So that is the flow of execution. It starts from the try block. It tries to see if it is some exception is happening. The control comes to the catch block, it executes what all statements are required, and finally it comes to the finally block. Okay. Now one more thing that we need to keep in our mind is that as soon as some exception happens inside the try block, the control directly shifts from that statement to the catch block. It doesn't execute the try block completely. So let us try to analyze that as well. So let's say that instead of starting from I is equals to 25, let's start from I equal to 0, and let's say that we are checking if I is less than equal to 25. Now in this particular iteration, think that as soon as we are starting with I equal to 0. So in the first iteration itself, that num% I is equals to 0, this particular operation would fail. Okay. The reason is I equal to 0, we are starting from the first iteration. Okay. And we are trying to divide a number by 0. So this would fail and the control would come here. So you won't see, the other divisors like 1, 5 and 25, that as of now what we are seeing is 25, 5 and 1. These are the three divisors that divide 25, and the exception happened when we came at 0. But now from the exception starts with the iteration starts with 0, so we won't be seeing any other things here. Okay, so let's see how the program runs now. Okay, so you see it did not execute, it did not go further with the iterations, and as soon as you started with 0 here, you get an exception here, you go to the catch block, you print that some exception has happened, and you say that we are inside the finally block. Okay, so that is one of the real important points to take from here. As soon as the exception would happen, the control would shift from the try block to the catch or finally block. Okay, now one last point that I wanted to show here was that if any exception is not happening, we are kind of going good. So let's say that the programmer corrects his mistake and changes the value from I equal to 1 and puts and checks if I is less than equal to 25. So in this particular case, you shouldn't be seeing the arithmetic exception. So let's see how the control goes. Okay, so this is out. Okay, you see that some exception has again happened, and the reason behind is that we are, instead of doing I plus plus, we are doing I minus minus. So you see, I mean, that is the beauty of exception handling. It tells you that some issue has happened with your program in a graceful manner, and you can correct it out. So we updated from I minus minus to I plus plus, and hopefully now we shouldn't be seeing any exception. Okay, so let's run it again. Okay, so you can see that we start with I equal to 1, it's going good. I equal to 5, it's giving. I equal to 25, it's printed. The control never went inside the catch block, but it went to the finally block. So that proves our point, saying that even if there is no exception, the control goes to the finally block. Okay, so now let's move on to the next topic and see that how do we take care of the situation when there are chances of multiple exceptions coming up. Okay, how do we handle that scenario? So let's check that as well. Okay, so coming to the next topic that I mentioned, that we'll be seeing how do we catch multiple exceptions if they come inside our try block. Okay, so I've created a new class here, multiple execution demo. Let's write a main method here. So let's first of all create a mechanism for taking the user input. So just assume that this is the line of code that I'm writing just to take user input. Okay, so saying that buffer reader br is equals to new buffer reader new input stream reader. Here I'm taking system.in. Okay, now having declared this the buffer reader, let's create a new URL string. So let's create a new URL string and let's say that br.readline. Okay, so this URL string would now be having the input from the br.readline. Now you can see that it's already giving us as a warning of saying that it throws an exception and this must be caught. So let's declare everything inside a try catch block. Okay, let's for the moment say that it is throwing some exception e where we say that reached inside exception block. Okay, and let's add a finally block as well here. Print the same similar line here and say that reached inside finally block. Right, so now we have got the input in the URL string. Now let's create a URL object here.
All right, so this would create a new URL object for us. Okay, now let's use this buffer data BR object having taken the input from the console. Let's reuse it, and let's say that whatever URL the user is given, we'll try to open that and take the inputs. So it would be open stream. Okay, so that way what would happen is that whatever input the user has given in this particular URL string, a new connection would be opened, and whatever output we are coming getting from this URL.openStream, we'll be storing in the buffer reader. Okay, now once that is done, what we'll do, we'll just print whatever value is coming from this URL. So okay, let's say that so the new value that is coming from this URL string is br.readline. Okay, so we are good. Okay, let's run this program now. Okay, so let me just go through the program once more. Okay, what we have done is we have taken a buffered reader, which is taking whatever value the user is giving into this URL string. Okay, then I've taken a URL object which would be kind of assign the value that the user has given. So that value is coming from the URL string. I'm using this buffer data again to open URL object, and basically we'll call the function openStream that would get the response from the URL, and we'll just print it out here. So the idea is, I mean, if we are getting an exception, this is the code that would be called. Okay, now let's first of all run this program and see what is the expected outcome here. Okay, so now you can see that it's waiting for the user input. Let's say that we are giving the user as google.com. Okay, so you can see that I'm getting the output here in the format of the response that is coming from Google website. Okay, so this is like the happy scenario in which everything is functioning perfectly fine. Now let's say what happens if the user is giving an incorrect value. Okay, so let's run the program again.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below, and you can go check it out. Now let's continue with this session.
Okay, now let's say that user by mistake forgot to enter the HTTP part incorrectly. Okay, so ideally you should be getting a URL malformed exception. So now you can see that it has reached inside the exception block. Now this was a similar example that we kind of verified some time back for the normal exception. Okay, when arithmetic exception was thrown to the user. Okay, it was a single exception, so we went inside the exception block. Now we let's first of all write the different type of exceptions that we can get here. So one of the exceptions is the IO exception. Okay, if the user has given a URL which is not returning anything, or say for example the website is down, in that case what would happen, you'll throw an IO exception that this particular line, because the stream won't return you anything, so you'll be getting an IO exception because of this line. So let's catch that IO exception. Let's name that as IOE. Okay, and let's print a similar line here. Let's say that reached inside exception block, IO exception block. So that would kind of make things easier for us. We'll add the import for that. Okay, now one important thing to note down here, the order in which we have placed our catch block. Now we could have kind of just removed this exception block. Okay, but the idea here is that we add this exception block for the catch block, which is you are using the exception object, because that would be like the super class of all the exceptions that are coming. Okay, like the IO exception, or a net malformed exception, URL malformed exception. So all these exceptions are subclasses of exception class. Okay, so the idea is as soon as the control kind of
goes through the try block, if it faces an exception, it tries to match the exception starting from the above the first catch block. Okay, now if it's an IO exception, the control goes here. Okay, if it's like okay, let's write a malformed exception as well. Let's say that the exception that we are getting here at malformed URL exception. Okay, so let's use this. Let's say malformed URL exception. Let's say MUE. Okay, let's just print this line. Okay, region side malformed URL exception. Okay, so this is something that we have been discussing, the placement of the catch block. Okay, one particular item to note here is that as I was mentioning, that all the subclasses should come above. Okay, the order of execution of matching the exception is always in the order of the catch block occurrence. Okay, so if we are getting the malformed URL, okay, the control would go here. If we are getting an IO exception, the control would go here. If none of the exceptions are kind of matching here, the control goes to the superclass that is exception. Now what if you would have seen that as soon as I had placed this malformed URL exception here, the idea was it is saying that exception is already been caught. That means this malformed URL exception is kind of a subclass of the IO exception. Okay, now because of runtime polymorphism, what might happen? Any malformed URL exception that you're getting would be kind of assumed as an IO exception itself, because the malformed exception is also like a IO exception. Okay, because it's a subclass of IO exception. Okay, so that is one important thing that we need to keep in our mind. We'll always start with the the subclasses of exception, and then kind of increase the hierarchy, and till the end we'll go to the exception block. So that is one thing to keep in mind here. Now let's say that now we run the program here. Okay, so let's say that the user has kind of forgotten like the P in the HTTP protocol. Okay, and he has just said that google.com. Okay, now when we run the program, you can see that the control is going inside the reached inside malform exception block. Okay, it did not go to IO exception, it did not go to the exception block, it just went to the reached inside malform exception block. Okay, and after doing everything, it went to the finally block. Okay, now right, now let's run the program and see that what happens in case you get an IO exception. Okay, so now let's say that I'm passing this let's say the site becomes down, right? So send the request here. The program is waiting for the output from google.com/8181. It'll kind of keep on polling, and it'll keep on waiting for the response here. And eventually when the response doesn't come, yeah, you can see that now the control has gone to the IO exception block, because there was no when it tried to do the open stream url.open stream, it went inside this particular line through an error, the IO exception, and it went inside the IO exception block. So you can see the control did not go to the malformed exception or the exception block. It went into the correct exception block. So that is as far as the catching of multiple exception goes. Again, just to reiterate what we had gone through, always start with the subclasses of the exceptions. Okay, and only at the end add the catch exception e block. That kind of takes care of any unknown or not taken into account exceptions at runtime which can come. Okay, so for that keep this catch exception e block. Otherwise try to keep the exception block as specific as possible into the catch thing. Okay, now let's see the next topic we have, that is the classification of exceptions. Okay, so far we have seen that you know in the last program we saw that there were a couple of exceptions like malformed URL exception or the IO exception that were coming. So we also witnessed that there was this arithmetic exception came when we try to divide a number by 0. Okay, these were the couple of exceptions that we had seen in the last slides. Now there is this classification of exception. That couple of exceptions are there which the compiler kind of guesses that these might be thrown at runtime. Okay, like say for example, if I'm trying to open up a file and that file does not exist, so I'll be getting an IO exception, right? So these are a couple of exceptions that a compiler kind of knows beforehand, and it will force you to handle these exceptions. Without you handling those exceptions, the compiler will not allow you to run the code. So these are known as the checked exceptions. So a couple of examples of the checked exceptions are the IO exception or the file not found exception or the malformed URL exception. So if you're using kind of the constructs like trying to read input from a file or open up a URL, so these are a couple of places where you'll be kind of forced to check these exceptions, okay, or rather handle these exceptions. Okay, there are the other type of exceptions which are kind of the runtime exceptions. So we saw the arithmetic exception which we got, right, that this the number because of the iteration turned out to be 0, and we divided the number like 25 by 0. So this is sort of a thing that compiler will not be able to guess, and it will not be able to force the programmer to handle those exceptions. So those are the runtime exceptions or the unchecked exceptions. So some examples of those exceptions are the arithmetic exception or the array index out of bound exception, where you're trying to access an element in the array, but the size of the array does not allow you to do that. So in that case you get array index out of bound exception. So these are the exceptions where you won't be forced by the compiler to handle, albeit there is a process of throwing an exception that I'll kind of go through, and that will help you to handle those exceptions as well. So let's now see that how do we kind of have an understanding of the checked and the unchecked exception via code. Okay, now let us create a new file here. Let's say that class exceptions demo.java. Okay, so this is a classification exception demo. Let's kind of make use of the hybrid of what all demos we have seen here. Let's first of all start with some static void main method. Okay, so in this program what we'll do, we'll write two static methods. One that takes the user input, okay, and second that kind of gives us the divisors, that prints the divisors of the number. Okay, so let's write those two methods first of all. So we'll see that it's a public static, and let's say it kind of gives you an input in the integer value. So let's say int read data. Okay, and what we'll do, we'll kind of make use of this buffered reader thing and read the data from the user. So we'll say that buffered reader. Okay, so we'll start with, okay, we'll import these classes, take the, so this buffered reader is taking the input from the user, and we'll take the string number will be the br.read line. Okay, and we'll convert that to an integer using integer.parseInt. Integer return value is equals to integer dot parse int this number that we are getting number. So let's say that as number string. Okay, so that is the number string that we are getting here. Now you can see that the compiler is kind of asking us to say that these are the it is the unreported exception, IO exception. It must be caught or declared to be thrown. So let us kind of first of all start by seeing the process of how do we enclose that in the catch block. Basically I'm just handling the exception as of now here. Okay, irrespective of the type, I'll just say exception E. Okay, because it's a parent class, it will kind of satisfy this particular scenario. I'll say that system.out.println, saying inside the catch block. Okay, so that's the way I've kind of handled my the read data method. I'll call this read data method from my main method. Okay, I'll say that it integer input is equals to read data. Okay, so that is how I'll be getting my input. Okay, just a thing here, we'll have to return the value here. Okay, return retvel dot int value, because it's the integer that we are declaring here, right? I'm sorry, I could have just kind of taken an integer here, so I'll just say int retvel and integer return value. And since this particular thing is placed inside the if block, inside the try block, we'll have to declare it outside because the scope would be kind of getting limited. So we'll just declare it here. All right, now having gotten this retvel, let's once run the program and see what is the input that we are getting, just for the sake of verification. So we'll use the SOP and say that getting the input plus input. Okay, now let's run the program once. Okay, so I'll say 25 and I'm getting the input as 25 now. So we are good on at least the input side. Now let's write the next method that is kind of that is give us all the divisors of that. Okay, so let's write that static method that would kind of give us that would print all the divisors for the input number. Let's say that public static void, let's say print divisors. Okay, takes an input parameters input in. Now use the exact same method which we kind of used from the exception demo. We just copy it over there. Okay, so basically what I'm doing is I'm kind of taking an input number. Okay, I use its value and I kind of print all the divisors of that. Now I'll just call this print division method from our main method and we'll pass the input to it. Okay, so that way it'll print us all the required the divisors. Okay, now let's run this program once. So let's say I'm kind of giving some input like I think let's say I'm giving an input like 56. So it's getting the input 56 and then it gives us all the respective divisors. Okay, it did not go inside the exception block because we had if you remember, we had modified this int I equal to 1 and we went on till there. Now had it been like 0 and if we run the program, so let's run the program putting that as 0. Okay, if I put again 56, you see the some exception has happened and we are inside the exception block we're getting. Okay, now that is something that what we are doing here is that in the first read data method, what we are doing is we are kind of making sure that this is the exception that we are catching, because you remember, I mean, this br.read line, as soon as we wrote this line, we were forced by the compiler to add to handle the exception that was coming out of it, specifically the IO exception. Okay,
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now let me just take that IO exception. Okay. Now, so this is as far as the IO exception goes. Now, now here till here we are fine. Now assume that in this particular thing we are just saying that that is the exception which is we are kind of getting a hold of into the print divisor method. But you remember, if we had like kept I equal to 0, we get an arithmetic exception, right? Now arithmetic exception, whenever we kind of try to add this particular piece of code, we were not forced. So say for example, I can just comment out these lines, this try and the catch block. If you remember, for the first time we did not have these try, catch and exception blocks. Okay, you see, we are not getting any warnings here to add any like exception thing, because the arithmetic exception is a runtime exception. Okay, so we won't be forced to kind of get a hold of that particular scenario. We can just try and catch that. Okay, it's kind of up to us. Now how do we make the the compiler ask to handle those exceptions? Okay, so that's where the concept of throws comes into picture. Right, so now you have seen that we have just commented the code for the try and catch in the printf method. Okay, and you can see we are not getting any exception or the warnings here by the compiler. Now what happens, I mean, in case we want the users to know that my particular method, that is the printf method, is kind of capable of throwing some exception, and better you handle it. So that is the way of telling a programmer telling to the end user that I'll just write this method, and I suspect some exception would be thrown by my method, but I don't wish to handle it. I'll tell you that this might be the exception that is coming out of my method, but you better handle it. Okay, you better handle it in whatever scenario you would want to do. So in those cases we write the clause as throws. So this throws block would kind of help a programmer tell to the end user that this is the method that can throw this exception, so please handle that. Okay, so let's say that this particular piece of code is throws. We'll say that it throws some, say for example, it throws some IO exception. Okay, now as soon as we have kind of written that, you see that you're getting a compiler issue here saying that this is an unreported exception, IO exception, which is happening inside the printf block, better handle it. Okay, so for doing that, what we need to do, we need to write this printf method inside a try and catch block. Let us also say that this read data method, now this read data method can also throw the IO exception. So just say it throws an IO exception, and let's not do the try catch thing here. Okay, let the calling method take care of the exceptions here. Okay, so we say that it throws an IO exception. The other thing to note here is that because we are kind of doing here the integer.parseInt of a string variable, it can also throw a number format exception. So let's say that it also throws a number format exception. And you can just comma separate the exceptions that your method can throw. So that way what would happen is, now if you see, the read data method is also showing a warning saying that there is unreported exception, IO exception, it must be caught or thrown. So what we can do, we can put everything inside the try catch block in the main method itself. Okay, so that way what is happening is the calling method is taking care of the exception. How does it want to deal with the exception? I mean, it's kind of entirely up to the calling method. So let's say that we are saying the IO exception, IO, we'll just print some value, and we are also catching the number format exception, which is again a subclass of IO exception. So we'll have to make sure of putting that above the IO exception. Let's say number format exception, and we'll print some value like system.out.println inside number format exception. Let's say that we are inside an IO exception. Okay, and finally we'll say that we are inside finally, and we'll just close the buffer reader. Let's go close the buffer reader here itself, okay, because we haven't declared that inside the scope of the main method. So let's put the br.close. So this finally method is really important in case we would want to close all the resources as we had discussed. So now let's run the program and see what all are the different outcomes that can come out of this program. We'll again browse through whatever we have written. Finally, we have a try catch block in which we are kind of calling a read data method and a print divisor method. Okay, this try block is followed by two catch blocks. One is the number format exception NFE, and the other is the IO exception. It's always better to write another exception block just to handle any other form of exception which is not a subclass of IO exception. So it's always a good practice to write that. So we'll just say that inside exception block. After that, we have written a finally block. The print divisor method is kind of iterating, and it gives us all the divisors of the input data that we are sending. Okay, it also throws an IO exception. The read data method, it takes in the user input parameter, it converts that to an integer, and it throws number format exception and IO exception, and it returns an integer value. Okay, all right. Now let's say that we have a number 56. We're getting everything correctly. We are finally getting inside the finally method. Let's say that we are running the program again, and let's get some wrong input like a string input. Okay, so we'll say that inside number format exception and inside finally. All right, so this is the way of looking forward to the checked and the unchecked exceptions, forcing the programmer to take care of the exception by using the throws block. All right. Okay, so now let's move on to the next topic of creating the user defined exceptions. So these all exceptions were the one which are kind of coming in as part of Java API, right? Let's now define the user created exceptions and then see how do we make use of them.
All right. So the next topic that we have is how do you create your own exception class. So there are a couple of cases, and when programmers, they just want to hide all the elaborate stack trace that comes along with the exception. Okay, all they want to tell the user is that okay, this is the exception that has happened, and please take this corrective action. They would not be interested in showing that from where the issue has come, or showing the java.lang. Those sort of system messages. So for doing that, what users can do is they can create their own exception classes. Okay, it can also happen that there are a couple of exceptions for which Java does not provide any exceptions, right? Like say for example that you are in a medical diagnostic center, you're taking the blood sugar samples for people before meal. Okay, so the normal sugar level is like between 70 to 130. Okay, now we've taken around, let's say, 120 samples. Okay, and in case if a person's sugar level is coming below 70, you would want to throw some flag or some exception saying that okay, this user has got a low
sugar level, or if it is like greater than 130, then you're supposed to show another message saying that this person has got high blood sugar. So you can do that via using your own exception classes. So one thing that we need to keep in mind is that all the exception classes that we develop, these should always extend the exception class. Okay, so let's quickly go over how do we create our own exception classes, and how do we make use of them. So let's create that like user defined exception class. Okay, okay, let's say that I'll first of all create a main method. So let's say that I have an integer array. Okay, I'll say that in this integer array I have sugar data, let's say that it's of 10 patients. Okay, so let's say that we have the sugar data for 10 patients. Okay, let's kind of initialize here only. Let's say that we have people with sugar level 80, 90, 67, okay, 132, and let's say 110. So these are like let's create just 5 records here. Okay, so this integer array would be having sugar data for 5 patients. Okay, now let's say that we would want to test if the sugar data is kind of if these people are kind of having a low sugar or high sugar level. Okay, so let's say how we can do that. So let's write a method here. Okay, let's say that the method is public static as sugar. It expects an integer value. Okay, I'll check that if the value is like say less than 70. Okay, we'll do something else. If value is greater than equal to 70 and value is less than equal to 130, do something else, it would fall outside the range, right? Else do something else. Now one of the ways could be that we just print out the values here. The other could be that we define our own class of exceptions. I'll update this information of how do we throw those exceptions. So let's declare that say class say low sugar exception. Okay, and let's say that it extends exception class. All right, so the way to this is how we have created the low sugar exception class. So we'll have to define the constructor for that as well. So we'll say that this is the constructor and this is the message using which we'll create this exception. And what we'll do, we'll just call the super with whatever message we have. Okay, so this in turn calls the constructor for the exception class. Okay, so this is how we have just created a low sugar exception class. Let's create a high sugar exception class. So it would be similar to this one. Okay, the name would be high sugar. Let's give the name as high sugar. And all right, we'll just use the similar constructor here. Okay, so this is how we have created 2 exception classes. So now let's make use of these exception classes. So now we are checking here that if the value is the sugar value is less than 70, so we'll say that throw an exception, throw new low sugar exception. We'll write a message saying here that the sugar is low. Okay, we'll just say that. All right, it has to be a void method. We are not, returning anything, and we need to declare that we are throwing low sugar exception. Okay, so that is the first thing. Now we'll come to the else if block. Else if, I mean, we are good, right? So let's just print out that value. Say that else if, we'll just say that, system.out.println the sugar is fine. Okay, else, I mean, if it is the value is greater than 130, so what we'll say is we'll throw another exception. Okay, we'll throw an exception, a high sugar exception. Okay, and we'll say that the sugar is high. Now this is how we are throwing the exception to the calling method. Okay, now because we are throwing this particular test sugar method is throwing two exceptions, these must be declared here. So we'll just declare that it throws a high sugar exception as well. All right, so this is as far as the test sugar method goes. Now what we need to do is we need to iterate over our sugar data method. So we'll iterate over the method here, and we'll call this test sugar method with value of I. I can see that this test sugar method is throwing two exceptions, so we'll have to put that inside a try and catch block. Okay, so let's do that, and we'll say that there is this catch block that, and it catches low sugar exception. We'll write the method here, write the body here. We'll say that low exception, ls low sugar exception, high sugar exception. We'll write some method here and some body here. This is the high sugar exception. All right, and as a trend, we are kind of always adding the exception e, and we'll write some method and some body. All right, so let's see, I mean, what's happening here. So we will be iterating over the sugar data array, and we'll be calling this test sugar I method, and we'll just print out the value saying the sugar is fine. Okay, so sugar is fine for, say, patient I. Okay, for, we'll just print the value of I. Okay, so let's not print anything here. All right, now let's say that if a person is coming here in the low sugar exception message, so we'll just show him whatever messages kind of come from this exception. So we'll say the issue with the patient I is, okay, so this I is kind of declared outside. So we'll just say that the issue with the patient is, and we'll print the message. Okay, similarly we'll do the same thing here in the high sugar. We'll say that, okay, now we won't print anything here, or maybe we'll just say that some exception has happened. Some exception has happened, right? Replace the for loop and put it outside the try block. Okay, and surround everything inside this for loop. Okay, so now what we are doing is for every patient we are trying to see, we are checking the test sugar data and we are putting that inside the try and catch. Now let's see what would happen now. So you can see, I mean, now the output is coming as expected. So for the first patient, I mean, the sugar is fine, which is coming as 80. Next one is 90, which is fine. For the third patient, the exception that we are seeing is the issue with the patient is that the sugar is low. Okay, so for this patient we are seeing this. The third patient we are seeing the exception. For the fourth patient, again it is 132, which is greater than 130. We are seeing the exception, and for the last one, it's kind of in the range. So we are seeing the sugar is fine for 110. So now you can see that this is how you can make use of the exceptions. Okay, the user defined exceptions, and execute your program. Okay, now one other point that I would want to touch base upon here is that you're catching two exceptions here, the low sugar exception and the high sugar exception. So in case you're seeing like two different exceptions which are not related, as in which are not like a superclass and a subclass, what you can do, you can group them. Like this low sugar exception and high sugar exception, these are just subclasses of exception folder, exception class. Okay, these are not related any other way. So what we can do, we can declare it in this manner as well. Okay, we'll just say that if there is a high sugar or a low sugar exception, just come like this. Okay, so it kind of matches. It's almost a similar way of writing whatever we had previously written. Okay, so if we just run the program now, you'll get the similar output. Okay, so you can see that the issue with the patient is sugar is low and sugar is high. That means, I mean, the control went into this for high sugar exception as well. Okay, so that is another way of writing this low sugar and high sugar exception. Now if we just if we just want to club the exception class as well, okay, so we'll get an error because both of these low sugar and high sugar exception classes are subclass of exception. Okay, so this type of grouping is not allowed. Or had it been an IO exception, so it would be fine. The only thing is that then throws also needs to add that IO exception in its list. So we'll just add the import for IO exception, and you can see that. So we have clubbed like low sugar, high sugar, and the IO exception in a single catch statement. So that would kind of make your job a little easy in case you want to display similar message for all the exceptions. You can just club them inside a catch block. Okay, so that is it on the user defined exception. Now let's move on to the next topic. So we have the print stack trace method. That method basically comes under the exception class. So that method gives us the information as to where all this exception has been kind of routed through and where it was thrown. So what was the path leading to that method. So we get that sort of information from the stack trace method. So let's see in the code how this information is shown. So let's use the same program, that is the user defined data. Okay, let's say that we are moving everything inside the main method that we have written inside say method 1. Okay, let's write some method 1. Okay, now in let's say that static void method 1. Okay, let's call method 2 from here. Okay, I'm just trying to show how do the exception stack trace comes up. So there's a reason I'm kind of writing these two methods here. Okay, and here we'll update the content, okay, whatever was there in the main method. So now just have a look at the program again. What we are doing here is that we are starting with the main function. Okay, we're calling from the main function method 1. This method 1 inside is calling method 2, and in this method 2 we are kind of again calling the test sugar method and whatnot. So assume that I come inside this catch block, right? We verified that I can club the exception and I can come inside this particular catch block. Now along with printing that, let me also say that so low sugar exception dot print stack trace. That is one of the methods that kind of gives you the information as to where all this particular exception came from and what was the path leading to the method in which this exception came. So let's run the program now. Okay, so now you can see that for the low sugar exception, okay, see the path that it is following. It starts with saying that the user defined exception class, that is there is this main function, line number 16. Okay, so this is the line number 16 that you can see here. Okay, then it says from here it goes to method 1, that is user defined class method 1, line number 20. So you can see line number 20, there is a call to method 2. From here you can see there's method 2. In the method 2, what is happening is on line number 27, user defined exception.java, line number 27, the exception has come. So line number 27 is the test sugar method, okay, which is kind of expected. So from here the control went to test sugar method, and in this particular method there is line number 43 where the exception came. So let's go to line number 43. Line number 43 is here, thrown you the sugar is low. So this is how you verify the information from the stack trace. The same situation happens for the high sugar exception. You start with the main function, you go to the method 1, from here it go to method 2. Method 2 calls test sugar method, and from here you get an exception that the sugar is high. So that is the importance of the print stack trace method, and it is very important in case you get some issues. It is very helpful for the purpose of debugging. Okay, so this is it from the exception handling module on core Java.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out. Now let's continue with this session.
Alright, so let's start with the next topic, that is synchronization. So if you remember, we discussed some while back that say that you have an account class with you, okay, and it kind of has like two methods. One is deposit amount and the other is like withdraw amount. Okay, now assume that this account is like owned by like two people. Okay, now in a scenario when these two people are simultaneously trying to withdraw some amount from that account, ideally what should happen is they should always be checking some that if the amount that they are trying to withdraw, if that is existing in the account or not. Okay, but there are scenarios in which if these two account holders are simultaneously checking, it might happen that at the time of checking, what happens is both of them are kind of get an information as to the value in the account is kind of available to be withdrawn, and then they proceed on with the withdrawal method. Okay, but it might happen that so say for example my account is having like 50 rupees, okay, and both the account holders are trying to withdraw that amount simultaneously. So in case they are checking simultaneously, they would each see that the amount in my account is 50 rupees. And after that, if they are making the withdraw operation, for the first person it would be successful, okay, but for the second person, if he's trying to make that withdraw method, if he's trying to call the withdraw method, there would be an overdraft in my account, right? Because it had already checked, and at that time the balance was like 50 rupees. But before it was able to withdraw the amount, the first account holder was able to withdraw the amount, and because of that there is an overdraft in my account. Okay, for getting away on these complicated situations, what we have synchronization enabled in Java. So basically synchronized methods are those methods that prevent more than one threads for accessing simultaneously the critical method code. So in this piece of in this example, the critical piece would be a person checking the amount and then withdrawing. So the synchronized methods kind of make sure of that scenario, okay, so that only a single thread can access that piece of code.
So how do we create a method as synchronized or a block as synchronized? By using the keyword synchronized. And for making a block of code synchronized, what we need is we need the object as the argument. Okay, so basically we should be having that in this example, we should be having the object of account, right? The joint account which is held by these two users. So we should be passing this object as the argument for getting its log. The other thing that we would want to understand from here is that in case a thread kind of occupies the lock on that object and it goes in the sleep mode, no other thread can attain the lock. Okay, so the idea is very simple. In this example, let's say that you have an account class. There are two account holders who are trying to withdraw the amount. Okay, so whenever the method that gets called for withdrawing the amount, that would be kind of put in a synchronized block, and both the holders would have to first of all acquire the lock on that object. Once you have acquired the lock on the object, even if one of the holders kind of goes in the sleep mode, one of the threads for that holder goes in a sleep mode, the other thread would not be able to occupy the lock on the same account. So that is something that we should be kind of taking care of. Okay, so this is as far as synchronization goes. Now let's quickly see a demo of the same example. We'll create a class, account class. We'll kind of create two threads for two account holders. We'll try to simulate the condition in which both of them are trying to withdraw the amount from their account, and the condition in which the overdraft happens, and then how the use of synchronized kind of helps us in doing away with that situation. So let's go to the code now. Okay, so what I've done here is I have created a class account service. Okay, let me create a class account first of all. So in this account, I'll be having, let's say that, a private integer, let's say balance. Okay, let me expose two methods here that would return me the balance, and that would help me in the withdraw method. So I'll say public int get balance. We'll just return this dot balance. Right. This is as far as the get balance method goes. Let's write a method for making the withdrawal. In this withdraw method, I'll be passing the amount. Okay, and what I'll do is I'll just set the balance is equals to balance minus amount. All right, so this is as far as the account class goes. Okay, you have a balance, you have a method for accessing the balance, and you have a method for withdrawing the amount. In this method, we are reducing the balance after deducting the appropriate amount. Okay, so once you have written this account class, let's go to the account service class that we are writing. So we want this particular account service to be thread enabled. So we'll say that it implements the runnable interface. Okay, now because it's implementing the runnable interface, we'll have to write the run method here. So we'll just say public void run, and we'll write the implementation in this run method. Okay, now let's write a main method here.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So in this what we'll do is, in this account service, first of all, we should be having you know, a private account let's give the name as joint account. Okay, and let's default the value of the balance in all the accounts as, you know, 50. Okay, for the sake of demo. So what we are doing here is we are creating a new account. We are passing the value or basically we are kind of, you know, setting the balance as 50 for that joint account. Okay, now let's create a class of account service, or let's say, you know, joint account service is equals to new account service. Okay, now let's say that there are two different threads which are kind of, you know, using this joint account service. Let's say that you have a thread, you know, T1, or provide some name to it. So let's say it's like, let's say Tom. Okay, all right, so we are creating a new thread and we'll just say new thread. We'll pass the account service. Okay, let's set the name of Tom thread as, for, you know, getting a better visibility on which thread is accessing the method. Let's say the name of this thread is Tom. Okay, now let's create the other thread for the other stakeholder. Let's say it's like Harry. All right, we'll pass the same joint account service object to it. Say that Harry.setName is equals to Harry. Okay, again to identify that which thread is accessing our method. All right, and we'll start both the threads. Okay, and we are starting the other thread as well. Now what we'll do in this run method is, because we are trying to emulate a scenario in which, you know, we'll be kind of seeing the overdraft situation. Let's say that, you know, we'll withdraw amount of like, you know, 10 rupees and like 5 iterations. So let's say that we'll write a for loop here. I less than 5, I plus plus, and let's write a method to you know, that withdraws an amount of 10 rupees. All right, so let's write that method first of all. Now withdraw method, so it's public withdraw, public void withdraw. Okay, and again we are passing some amount to it. Okay, now the idea behind this withdraw method is that, you know, always before withdrawing an amount, it should check what is the value in the account. Okay, and if the amount is kind of greater than you know, the available balance, there should be some error message, or, you know, something coming that, you know, the person is not allowed to withdraw that amount. Okay, so let's say that we are saying that if like amount is greater than the you know, joint accounts balance. Okay, so if it is greater than that, let's say that system dot println the amount is greater than available balance. Okay, let's print that message. Else, you know, the person should be allowed to get you know, withdraw the amount. So else what we'll do is we'll just call the joint accounts withdraw amount and amount. Okay, we'll call this method. So before doing that, let's say that we'll put up an SOP here. Saying that the balance is available, and let's print the thread name. Okay, for let's say owner. Okay, we are just setting the name of whoever is trying to access this particular method. So we'll get the name of the thread that is trying to access this piece of code. We'll do the same thing here as well for the system.out.println the error message. Okay. All right. Having written the method for withdraw amount and calling it from the run method, we should be good to go for showing the issue with this particular piece of code. Also for the sake of better understanding, if the joint account, okay, the value in the joint account is kind of getting lesser than the balance. Let's kind of, so we'll say joint account dot get balance if it goes less than 0, and this is what the situation we want to demo, that the overdraft situation has happened. Let's say that the value in joint account is, you just display the value. Okay, so in the joint account dot get balance, we'll just print it. All right, so now let us run this program and see what happens. So the idea is that you have an account class. Okay, it starts with a balance of 50 rupees, and you have a method that returns the balance. You have a method that does a withdraw. You are creating an account service, then you are creating two threads, thread Tom and thread Harry. So both of them you just start the execution. Okay, so the execution goes inside the run method here. Okay, and this run method, what we are trying to do, we are trying to do a withdraw of 10 rupees. Okay, now that withdraw operation, what happens is it first of all checks if the amount that a person is trying to withdraw, if it is greater than the available balance. If it is greater, it prints that the amount is greater than the available balance, and this is the person who is trying to access. The same thing, if the balance is available, we call the withdraw method. Now let's run this method, but the idea is the situation might not occur here. The error condition, the race condition in which an overdraw happens, that might not happen here. So let's see, if we try to execute this thing, and in how many times this error condition might happen. So let's run this piece of code. Oh great, it happened in the first go itself. So now you can see that the balance was available for owner Tom. It was the amount was greater than the available balance. The reason this particular thing is coming ahead of the normal the black SOP is this, the priority of the error is kind of higher than the out message. So let's kind of print an output message here. It'll be kind of easier for us to figure out. Again, I'm running the code, but the idea is this situation, the overdraft situation. Now this value is something that should never happen, because we are checking this condition here. We are always checking if the amount is greater than the joint accounts balance. A person should never be allowed to withdraw the amount. Okay, so this situation never should happen. Now let's run this piece of code again. Okay, so now you can see everything is working fine. So for the first iteration, the balance was available for Harry. Okay, if you want, I can just print that what is the value available. But the idea is, in the first iteration, Harry withdrew 10 rupees, then Tom, then Harry, then Tom, then Harry, and then again it was saying that the balance is available for Tom. But ideally, after the 5 iterations, the amount should be reduced to 0. And because it was available, there was a withdraw operation happened, and because of that the balance that was reduced to minus 10 rupees, which is an incorrect condition. Okay, so as I said that the value that is coming, the minus 10, that is an incorrect value, and that's happening because of the overdraft. Now let's try and see how do we resolve this particular issue. So let's try and make use of the synchronized block of code that we just understood. So let's say that this is my block of code, which is making a decision. First of all, it is checking if the amount is available, and then it is doing a withdraw operation. So I would want to protect this particular piece of code, and I don't want two threads to be simultaneously accessing this thing. Okay, so what I'll do is I'll surround this piece of code in the synchronized block. Okay, so when you do that, automatically only a single thread would be getting a hold of this piece, and once that is done, everything should be taken care of. So after putting this thing inside the synchronized block, let's run the program again. Okay, so now you can see that after the 5 iterations, the amount was allowed to be withdrawn for your owner Tom, and after those 5 iterations, it gave the error saying that the amount is greater, this particular, after checking it properly. So you see, this was made possible by using the synchronized keyword. At a time, only a single thread got a hold of the withdraw method. Okay, so that is the importance of, and that is the use of this synchronized block. You kind of make sure that this race condition never happens, and only a single thread gets the control of the critical piece of code. Okay, so this is as far as the synchronized methods and block of code goes. So one more thing, just to add to this, the use of synchronized. So far, we just saw that how we were using this synchronized keyword with the block of code. We could have just used this synchronized for the method. It's synonymous of whatever we are doing here. So we could have just defined the method as synchronized, and then only a single thread would have gained the control of this particular method for the same object. So that is one of the ways of doing this, but the idea is in real life, this particular piece or this particular method, I don't want to synchronize the complete code for that method. There could be a scenario in which I would just want to protect a small piece of my code, and I don't want that to be kind of entered simultaneously. So I can put synchronized in that block of code by making use of the synchronized block. Okay, so now let's move to the next topic, in which we see how the threads interact with each other. So now comes the topic about the thread interaction. Okay, so far we have seen that how do we create threads, how do we start them, how do we put the thread into the sleep status, how do we make use of the synchronization of the blocks of code in which only a single thread would be allowed at a time. So far we have seen that. Now let's come to the next topic, which talks about that how do these threads interact among themselves. Okay, so all the methods that we had discussed, that which were the sleep method or yield method or join method, so those were the methods that were of class thread. Now these methods that we would be discussing now, we would be making use of all the objects method. Okay, so object classes method. Here the idea is that we would be placing an object into the synchronization mode. That object would be accessed by 2 or 3 threads, and we'll try and see that how do that object kind of invokes
or tells the thread to behave in certain manner. Okay, so the first method would be the wait method. So by using that method, what it does, it sends the current thread, whichever is acting on it, into the into the wait mode, and it sends it into the object's waiting pool. Okay, the other method is that, in case then there's the notify method. In case a particular object is kind of accessed by two threads, let's say two threads, and one of the thread is kind of waiting till the other thread is kind of working on its processing. So how do thread B calls thread A? So it makes of that object makes use of the notify method, and using that notify method, it sends a signal to the thread which is waiting in the object's waiting pool. Now the use of the notify method is applicable only in case two threads are working on the same object. So in that way, one of the thread could be called if it's in the waiting pool, and if the number of threads that are acting on an object are greater than 2, then in that case we make use of the notify all method, because a signal which is sent to the threads which are waiting in the pool, we don't have a control as to which thread would be invoked later on. Okay, but by making use of the notify all method, what we do is we send a signal to all the threads which are in the object's waiting pool. Okay, and as I said that these all methods, these need to be called from the synchronized context. Okay, only in case my object is is kind of inside the synchronized block of code, and only in that case we can call these three methods, that is wait, notify, and notify all. Now let's have a demo and see how these threads would interact. So for this particular demo, let's think of a scenario that we have like a shared queue between a producer and a consumer. Okay, now a producer is something that adds an item into that shared queue. A consumer thread would be something that would try to get that object from the shared queue. Now this shared queue would be kind of a common resource between the producer and the consumer. So we'll try and see that how we make use of these wait, notify all methods and send signals to the producer thread and the consumer thread, so that they can a producer can add some information or some records into the shared queue, and the consumer can get the information from that queue. A consumer should not be getting that information if the queue is empty, and a producer should add the information in that queue only when that queue is empty, because it doesn't make sense if producer keeps on adding those items in the queue and if the consumer is not consuming them. So we'll try and see that in the demo, and we'll make use of the wait, notify, and notify all methods and see how these threads interact. So let's quickly go on to the code. So in this particular case, what I've done is I have taken I've created a class thread interaction demo. Okay, now let's say that you have two classes. One class is producer, let's say that it extends a thread. Okay, and we'll create another class consumer. We'll say that even that extends a thread. Now for these producer and consumer, let's write a method here in the thread demo that calls it. So let's say that this method okay, let's create a linked list, which is like which would act as like a shared queue. Let's say it's a shared resource. Okay, and let's say that like a new linked list. All right, so this is one of our linked list. Let's create a producer thread here, let's say that producer P is new producer. Okay, we would want to pass this shared resource into the producer thread. Okay, because this is something that has to be shared by the producer and the consumer. So let's write the constructor for this producer, and let's say that we'll just call the super method from here. Okay, say that it's the producer thread, and let's create a member variable for the the queue here. So let's say that it's a linked list for me, and we'll set this dot shared resource is equals to shared resource. Okay, whatever is being passed. All right, so this is how we have created that a new producer. Let's pass the value into the new producer object. Okay, now similarly, let's create a consumer. Let's say consumer C is a new consumer. Okay, we'll pass again the shared resource in that. The implementation has to be really similar here as well. For the consumer, it would be having a shared resource linked list. The constructor would be somehow like this. We'll pass the consumer into the super method, and we'll pass the shared resource. So that is how we have kind of created two objects here. Now these objects, producer and consumer, what they are trying to do, they are extending a thread. So let's write the implementation of the run method here. Okay, now the idea in the run method is that what we'll do, we'll try to add 5 items into the producer. We'll try and iterate this thread for 5 times. We'll add the item into the queue, and from the producer, and from the consumer side, what we want to do is we want to extract that item. Okay, so we'll be writing a for loop here. We'll say that for int I is equals to 0, I less than say 5. We'll increment the counter here. Now what we are supposed to do in the producer is that we should only be adding into the producer if the shared resource is empty. Okay, that is the whole idea, and we don't want that shared resource both producer and consumer trying to access it simultaneously. Like we have seen the example of the account, both of them, if they are trying to access that particular thing simultaneously, it might, because of the thread trace condition, I can get an incorrect result. So let me kind of synchronize this, the shared resource. So we'll put the synchronized shared resource here. All right, now what we want to verify basically here is that if while the the shared resource, so while the shared resource,
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
so while it's not empty, we need to wait. Okay, the idea is if the shared resource is not empty, I should not be adding anything into the shared resource queue. All right, and let's put up an SOP here saying that in the wait mode, let's say in the wait mode in producer, as the is not empty. Okay,
You'll say that this producer thread is kind of waiting because the resource is not empty, and what we'll do is we'll make use of the shared resource dot wait method. All right, now having put this wait method here, it would throw an exception, so we need to take care of handling that exception here. So we'll put that inside the try catch block. Let's put the interrupted exception, IOE, and let's put these SOPs and the wait method inside the try block. All right, now what we have done is we are waiting for the shared resource. Let's just print an SOP here that system.error.println caught exception. Let's say that it has caught exception in producer. Right now, so till the time this shared resource is not empty, we need to wait. Now once it got empty, what we need to do is we need to add something to the shared resource. So let's add the counter I into that. Let's say that shared resource dot add, we'll add an object I. Okay, and after doing this adding, what we have done is we have added some information into the shared resource. Let's notify the other thread that is waiting for this activity. All right, so let me just quickly go through the code again. So what I'm trying to do here is I'm trying to do 5 iterations. I put the shared resource as my synchronized part. I don't want to allow 2 threads acting on this part simultaneously, so that's the reason I have put the synchronized. Now I'm waiting on this shared resource. I'm trying to see that till the time it's not empty, I need to wait. So I'm calling the shared resource dot wait method, and once it gets empty, what I need to do, I need to add an item into it. Okay, and then I'll just notify. So the similar implementation has to be going into the consumer. Okay, it would be little different, but we'll try and make use of this similar implementation here. So far the consumer, what it should be doing is almost like the opposite. We'll again do 5 iterations. We'll put the shared resource into the synchronized code. Now here we'll see that till the shared resource is empty, we'll have to wait. Okay, so in the wait mode in consumer, we'll say, okay, because the shared resource is empty, so till it is empty, we need to wait. Okay, now once there is some information into there is some item into the shared resource, let's just remove. Okay, and then we'll notify. So what happens is as soon as the producer is adding an item, the this particular while loop should break. The control goes into this line, the consumer removes the item from shared resource, and then this shared resource notifies the producer thread, because that goes into the waiting state as the queue. It basically acts on this shared resource. It tries to verify its value, that what is the number of items in the shared resource. If there are any number of items, it goes into the wait manner, right, into the wait state. So that is the implementation of the producer and consumer. Okay, now let's try and run this particular thing, and before doing that, let's put up an SOP saying that I'm adding an item. So let's say that, so it kind of would give us a better sense here. We'll say that system.out.println in producer, and adding whatever value that we have added, and yeah, that should be it. In consumer, I think that should be fine. All right, so now let's run the code and see what happens. Okay, so let's run the code and see what happens. So okay, Okay, we are not saying anything. Okay, the reason is because we haven't started the threads, producer and consumer. So let's start the threads here. Let's say p.start and c.start. All right, so that way the producer thread would also be getting started along with the consumer thread. So now run the program. Okay, so now you can see that first of all the control goes to the producer. It adds a 0 here because for the first time the shared resource is empty. Okay, so it goes into this loop. It does not go inside the while loop. Okay, and after that after adding this particular resource for the second iteration, it goes into it goes inside the while loop, and it says that it goes in the wait mode. Similarly, for the consumer initially, because the item was not there, it went into the wait mode, and then as soon as the producer added 0, it just removed that item. And because it removed that item, okay, because it removed the item from this line, the control went back to the producer, and then it came out of this while loop because it was waiting here. Then it added 1. All right, and then the consumer removed, then again the producer added 2, then the consumer removed, it added 3, and it added 4. So that is the whole idea of how these threads interact using the wait and the the notify methods. Okay, so having seen the implementation of the notify and the wait method, now let's quickly see the implementation of the notify all. So what we'll do, we'll try and enhance this example, and we'll try to make use of the notify all in this example itself. So let's say that you have 2 consumer threads. Okay, so let me say that you have a consumer C2 as well, and with starting C1, I'll start C2 as well from here. Okay, now let's see what the producer now need to do. Because I have 2 threads running, let me add 2 items every time. So instead of adding a single item here, what I'll do is I'll add another item as well. So I'll say that share resource add i+1 as well. Okay, after modifying the producer, let's move on to the consumer. Okay, so what we'll do in consumer is that so basically if you try to see from here, I mean there are 2 threads that are running for the consumers. Okay, so after I remove from the shared resource an item, let me just put the current thread into the into the sleep mode, so that I give the opportunity to the other thread for removing this item. So for that, what I'll do is .current thread .sleep, and let me just put it for 200 milliseconds. Now because it's the sleep method, I'll have to put that inside the try catch block. Okay, and in the catch block, what I need to do, I need to again write the interrupted exception. All right, so that should be it. It should be the consumer. All right, and even this should be consumer. Now the idea is the producer should, instead of now calling the notify method, it should call the notify all, because there are 2 threads running here, C1 and C2. Okay, those are the 2 consumer threads running. Both of them go into the wait state if the shared resource gets empty. Okay, now I need to wake both of them, and in case for waking them both, I need the notify all method. So let me just modify the producer's notify method to notify all, and I think let's run the code and see what happens. So you can see that you're in the producer, you're adding item 0. So you're not only adding item 0, you're also adding the item 0 and 1. So let me just update that, adding item 0 and i+1. So that is all you're adding in the item, and from the from the shared resource. Let me just put up an SOP and tell you that, say you're removing from consumer, let's say the item I. Okay, so this is the iteration that we are saying. So if we run the program now, what you'll see is that the producer has added item 0 and 1, then goes into the wait mode. Then we have like these two consumers running. Consumer, both of them are kind of removing item 0 and 0 from here. So in case you want to see that which is the thread that is kind of taking care of that, let us define the thread name here as well. Okay, for doing that, what we'll do is we'll update the consumer class. We'll say that the constructor expects like a string name. Okay, we'll pass the name for the consumer. Okay, we'll pass some value here. We'll say that it is C1, it is say C2, or let's say just C and C2. Okay, and while we are removing the item from the consumer, let's say that consumer and print the current thread's name. Okay, now let's run the program. Okay, so you can see that first of all, for consumer C2 thread, I'm removing the items. Okay, then I I add from using the producer 2 items, 1 and 2, and then I make use of consumer the consumer C. So that is the way I'm kind of showing that which consumer is deleting the item from the shared resource. So this is as far as the notify, wait, and notify all methods go. So yeah, that's it from the threads module.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below, and you can go check it out. Now let's continue with this session.
So within this, we can understand that websites generally operate on a request response basis. Now, what does that mean? So imagine you're working as a client on a client system, right? And you want to access a website or a service that is present on a server, right? So the first thing that you would do is on the website, you will look at the various options that are available to you. So say if you want to evaluate a mathematical equation, so you will enter your parameters, right? For that mathematical equation, you'll click on submit. Yes, I want the answer to this particular equation, right? So that process of submitting is called a request, right? So once you've sent the request, the server will take those parameters in, and based on the algorithm, the server will evaluate that equation. And once the server has evaluated that equation, it will send a response. It will generate a response, and that response could be in any format. It could be in JSON, it could be in text format, it's simple message format, right? Any format essentially. Once the response has been generated, it will go to the web page, and on the web page you can see it. So basically the response has been sent to the client after the request has been sent. So it usually happens like this. The client sends a request, the server will send a response back to the client. So this is the general web architecture. So there are essentially 3 elements that you're dealing with over here. So the primary one is the front end, which is over here, which you're seeing, which is the website itself, right? The visual aspect of the website. And the secondary aspect is the logic aspect of the website, which is the server, right? So you don't directly interact with the server. You will see something on the website, right? And on the website, you'll click on something, and based on that click, based on what you've done on the website, on the front end, if it's a valid request, it'll basically be sent to the server. And the server will generate a response, which it will communicate to you through the front end itself. So this is the medium for communication essentially between the client and the server. And when we move on, we get to Java servlets. There are various technologies all around the world based on the same concept, right? One of them is based on Java, and they are called Java servlets, right? So as the name suggests, they are basically miniature form of actual servers, right? They're pretty easy to build and execute. Essentially, they're lightweight in nature. So essentially, they're defined as web components used to create dynamic web pages, right? So essentially, to substitute for an actual entire server logic, there are mini functions that are there that can be done through Java servlets. So let us understand. There are five methods in servlets. So the first is init. Now, init is something that is used to essentially initialize your servlet. So once you've imported the servlet class, you can initialize it by using the init function. Then you have the service function. Now within the service function, you can essentially apply all your logic that you want to use. While the servlet has been initialized, an instance of the servlet has been created, all of the logic part that will be executed will happen within the service function. So, and as long as it is ready, and then finally we get the destroy function. So whenever you want to end the instance of this particular servlet and you want to garbage collect all of the memory that the servlet had been occupying, you'll use the destroy function. There are two additional functions. So one is the get servlet config, which will essentially give you the configuration information of the servlet, and the other is the get servlet info. So it'll give you the author of the servlet and any other name details associated to it. So let us understand now how servlets work. What is their life cycle? So essentially what happens is the first thing that you'll do is you'll load the servlet class. You'll import it firstly. So once you've imported the servlet class in your Java program, right, the next thing that you'll do is you'll instantiate that servlet. So you'll create an object out of that class. And once you have created that object out of that class, so you can use that object to initialize your servlets, right? So once you initialize your servlet with the init function, as we discussed earlier, you can actually start with your logic. So when you initialize it and the initialization is successful, the servlet goes into ready state. Now this is an infinite state as long as the instance of this particular servlet is running, right? So what you can do now is use the service function, the service method, and it can be called as many times as needed to execute as many aspects of the logic as are needed. And once the function of the servlet has been fulfilled, this instance is no longer required. You can essentially call the destroy function, which is called to basically garbage collect all of the memory that the servlet had been occupying and to essentially shut the servlet down. So this is how the servlets function, right? So let us see the practical implementation of these servlets. We are going to be building a login form where we are going to be entering two fields, which is the user ID and the password. And if the password and the user ID match with a pre-existing user ID and password, we are going to redirect our client to the successful login page, or we are going to redirect them to the unsuccessful login page. So let us see how that would work in the Java servlet environment. And before we actually begin, we need to understand two terminologies as well. So the first terminology is the get. Now, get is a method that is present in servlets and in various other web technologies as well, where you're essentially sending limited amounts of data through your URL itself. So you might have noticed whenever you search on Google something, right? You enter some search key term on Google and you search it. So it gives you something like this, right? So you have these variable names that are present in your URL, right? And they are equal to a certain value, which is your search term to be precise. So that is the kind of URL that you get whenever you press enter after hitting search or on a Google search form, right? So this is what you get. This is the get method. Google essentially is using the get method in that particular job, right? And there's also the post method where you can send more amount of data, right? You can send enormous amounts of data using post. You can send large amounts of data, but the data is not actually visible in the URL. So you're essentially redirecting yourself to a page where the data is existing, but in the URL itself, you cannot see the data, right? So that is when you are using the post method, when the data needs to be hidden and it's not exactly present in the URL. So once we've understood that, we can move on to our example. So as you guys can see, I currently have my Eclipse IDE open, right? So the first thing that we need to do is create a dynamic web project. So firstly, I'll go to File, I'll click on New, and then I'll go to Dynamic Web Project. So within this, we can name our project anything. So since we are creating a login form, I'll call this login form. And then I have to select a container on which my server is going to run. So the current container that has been selected is Apache Tomcat 8.5, which I have in my C drive, and I have configured the location to that particular folder. So once I have configured that, I'll go to next, and then I'll go to next again, and then I'll click on generate web XML deployment descriptor. Now what this will do is it'll generate a descriptor, an XML file by default. So I'll click on that and click on finish. So currently we can see that we have our project ready, and then we can create our code files within this. So there are essentially two aspects to every web application, the front end and the back end. The back end is where the logic happens, and the front end is what you see on the screen, right? So right now we have this folder called Java resources. We don't need to concern ourselves with the JavaScript resources because we are not creating a project in that. So in the Java resources, we can see that there are two folders, SRC and libraries. So if we have to add any additional libraries, we can add it in the libraries folder and import the modules from there. But for now, the servlets that we will create and any other Java modules that we will create that have logic in them will go within this SRC folder, right? And the front end will go in the web content folder. Now within web content, if we simply expand this, we can see we have the meta INF, web INF. We don't need to concern ourselves with that particularly right now. We'll just click on web content, right click on it and go to new and go to JSP file, right? So we'll just name this file something relevant. So let us call this login and .jsp and click on finish. So when we do that, within the web content folder, we have the login.jsp file. So since JSP files are something that the user sees, which gets rendered on their web browsers, the format is almost identical to HTML, right? So we can see the HTML doc type over there and the head, which basically would have the title in it, and the body over here where we can add the body, right? We can do all of that. So basically, in the body, we can get started with something. We want to create a login form, right? So we need two input fields, and we need a submit button to basically submit those two input fields in order to basically log into our website, whatever we are creating right now, right? So since we are not connecting any databases to this project, we wouldn't be actually creating a registration page where we'll take some data and register it onto our database for login authentication. Right now, we'll just create a login page. So first thing that we would do is create a form. Now form is something that is inbuilt in the HTML. So I'll simply create a form and create a method within that form. So the method, as we discussed earlier, describes the post or the get, whatever we are using this particular field for, right? So for instance, we are going to be using the post method over here, and the action basically determines where we are going to redirect once the submit button has been clicked on this form. So we are going to go to something, let us call this login authentication. right? So this is going to relate to the logic part of things, where we have the logic files in our Java folder, in the Java resources folder, right? So there will be a file called, let's say, login authentication. It's going to go redirect over there and check whether the credentials are correct or not. So we double quote close this and we close the form, right? Now within this, below this, we can basically create a table. So I'll just put an enter over here and create a table. So tables are pretty easy to create in HTML as well. So once I have created the table, within the table's body, I'll first create the first input field, and we are going to call this the ID input field, where you're going to enter your unique email ID or your unique user ID essentially. So let us create that first. So within this, we can name it anything. So let us call this ID. So this will appear on the web page as ID, uh, adjacent to that particular input field. And then we'll close this. So once we've closed it, actually it automatically did that. So once we close that, we'll create the field that we need. So to create the field, I'll simply create another cell block over here, and given the criteria of input, so input type, firstly I have to specify the type. So I want it to be in plain text because there is no hiding going on over here in the user ID input part. So I'll just add text over there, and the name, let us call this something like user ID, right? So this is what we'll refer to this particular input field as when we go to the logic part, where we need the value extracted out of it. And then finally we'll close this. So it automatically closed itself, and then we'll close this particular row as well. So it automatically closed itself as well, right? And the next thing that we need to do is create the password field. So we'll just copy this first, right? Because we want to create something identical below as well. So we'll just paste it over here. Instead here, we'll just call this password. And in type, I'll change it from text to password. So now, whenever I type the password in this particular input field, it'll appear hidden, right? In the form of asterisks or those black dots that you see, right? So basically hidden so that nobody else behind you can see, essentially. So in the name, I'll call this variable, so to speak. Let us call this pass, right? So once I have done that, I'll just create the submit button. So once you've entered that, you'll obviously need the submit button. So let us create that as well. So I'll just copy this and paste it over here. So since we don't need a name on the submit or adjacent to the submit button, because the submit button will already have the text submit on top of it, so we'll just simply delete this. So we don't need that. And what we'll do now is change this input type to submit. So it'll automatically be a button, and then we'll simply, in the value, we'll put it as, and name this as login. So once we have done that, we have our JSP page over here. So we're just going to save it, right? So now we can go to the logic part. So let me remind you over here again that in the action of this particular form, so once I click on the submit button right over here, what I want to do is initiate this action. It means that I want to redirect myself to the login authentication post method. So I'm just going to create a servlet now. So once I go to the Java resources, right? So within here, I'll go inside this src folder and I'll right click on it. So within this, I'll click on new. I'll go to new and I'll click on servlet. So here we can see we get the basic configurations for our servlet. So in the Java package, I'll simply leave it empty because I'm not actually putting my class into any particular package. But in the class name, I'll make sure that I enter this particular action text, that is login authentication, so that it actually maps to it. So login authentication, right? It has to be case sensitive as well. So once I have done that, I can simply remove the space over there and it'll allow me to finish. So I'll click on next, right? And we can see the URL mapping over here. It's going to redirect to slash login authentication whenever that particular action is prompted. And then I'll click on finish. Right. So right now I have my servlet created for me. So we can see the name over here at the @web servlet, which is slash login authentication. And within this, we can see a variety of methods, which is the do get and do post, right? Which are the methods that we are currently concerned with, because right here we can see that there is this post method that we are going to be prompting whenever we click on the submit button. So whenever we click on that, it will redirect to this particular servlet and it will redirect to this particular method, right? So whatever we write within this method, that logic is going to be implemented upon clicking the submit button. So the first thing that we are going to be doing in our do post method is remove the default text that is present over there. So we'll just remove the comment and the do get method, right? So once we have done that, what we can do is retrieve the text field values from our JSP page. So we can see that whenever the user enters an ID and a password, the names that are corresponding to those fields are user ID and pass. So these are the names that we are currently concerned with. So what we will do is we'll create two string values to basically store each of them. So firstly, I'll create string and I'll call this ID, and then I'll equate it to request dot get parameter, right? So whenever I type that request dot get parameter, I can simply add the exact field that I am looking for particularly. So in this particular case, the field that I am looking for is just a moment, wait a moment, user ID. So I'll simply add that over there, user ID. And within this string pass, I'll add request dot get parameter and I'll add pass, right? So when I do that, I'll simply, as firstly, I'll change this to something else. ID seems to be a keyword, so I'll change this to user ID. I think that can work, right? So once I have done that, I can simply add this over there and add a semicolon at the end of it, right? So once I have done that, I can carry on with my particular statement. So what if the user has entered these particular fields and now we have to check whether these fields exist in our database or not. So basically what we'll check first is if the user ID is correct, right? So if user ID dot equals, and here we can enter. So right here we can just simply remove this and enter equals. We don't need content equals, and enter something like let us call this Ryan, right? So user ID dot equals Ryan. So if in our database, in our hypothetical database, let us assume that there is only one data record which has the user ID Ryan, and let us create a password as well. So pass dot equals, so it automatically somehow translates to content equals. I'll just remove that and password equals, let's call this pass 123, right? So this is the password that the user ID Ryan should have, right? That is present in our database. So right now what we can do is give some conditions for each of these particular conditional statements, right?
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So for each of these conditions, if the user ID and password are correct, and if they are not correct, we have to create two web pages where we can redirect our user to, right? So for instance, right over here, we have our login page that is currently created. We have to create two more pages, right? So the first page that we will create is for the case when our user ID and password actually match and the individual is able to log in. So successful login, let us call this particular JSP page that and create it. So the first page is called successful login. And within this, we can simply give one H1. So for instance, our H1 can be uh, you have successfully logged in. And then we can create a page that indicates a an unsuccessful login, so to speak, right? So I'll save this first over here. I'll save this first and I'll go to login authentication. I'll make changes to that later. So the next page that I'll create is I'll go to new and click on JSP file, right? And I'll call this unsuccessful login. So I think that can suffice. Right, I think that works. And call it .jsp. Click on finish, right? And within this, we can give some sort of a value. So here, let us give some title. Like over here, we have given insert title over here. I'll simply remove this from here. I'll remove the title to something like successful login. Right, I think that works. And over here, we can give the title unsuccessful login. And within this body, we can give an h1 and call this h1 your user ID or password is incorrect. Right? So this will be the text that will be presented to the user on the web page if the user has entered the wrong credentials, right? And I'll save this as well. So we have successfully created our two JSP pages that we are going to be using when the password is correct and when the password is wrong. So when I go to the if statement over here, I'll obviously open up a curly bracket. Right, and within this curly bracket, we have to give the condition when it's correct. So for the if condition, what we'll give. So here we'll be using a function which is called as send redirect. So as we can see in the two arguments that we are receiving in this particular do post method, one is the response method and one is the request argument, not the method, the arguments that we are receiving. So from the request, we receive the parameters, but in the response, we can basically decide what we can do after we have received the parameters, after the logic part of this particular. We are going to use response dot send redirect, which is going to give us a prompt to enter a location as an argument. So here we can simply open up double quotes, and as a string value, we can pass the name of the JSP page where we want to redirect in case the condition is true. So we want to redirect to successful login, right, and .jsp. So it's important to specify the extension of the file, and then once that has been done, so this becomes correct, and then we go to the else statement, and within the else statement we don't have to specify any condition. It's just in the case where any of those particular conditions are not true, the password equality and the user ID equality. And here we do something similar. We call response.send redirect, and we enter the page name that we want. So in my case, I want unsuccessful login.jsp. I close my double quotes over there, and once I have closed my double quotes, the program is ready. I'll just put a save over here and see if there are any errors that are persisting. So I'll look at this error, just a moment. So yeah, so there was one bracket that was missing. Now that bracket has been entered, and I'll save this so that frees our program, our project, from any errors. So let us now run this. So running this is quite simple actually. We'll simply have to go to the project name. We go to run as, and we go to run on server. This is not a Java application that we're running. We're actually running a server. So I'll simply save this again and simply go to that again and go to run as and run on server, right? So when we go there, it prompts us the option. What do we want to use? We want to use the Tomcat 8.5 server. So we have already selected that, and we'll click on next, and we'll click on finish. So we can see our server has started running. So since we haven't configured an index for our website, we are not initially redirected to any particular web page. So I'll just simply add a address over here, which is called login.jsp, and I'll press enter. So when I press enter, we can see that we are actually redirected to a web page, like on the local host 8080, which is on my local server. And in the ID, the first thing that I can try is enter Ryan, and in the password I can enter pass123, and I'll click on submit query. So it prompts us with you have successfully logged in with the title successful login. And on the other hand, if I simply go back over here to login.jsp and I enter Ryan, but I enter the password which is correct, 123, and I click on submit query. So it gives us the unsuccessful login.jsp. So currently I think I did not have my name configured properly. So I'll just fix that and it'll be resolved. So yeah, so there were two L's in the unsuccessful login. So if I simply go back to my login authentication.java, and I put in two L's over there, which is incorrect spelling, by the way. So if I put that over there and save it, right, and then what we can do is stop the current execution of the server. So we can simply go to the server and click on stop, the square button over there, and then we can rerun this entire program, right? So I'll close these web pages up and go to login form, and I'll click on run as, run on server. I'll click on next and finish. It opens up a web page again. I'll click on login.jsp. I enter that. I enter Ryan and a password that is incorrect, 1234, and click on submit query. So here we can see your user ID or password is incorrect, and that is how servlets work essentially. So the servlets deal with the logical aspects of things, and the JSP files, which are optional by the way. You can use other front page format as well, like HTML directly. You can use that, but with JSP we get a lot more features that are compatible with servlets. That is why we use them in combination to them.
What is JavaScript? Let me tell you this, JavaScript is actually one of the most popular programming languages we have today whenever the talk is about web applications, right? So whenever we want to build mobile applications or whenever we want to build web applications, the top programming language that the people will look out for is JavaScript and all of its flavors out there. So with JavaScript, you can do a lot of things in a very simple way, but yet your results can have a lot of impact on what you do. For example, you can go on to do a front-end development where you can handle all the aspects of designing, creating the user interface, driving a good user experience, working with the elements, styling of these elements and all of that. And of course, you can be interested in working on the backend as well. Backend as in how the data moves around in the system, data ingestion, how the servers talk to the data access units, a lot of protocols. At the end of the day, you can make your front end talk to the back end too. And it's not only just this. If you have an interest towards both of these, front end and back end development with JavaScript, it is possible to look towards full stack development as well. Full stack development, of course, involves both front end and back end development simultaneously. And there are many things that JavaScript is extremely good at. The first thing you really have to talk about is how it can build dynamic web pages. You already know that today's web pages load really fast. They drive a very good user experience. They work on all the devices out there and all of that, right? To help and add the dynamic nature, JavaScript is key. And of course, if you already have existing features in your application and you just want to provide functionality to it, you want to add meaning to what the feature does, then JavaScript is what you'll be using. And then when you're building web applications, right, so you need support structures, you need what we call as a scaffolding to go on to build applications from scratch and work on that. For that, we'll use JavaScript or a flavor of JavaScript, and sometimes it's also called as frameworks too. So there are a lot of frameworks. There's a lot of extremely popular frameworks out there. For example, think about React. It's a very good JavaScript framework. It's not only just React, you have a lot of scope in terms of JavaScript. So both Java and JavaScript are at the top of its game is what I would like to say. But then with that, we really have to check out a couple of points that compare Java and JavaScript. So talking about mode of working, right? Java is an object-oriented programming language where you will deal with all the entities as objects. These objects will have certain functionalities to them, right? So you will have attributes, you will have definitions that define what the object is, and the functionality defines what the objects do. This is how data is moved around, and it's created, modified with, and of course destroyed even when not in use in the entire case of Java. Now, JavaScript is actually very similar to Java, but it's not the same here because see, JavaScript involves using an object-based scripting approach and not the object-oriented approach that we take in terms of what we do with Java, and that is a very big difference in itself to begin with. And then coming to the second point, if we talk about file extension. All the files, whenever you're working with Java, is going to have an extension of .java no matter what. So whatever is contained in those files, if it's a Java file, there's a very good chance it's going to have a .java extension. Of course, if it's a package or if it's a virtual machine file, you can have multiple other extensions with this. But the main extension of a Java file, as the name suggests, is .java. And in the case of JavaScript, the extension is .js. JS is short for JavaScript, as you've seen, and this is what is primarily used for creating and storing all of our data in JavaScript files. And then coming to the third point, we have to talk about compilation. Here is where another very big difference exists in between Java and JavaScript, in a way where Java code gets interpreted and then compiled, right? So we have something called as bytecode, where the Java code gets converted into bytecode, and this bytecode is what gives Java the independency from the platforms, write once, execute anywhere. That is only possible because Java code gets interpreted and compiled into bytecode, and this bytecode can be used on a variety of machines of our choice. Now, with JavaScript, it's a little different, but since JavaScript is mainly used for web development, and in the case of JavaScript, it is a little different because JavaScript is meant for web development, right? So it runs on all the browsers that we have out there. It uses the JavaScript interpreters, and at the end of the day, the code runs effectively on most of the popular browsers. In fact, I want to say all the browsers that we have today, be it Mozilla Firefox, be it Google Chrome, Internet Explorer, Microsoft Edge, all the browsers out there. And then coming to the next point in comparison, we have to talk about variable declaration. See, Java is a strongly typed programming language in a way. So whenever we talk about strongly typed programming languages, one thing you have to understand is that variables have to be declared before usage. So you have to explicitly mention the type of variable that you're going to use, and then of course you have to declare it and then work with it. Now this is what strong typing is. If we're coming about weak typing, JavaScript is a weakly typed programming language in a way where you really do not have to specify the types of data that you explicitly use whenever you go on to store something in that particular data entity or data unit. In that particular case, this is another huge difference between Java and JavaScript, where Java is a strongly typed language and JavaScript is a weakly typed language. And then coming to point number 5, we have to talk about the production execution. So what happens with Java code is that it gets compiled on the server itself using all the native programming capabilities, using all the computing hardware of that system, and then it can be used. The results can be seen on a client's machine, and of course with the frameworks of today, it works both ways now. But primarily, Java is meant to execute on a server and display the usage or the communication medium on the client's machine. Well, JavaScript is a little different here because JavaScript, first of all, does not involve compilation because the code gets directly interpreted, and this happens on the client's system directly, where the client is using the browser to work with it as well. And in that particular case, execution of data on the server by Java code differs a lot by the execution of JavaScript code that gets directly executed on the client's machine by being interpreted and not compiled. And then coming to point number 6, we have to talk about the learning aspect of Java and JavaScript, right? So if you're in this particular video, if you're looking to learn either Java or JavaScript, I'm sure you guys will have a very good understanding of what you might want. And in case if you do not, if you have a question saying what can I learn better, what's easier, you have to understand that documentation is something which is very important to learn any programming language, and both Java and JavaScript do come with amazing extensive amount of documentation out there. And your learning should depend on your usage, right? Java is meant for stability while JavaScript is meant for speed. But then in terms of learning, it's a little difficult because I think, in my opinion, it would be a little easier to get up to speed with Java, just for the fact that it's slightly easier to use. But then due to the popularity of JavaScript, right, there's multiple outsourced third-party documentations as well that will make sure that you guys can learn new frameworks easily and find solutions to problems which would have been difficult if JavaScript would not have been popular. So depending on your requirement of stability versus speed, you can pick one of Java or JavaScript. Understand that both of these are among the top 10 careers to have in the particular decade that we are in. So either one should serve you good. Is it Android app development that you're into? Is it mobile app development that you're into? Web development? Depending on those as well. Now, coming to the 7th point, I'm sure you guys are curious about the average salary of a Java developer and a JavaScript developer, right? So Java developers get an average salary of somewhere around $105,000 per annum in the USA and around 8 lakhs per annum in India, while JavaScript developers get an average salary which is slightly higher at $115,000 per annum, of course, in the USA, and around 10 lakhs per annum in India. These are the average salary numbers which are very well achievable by beginners if you are certified in Java or JavaScript, and if you have the skills and the skill set to basically solve problems. Now, with that, coming to point number 8, if you are curious about the job roles of Java and JavaScript, Java development involves a lot of roles such as Java developers, core Java specialists, Java EE engineers, and a lot of other roles too. In the case of JavaScript again might open your case into multiple job roles, because here you have web designers, your front-end developers, back-end developers, mobile app experts, JavaScript developers, solutions architect. So in my particular case, if I have to pick a winner for this particular round of job roles, I think due to its immense popularity and active usage, JavaScript might open up your door to multiple job roles. And then coming to point number 9, we have to talk about the usage of objects in both of these languages, right? See, Java objects are one very important thing you have to remember. It's all class based. So without having a class, you really cannot create any sort of programs or work with any sort of Java objects at all. This is a very important difference. But then when you're talking about JavaScript objects are very different when we talk about Java objects, because here it is not class based, but it is prototype based. So the hard staunch requirement that you have to have a class to make use of Java objects versus not having that is okay with JavaScript is a very important difference that you guys should know at this point in time. And then of course, coming to the next point, we have to talk about concurrent execution. Now let's say you have multiple programs or multiple applications that you want to develop and run at the same time. In that particular case, Java uses what approach we call as the thread-based approach, where it will have multiple threads associated to divide and share the computing load across execution units, and then of course whatever concurrency is required, that is achieved through this. Now with JavaScript, it's slightly different. We do not use a thread-based approach here. So we make use of an event-based approach in a way where we can solve all of the concurrency requirements based on this. So again, this is a very big difference that lies in between Java and JavaScript. And then coming to the last point in a comparison. So we really have to talk about the nature of execution, because what happens is that Java is a standalone programming language, right? So you can write code, no matter where you are, no matter what code you write will be executed on virtual machines across a lot of computers out there. And it has its own niche use cases, as we discussed in the start of this video. And JavaScript is popularly not used just by itself because it needs the basic foundation from HTML. It's going to need other web development languages and frameworks to go with it. For example, if you're writing a website, HTML is going to give you the foundational pillars of your website, CSS will give you the styling, and if you require some sort of functionality, that is where JavaScript comes into the picture, right? So you just cannot have functionality and not have a front end to work with. In that particular case, JavaScript is used alongside multiple other tools, frameworks, and development languages. Now with this, you will have a question saying, okay, so what do I pick, Java or JavaScript? Now, as I told you, both of these are among the top careers to have, so you will be okay if you pick up either of these. But then it depends on your interest and it depends on what you want to do. For example, you can consider Java if you're looking towards Android app development, if you're looking towards big data analytics, or if you want to get into hardware programming, or even if you have certain interest towards the backend or server-side technologies, like Apache, we have Glassfish, and many other things. So this is where, if you're interested in this, you would be considering Java. Now, where would you be considering JavaScript? JavaScript you can definitely think of if you're into front-end development, if you like to provide solutions via back-end development, and of course this calls for full-stack development as well. Not only this, in a world where we're living where almost everything is mobile now, JavaScript is something which is very popular for mobile application development too, and even dynamic SPAD, which you call as single-page app development, which is again a very popular thing today. So what is your requirement? Is it speed? Is it stability? And what is your go-to interests, say, that align with you?
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out. Now let's continue with this session.
First and foremost, the basic question which comes to everyone's mind is, what exactly is Java? Java is a general purpose programming language which is object-oriented, class-based and concurrent, which is mainly designed to have a fewer implementation dependencies as possible. Java, which was called as an oak earlier, which was still being developed. The name oak was used by Gosling after an oak tree that stood outside his office. And basically, it is one of the object-oriented programming language, meaning that it is based on objects that work together to make the programs do their jobs easier. Java is all around us, and the Java code looks like C, C++ or C#, but the code written in those languages will not work in Java in most cases without being changed, right? Now we will get into the next question. What are classes and objects in Java? Classes and objects are basic concepts of object-oriented programming language which revolve around the real-world entities. A class is a user-defined blueprint or a prototype from which the objects are created. In simple words, a class is like an object constructor or a blueprint for creating objects. Class has several variables and methods. For now, we will consider the example of dog, where the dog is considered as an object and the variables are nothing but data members such as breed, size, age, color, etc. Methods are eat, sleep, sit, run and many more. This is all about class. Now we will see what are objects. An object is a self-contained component which consists of state or attributes and behavior or method. In simple words, we can say that object is a real-world entity which has both state and behavior, and it's an instance of a class.
Just a quick info, guys. Test your knowledge of Java by answering this question. In which memory a string is stored? When we create a string using a new operator, A. Stack, B. String memory, C. Heap memory, D. Random storage space. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
For example, we will take pen, which is an object. Its name is Reynolds. Color is white, known as its state, and it is used to write, so writing is its behavior. Let's jump on to the next interesting question which has been asked in every interviews. That is, list the top 10 features of Java. We will see to it one by one. Java is easy to learn, where it can be learnt in a short span of time because it uses English-like syntax and it is concurrent. Java is an open source software where it doesn't require you to pay a penny to write the codes for your applications in Java. Since everyone loves to build the software for free, Java provides it. Java finds its use in real-world applications. So guys, let us discuss some of the technologies that makes use of Java in the real world. Java is used in Android applications, web applications, e-commerce, server applications, scientific technologies, and in many frameworks. Opportunity with high salary. Nowadays, most of them are hunting for the Java professionals. Java programmers are highly in demand and one can earn good salaries in MNCs. It's an object-oriented programming language. Everyone knows it is impossible to write a program without object and class. The concepts of Java are relatable and much easier. This property makes Java a flexible, system modular, and extensible programming language. Java has powerful development tools. Take Java to the peak level. It also offers a high level of debugging assistance to the programmers and makes the coding easier. REPL, that is read eval print loop, and the JShell scripting is making a Java coding very easy where the programmers can write it in a single go. Java has rich APIs, which make Java a successful language. It doesn't have any compatibility issues and it handles wide set of procedures and functions. Also, it provides Java for input-output networking and database connections, that is JDBC. Moving on to the next feature, that is Java is present everywhere. Yes, of course, Java is omnipresent. It is not limited to a single domain, be it a desktop applications, mobile applications, web applications, and many more. Moreover, it's also used in banking, retail, and all will use in one or the other way. So, it's not going out to the market anytime soon. Java is portable and versatile. It's an open source and platform independent where the Java supports the famous tagline that is Aura, that is write once and run anywhere. It helps in dynamic coding and it's highly secured. Java has tons of resources and community support. It is one of the mature programming language that requires lots of resources which are available online, and there are also free and paid online courses. On multiple online forums like Stack Overflow, Quora, Reddit, etc., it will help them to clarify the doubts which results in the growth of community itself. Now we will jump on to our next question. What do you mean by JDK, JRE and JVM? Explain with any one difference. JDK is a software development environment used for developing Java applications and applets. It includes the Java runtime environment, that is JRE, an interpreter or a loader, that is Java, a compiler, that is Java-C, an archiver, jar, a documentation generator, that is Java doc, and other tools needed in Java development. Java Development Kit, in short JDK, is a kit which provides the environment to develop and execute the program. JDK is like a kit or a package which includes two things. One is the development tools, that is to provide an environment to develop your Java program, and one more is JRE to execute your Java program. JRE stands for Java Runtime Environment and may also be written as Java RTE. The Java Runtime Environment provides the minimum requirements for executing a Java application. It consists of a Java virtual machine, core classes, and supporting files. JRE, that is a Java Runtime Environment, is an installation package which provides environment to only run the Java program on your machine. JRE is only used by them who only wants to run the Java programs, that is end users of your system. Coming to Java Virtual Machine, it will convert the bytecode to machine-specific code. It is platform dependent and provides core Java functions like garbage collection, security, memory management, and so on. It's known as virtual because it provides an interface that doesn't depend on machine hardware and other operating systems. That is why it makes Java program write once and run anywhere. Java Virtual Machine, that is JVM, is a very important part of both JDK and JRE because it is contained or inbuilt in both. Whatever Java program you run using JRE or JDK goes into JVM, and JVM is responsible for executing the Java program line by line. Hence, it is also known as interpreter. Coming to the differences, that is JDK versus JRE and JVM, that is JRE and JDK both contain JVM which helps to run the Java program. JVM provides the platform independence. It's also known as the heart for the Java programming language. JRE is used for running the Java programs, whereas JDK provides the development tools which are required to run the Java application. Now we will see the next question, that is why Java is platform independent. Explain how the garbage collection takes place in Java. When we compile the Java program using JavaC, that is Java compiler converts the source code into the bytecode, that is the .class file, and these codes are readable by Java Virtual Machine, and each operating system has its own JVM. JVM is a platform dependent, but because of it, as it provides an interface that doesn't depend on machine hardware and other operating system. Java program is write once and run anywhere. In Java, what happens is that when an object is not referenced anymore, garbage collection takes place and an object is destroyed automatically. For automatic garbage collection, Java calls either system.gc method or runtime.gc method. During garbage collection, the memory used by the object is automatically written or drawn back once all the references to an object are gone. Our next question is, explain why Java is not 100% object-oriented programming language and how it enables high performance. Java is not completely an object-oriented as it supports the primitive data types such as long, byte, int, and so on, which are not objects. In Java, we use the data types such as float, double, byte, int, and so on, which are clearly not object-oriented. Therefore, Java is not considered as 100% object-oriented. Coming to the performance, Java uses just-in-time compiler, that is JIT, to enable the high performance. JIT is used to convert the instructions into the bytecodes. Coming to our next question, that is, what gives Java its write once and run anywhere nature? The bytecode, that is, the Java compiler, converts the Java programs into a class file, that is bytecode, which is the intermediate language between source code and the machine code. This bytecode is not platform specific and can be executed on any computer. For example, it can be written in Windows machine and it can run on Linux machine. Explain the basic structure of Java with an example. Structure of a Java program is the standard format released by language developer to the industry programmer. Sun Microsystems have suggested a structure for the Java programming language for developing the Java applications. Here is an example. The first line says about the package details. A package is nothing but a collection of classes, interfaces, and subpackages. A package is imported by default and this package is known as default package. Coming to the next line, that is class hello, that is nothing but class followed by class name. A class is a keyword used for developing the user-defined data type and every Java program must start with the concept of class. Coming to the class name is nothing but it will represent a Java valid variable name treated as a name of a class and it is case sensitive. Coming to the data members, that is int a, b, where it represents either the instance or static and they will be selected based on the name of the class. Next is the void display, says the user defined method. It represents either instance or static. They are meant for performing the operations either once or each and every time. Coming to public static void main, that is the main method is known as a program driver. It is not returning any value and hence its return type must be void. It executes only once throughout the Java program execution and hence its nature must be static. Main method must be accessed by every Java programmer and hence whose access specifier must be public. Coming to the block of statements, that is system.out.println, where we print the statements. Block of statements represents set of executable statements which are in term calling user-defined methods are containing business logic. Moving on to our next question, that is, what are the advantages of packages in Java? There are various advantages of defining packages in Java. Packages helps in avoiding the name clashes. The package also provides easier access control. We can also have the hidden classes that are not visible outside and it can be used by the package. It is easier to locate the related classes. Now we will see the difference between equal to and dot equals method in Java with an example. The main difference between both of them is that dot equals is a method whereas equal to is an operator. The dot equals method is used for content comparison and equal to is used for address comparison. Here is an example. We will see how we can execute this in an Eclipse IDE. First, we will create a public class test. Next, we will write the main method, that is public static void main string of args. Next, we will create two string objects, namely S1 and S2. Now we will print both of these statements. First, we will use equal to operator. In the next line, we will print with a dot equals method. Now we will see the output. Run as Java application. Now the output comes as, for the first print statement it is showing false and for the second thing it is showing as true. In the above example we are creating two objects, namely S1 and S2. Both S1 and S2 refers to different objects. When we use equal to operator as shown in this line, it is for comparison, then the result is false. as both of them have different addresses in memory. Coming to this thing, that is dot equals method, the result is true. Why? Because it's only comparing the values given in S1 and S2. Now our next question is about OOPS concepts. We will see this one by one with an example. OOPS concepts include inheritance, abstraction, polymorphism and encapsulation. We will see this one by one with an example. The first concept is inheritance, means that one class can extend to another class so that the codes can be reused from one class to another class. Existing class is known as superclass, whereas the derived class is known as subclass. For example, assume that to inherit a class we use the extends keyword. Here, class XYZ is a child class and class ABC is a parent class. The class XYZ is inheriting the properties and methods of ABC class, which is represented as class XYZ extends ABC. Coming to our next concept, that is encapsulation. That means binding of data and code together to protect the data from the outside world. It helps in hiding the details of how an object does something. Assume that it's just an inner layout used in terms of implementation. For example, we will consider the mobile phone where the inner details of how the keypad button and the display screen are connected with each other using circuits. Next concept is abstraction, where it is used for hiding the unwanted data and giving the relevant data. It helps you focus on what the object does instead of how it does it. Assume that it is an outer layout used in terms of design. For example, again we will consider the mobile phone where it has a display screen and keypad button to dial a number. Coming to our last concept, that is polymorphism. Polymorphism nothing but many forms. A single object can refer the superclass or a subclass depending on the reference type, which is called polymorphism. It is nothing but a single action performing in different ways. Polymorphism can be performed by method overloading or method overriding. Any object that verifies more than one is a relationship, then the object is said to be polymorphic in nature. For example, let us consider a class animal and let cat be a subclass of animal. So, any cat is animal. Here, cat satisfies the is a relationship for its own type as well as its superclass animal. What is the differences between method overloading and method overriding in Java? Explain with an example. First, we will see the overloading method. Overloading occurs when two or more methods in one class have the same method name but different parameters. It follows compile time polymorphism. Now we will see the example. Here we have created a class name as dog with a method called bark and we have printed it as hoof. Coming to the overloading method, it will come with the for loop. Again we will print it as hoof. In this overloading example, the toBark method can be invoked by using different parameters. Compiler know they are different because they have different method signature, that is nothing but method name and the method parameter list. Because in the first method, that is public void bark, there is an empty parameter. In the second method with the same name, that is public void bark, it is with the int num. So it is nothing but having different method signature. Coming to our next concept, that is overriding. Overriding means having two methods with the same method name and parameters, that is method signature. One of the method is present in the parent class and other is in child class. Overriding allows a child class to provide a specific implementation of a method that is already provided by its parent class. It follows runtime polymorphism. Here is an example. Here we have created a class called dog and we have extended using that hoon. And the program continues as follows. What happens in the above example is that the dog variable is declared to be dog. During compile time, the compiler checks if the dog class has the bark method. As long as the dog class has the bark method, the code compiles. At runtime, a hoon is created and assigned to dog. The Java virtual machine, that is the JVM, knows that dog is referring to the object owned. So, it calls the back method of owned. This is called as dynamic polymorphism. Now we will see our next question, that is difference between string, string builder and string buffer with an example. String variables are stored in a constant string pool. Once the string references changes the old value that exists in the constant string pool, it cannot be erased. Now we will see the example where in a constant string pool we have assigned the string name, object and the value assigned to the string as book. That is string object equal to book. Assume that the name has changed from book to pen. Now what happens? That is, the older value remains in the pool whereas it has been replaced by the pen. Now we will see what is string buffer. Here string values are stored in stack. If the values are changed, then the new value replaces the older value. The string buffer is synchronized, which is thread safe, and the performance is slower than the string builder. Here we can see the stack with a name called book, that is string buffer name equal to book. Once the name value has been changed to pen, then the book is erased in the stack. This is how the string buffer works. Coming to the string builder, that is, this is same as string buffer except for the string builder which is not threaded safety, means that it is not synchronized. So obviously performance is fast compared to the string buffer. Now we will see our next question, that is explain about public and private access specifiers. Everyone knows methods and instances variables are members. Public members are visible in the same package as well as outside package, that is for other packages. Here you can see the public members of class A is visible to class B, that is within the same package, as well as it is visible to the class C which is in different package. Now we will see what exactly is private access specifier. Private members are visible in the same class only and not for the other classes in the same package as well as classes in the outside packages. We will see this with an example. Here you can notice private members in class A is visible only in that class. It is invisible for class B as well as class C. Now our next question is, what is the difference between abstract class and an interface? Coming to the abstract class, which has a default constructor and it is called whenever the concrete class is instantiated. Whereas interface doesn't have any constructor and it can't be instantiated. Abstract class consists of abstract methods as well as non-abstract methods, whereas in interface abstract methods should alone be declared. Coming to our next difference, that is, the class which extends the abstract class shouldn't require implementing all the methods. Only abstract methods need to be implemented, whereas classes which implement the interface should provide the implementation for all of the methods. Last but not the least difference, that is, abstract class contains instance variables, whereas interface consists of only constants. Now our next question is that what is meant by collections in Java, and we will list some of the operations that are performed by collections in Java. Collections are nothing but a group of objects is known as collections. Collection is a framework that is designed to store the objects and manipulate the design to store the objects. Collections are used to perform the following operations such as searching, sorting, manipulation, insertion, deletion and many more. All the classes and interfaces for collecting are available in the Java util package. Coming to our next question, that is, what is the output of the following program? Here I have created a class name test. Inside the main method I have printed 3 statements. The first statement, that is 10 plus 20 plus Java t point. What happens in the first case is that 10 and 20 are treated as numbers and added to be 30. Now their sum 30 is treated as a string and concatenated with a string Java t point. Therefore the output will be 30 Java t point. Coming to our next print statement, that is Java T point plus 10 plus 20. What happens in the second case is that the string Java T point is concatenated with 10 to be the string Java T point 10, which will then be concatenated with 20 to be Java T point 1020. Same thing happens in the third case. That is, but here the case is multiplication, where the numbers 10 and 20 will be multiplied first, and then the result 200 is treated as a string and concatenated with a string Java T point to produce the output 200 Java T point. Now our next question is, what exactly is multi-threading? What are the two ways of implementing multi-threading in Java? Multi-threading is a programming concept to run the multiple tasks in a concurrent manner within a single program. Threads share the same process stack and running in parallel. It helps in performance improvement of any program. Runnable interface is used in Java for implementing the multi-threaded applications. Java.lang.runnable interface is implemented by a class to support the multi-threading. Multi-threaded applications can be developed in Java in any of the two methodologies. Following are, by using the java.lang.runnable interface, classes implement this interface to enable the multi-threading. There is a run method in this interface which is implemented, and also it can be developed in Java by writing a class that extends java.lang.thread class. Now our next question is, what is thread, and explain the states of thread along with how do you implement thread in Java. A thread helps, facilitates multitasking and multiprocessing within a program. It utilizes CPU effectively and helps improve the performance of the application. Java enables the user to use the multiple threads at a time. It can be run in parallel with other programs without any interruptions. This helps in reducing a time for the process. For example, assume that if a program takes 60 seconds to execute, we can use 6 threads, which will give us the result in 10 seconds. A thread in Java can be in either of the following state: ready, running, waiting, and then dead. First, coming to the ready state, when a thread is created, it is in ready state. Running, a thread currently being executed in the running state. A thread waiting for the another thread to free the certain resources is in waiting state. Last but not the least, that is the dead state. Here, the thread which has gone dead after the execution is in the dead state. Java provides two ways to implement thread in a program. Interface java.lang.runnable has an instance java.lang, a thread which requires a task to execute through an instance. The thread class already implements runnable, so a user can directly override run method by extending the thread class or by implementing the runnable interface. Now we will see a small program for an increment and a decrement operators. Here we have created a class name operator, and inside main we have declared int a equal to 4. In the first print statement, that is x++, what happens in the first case is that here plus plus is nothing but the postfix operator which is used, in which in turn returns the value first and then it increments. Hence its output will remain as 4 itself. Coming to the second print statement, that is plus plus followed by x. But this is not the case in the second print statement, where plus plus operator is in priority and it is prefix. So it increments first and then it returns the value as 5. What happens in the third print statement? Here minus minus represents the decrement operator. In the third case, postfix, that is minus minus operator, is used, in which it returns the value first and then decrements. Hence, its output will be remain as 4 itself. But in the last case, what happens is that minus minus operator is in priority and it's a prefix. So it decrements first and then it returns the value 3, as you can see in the program. What is constructor and how many types of constructors are used in Java? The constructor can be defined as a special type of method that is used to initialize the state of an object. It is invoked when the class is instantiated and the memory is allocated for the object. Every time an object is created using the new keyword, the default constructor of the class is called. The name of the constructor must be similar to the class name, and also the constructor must not have an explicit written type. Based on the parameters passed in the constructors, there are mainly two types of constructors in Java. One is the default constructor and one more is the parameterized constructor. Coming to the default constructor, it is one which does not accept any value. The default constructor is mainly used to initialize the instance variable with the default values. It can also be used for performing some useful task on object creation. A default constructor is invoked implicitly by the compiler if there is no constructor defined in the class. Coming to the parameterized constructor, it is the one which can initialize the instance variables with the given values. In other words, we can say that the constructors which can accept the arguments are called parameterized constructors. Coming to our next question, that is, what are the differences between constructor and method in Java? A constructor is used to initialize the state of an object, whereas method is used to expose the behavior of an object. A constructor must not have any written type, whereas the method must have a written type. The constructor here is invoked implicitly.
Just a quick info, guys. Test your knowledge of Java by answering this question. Which of the following is not a Java feature? A. Dynamic. B. Architecture neutral. C. Use of pointers. D. Object oriented. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Whereas the method is invoked explicitly. The Java compiler provides a default constructor if you don't have any constructor in the class, but in case of method, it is not provided by the compiler in any case. The constructor name must be same as the class name, whereas the method name may or may not be same as the class name. What is exception in Java? Explain with an exception handling keywords. Exception is an error event that can happen during the execution of a program and disrupts its normal flow. Exception can arise from a different kind of situation, such as wrong data entered by the user, hardware failure, network connection failure, and many more. Whenever any error occurs, Java Runtime Environment, that is JRE, tries to handle it. Java Exception Handling Framework is used to handle the runtime errors only. Compile time errors are not handled by Exception Handling Framework. Here, there are mainly 4 keywords used in exception handling. They are throws. Coming to the throw, sometimes we explicitly want to create the exception object and then throw it to halt the normal processing of the program. Throw keyword is used to throw the exception to the runtime to handle it. Next is throws. When we are throwing any checked exception in a method and not handling it, then we need to use the throws keyword in method signature to let the caller program know the exceptions that might be thrown by the method. The caller method might handle these exceptions or propagate it to its caller method using throws keyword. We can provide multiple exceptions in the throws class and it can be used with main method also. Our next keyword is try-catch. We use try-catch block for exception handling in our code. Try is the start of a block and catch is at the end of try block to handle the exceptions. We can have multiple catch blocks with a try and try-catch block can be nested also. Catch block requires a parameter that should be of type exception. Our last but not the least, that is finally keyword. Finally block is optional and can be used only with try-catch block. Since exception halts the process of execution, we might have some resources open that will not get closed. So we can use finally block. Finally block gets executed always whether exception occurs or not. Coming to our next question, that is, how many types of exception can occur in a Java program? There are basically 2 types of exceptions, that is checked and unchecked. Here, an error is considered as an unchecked exception. But according to the Oracle, basically there are 3 types of exception. First one is the checked exception. Checked exceptions are the ones which are checked at compile time. For example, SQL exception, class not found exception, etc. The classes that extend the throwable class except runtime exception and error are known as checked exception. Coming to the second exception, that is unchecked exception. These are the ones which are handled at runtime because they cannot be checked at compile time. The classes that extend runtime exception are known as unchecked exceptions. For example, arithmetic exception, null pointer exception, array index out of bound exceptions, and many more. Coming to the last but not the least, that is error. Error cause the program to exit since they are not recoverable. For example, out of memory error, assertion error, etc. Now we will see some of the programs which is asked in every interviews. Here, the first program is write a simple Java program to print the Fibonacci series using both the recursion and the iteration up to a given number. First of all, Fibonacci series is a series of natural number where the next number is equivalent to the sum of the previous two numbers. Example, fn will be equal to fn minus 1 plus fn minus 2. The first two numbers of Fibonacci series is always 1, 1. In this Java program example, for Fibonacci series, we create a function to calculate the Fibonacci number and then print those numbers on Java console. Another twist in this question is that sometime interviewer asks to write a Java program for Fibonacci numbers using recursion. So it's better you to prepare for both iterative as well as recursive version of Fibonacci number. The one which you can see is the recursive function of Fibonacci series. Here, the system.out.print is printing n1 plus n2 where it is printing 1 and 1. Coming to the second thing, that is where the print Fibonacci has been called, where count minus 2 will check n minus 2 because two numbers are already printed. This is how the recursive function of Fibonacci series works. Coming to the iterative function. Now we will see the iterative function of Fibonacci series. Here we have printed the Fibonacci series. Here it will take the input from the user where it calculates based on the sum of previous two numbers. Here it is printed as int sum of previous two will be num1 plus num2, and then it is assigned the num2 to num1, and after that the sum of previous two numbers will be assigned to num2. This is how the Fibonacci series for both the recursion as well as iteration works. Now we will see the program to check whether the given number is prime or not. A prime number is a number which is divisible by only two numbers, 1 and itself. So if any number is divisible by any other number, it is not a prime number. Here is a program and the program is continued as follows. What happens here is when you run the program, the output will be 29 is a prime number. What happens in the above program is that for loop is used to determine if the given number is prime or not. We only have to loop through 2 to half of the number because no number is divisible by more than its half. Inside the for loop, we check if the number is divisible by any number in the given range, that is 2 to num by 2. If it is divisible, then the flag is set to true and we break out of the loop. This determines the number is not a prime number. If number isn't divisible by any number, flag is false and number is a prime number. This is how the program of prime number checking works. Here is a Java program to check whether the given string is palindrome or not. Enter any string as input. Now we use the for loops and the if-else conditions along with the equals ignore case method to conclude whether the enter string is a palindrome or not. Here is the source code for a Java program to check whether a string is palindrome or not. The Java program is successfully compiled and run on the system. Assume that we are entering the string input as mom. If we reverse the string also, we will get the same. This is what palindrome is. Now we will see the main program where it has been asked by many of the IT companies, that is, write a Java program to find the factorial of a number. Before going through the program, let us understand what factorial is. Factorial of a number n is denoted as n factorial and the value of n factorial is 1 into 2 into 3 up to n minus 1 into n. So let us see the program. Here what happens is that we will find the factorial of a number. Here assume that you are giving the input of 4. It now checks for the 4 factorial, that is nothing but n factorial. Here the n is 4, so it is 4 factorial. And then the output as 4 into 3 into 2 into 1 is equal to 24. So the output will be 24. What are the differences between throw and throws keyword in Java? The throw keyword is used to throw an exception explicitly, whereas the throws keyword is used to declare an exception. The checked exceptions cannot be propagated with throw only, whereas checked exception can be propagated with throws. The throw keyword is followed by an instance, whereas throws keyword is followed by class. The throw keyword is used within the method. The throws keyword is used with the method signature. You cannot throw the multiple exceptions, but in case of throws, you can declare multiple exceptions. For example, public void method throws IO exception, SQL exception. Now we will see a small program for throws keyword. Here what happens is that try is going to execute it as throw 90 and the catch, for example, it will caught the exception. Here, it supports the incompatible types where the int cannot be converted to throwable. In Java, the throwable objects can only be thrown. If we try to throw an integer object, the compiler will show an error since we cannot throw the basic data type from a block of code.
Okay guys, if you're looking for an end-to-end Java training, Intellipaat provides a complete Java training with certification, and those details are available in the description box below and you can go check it out.
So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Hope you all enjoyed the session. Thanks for watching.